Good morning, good afternoon, good evening. Can everyone hear me okay in the room? Awesome. All right. We are coming to you live from our Boston headquarters. This is the 2024 Formlabs User Summit. I am super excited. I'm really grateful that everyone is here. We have some customers here in the crowd with us in Boston, like I said, and thousands more joining globally, virtually from hundreds of countries. All of you share something in common: engineers, creators, designers, lovers of 3D printing, and this is going to be an amazing day. To introduce myself, I am Mike Baker. I'm the head of brand and communications here at Formlabs. I'll be your MC for the day. You'll see me a few times throughout the day coming in to introduce different sessions and to kind of fill in some gaps and to orient everyone. A quick bit of housekeeping, and then we're going to get right into it. So mostly this is for the people online. If you're joining on YouTube, we are offering non-English captions in 7 different languages. Just check the chat for those links. It should be very simple to set those up. If you do have questions, put them in the chat, either about logistics and the captions or questions throughout the day. We have Formlabs staff managing those channels as well. And if you need an agenda, that is also in the chat. That should have a minute-by-minute breakdown of what's coming from the main stage here in Boston. I think that's it for the preamble, so I'm going to basically get into it, and I'm going to start with why are we here, right? Why are we all joining this today? What's the purpose? And I'll kind of kick it off with something I like to do, which is a quote about cookbooks. I think that is a great way to do it. So someone told me several years ago that there are 2 types of cookbooks, and it's really stuck with me for a long time. There are informational cookbooks and inspirational cookbooks. There are cookbooks you go for recipes, how to make lasagna, how to make shepherd's pie, something really specific. And there are cookbooks that expand how you think about cooking, expose you to new types of cooking. My hope for today is that this program will leave everyone here with some inspiration and some information. And I really think we built a program that will do that. I'm really excited about it. There are definitely very tactical sessions, things that will introduce you to new Formlabs products like our Form 4 and 4L that just came out this year. There are sessions that will improve your workflows and give you tips and tricks for best practices. And there are ultimately just sessions that will help you get better parts, which I think is what a lot of people want here. But on the other side, there are also plenty of sessions that are more for the inspirational side of things, things that will expand what you are thinking about in how you're using Formlabs products. You will hear from other users, your peers, about what they are doing in completely different industries. You will learn about some of our more technical materials and really push the boundaries there. And you'll learn, what I'm really excited for is our CEO Max will talk this afternoon about the brand new developer platform. So even more ways that we can change 3D printing from a really kind of broad view. And at the end of the day, there's another special session that I'm really excited for. This is actually an online exclusive, so everyone in the room, we will send you the link afterwards. But at the very end of the day, we're going to premiere a great video with Shane Whiten. A lot of you might know him from his YouTube channel, Stuff Made Here. What you may not know is that he was actually a Formlabs employee, and he led the design of the Form 3. So he is going to join Alec Rudd, who designed the Form 4, and they are going to go deep into a Form 4. It's a really, really awesome session. But there's a whole day before then, so don't pin your hopes to the end of the day. There's so much great sessions in between. And the session that I'm about to introduce is also one of my favorites. In about a second, Max, our CEO, is going to get on here with Tom Stanton to do a fireside chat. Tom is an amazing YouTuber, an engineer. He builds really great products, and he uses 3D printing in a lot of ways. So they're going to talk about some of those projects, how he got into YouTube, and I think that's it. So I'm going to roll a video just in case anyone doesn't know about Tom that will show some highlights of things that he's done. And then right after that, he and Max will take the stage. Thank you so much. I'm really excited for today, and I can't wait for everyone to learn so much. Thank you.
right. I'm really excited to be here with Tom. As you saw from that video, he is an awesome engineer and social media creator, and he gets to work with both 3D printing and airplanes, which are two things I really love. So I'm actually a little bit jealous that you get to do that all day long. I think that Tom is part of this new wave of really amazing content being posted on the internet in this kind of fun engineering and educational genre, and I think this is really incredible. Stuff like this, I think, didn't really exist 10 years ago, and it's amazing now that it does. The view counts are crazy. You typically get more than 1 million views, right, on most of your videos, so it's like approaching the scale of popular mass media, but it's showing people useful skills, and I don't know if you think about it as primarily educational, but I think the fact that it's entertaining and useful is amazing, and you should be proud of getting to do stuff, make stuff like that for the world.
Thank you. Yeah, I mean, it's interesting the way you put it as a wave of online. I guess it is entertainment through engineering, and I think a lot of it is grown from the 3D printing aspect of it, being able to make almost any part you can think of at home makes it far more accessible for making these projects for entertaining videos. I suppose back in the day, the equivalent would be shows like Mythbusters, where they would require a lot more tools and resources to build. I mean, their projects were on a much larger scale, but being able to design and 3D print stuff essentially in my bedroom has made it far easier to make these projects to upload to YouTube.
Yeah, absolutely. Between YouTube itself and 3D printing, being able to make content like that is way more democratized, and now one-man operation can do it. So maybe you could tell us a bit about how you got started in this. You studied as an aerospace engineer, but then I guess ended up going a bit of a different path. How did that happen?
Yeah, so I've always been interested in like hands-on making things, basically what I do now. But when I went to study at university, it was a lot more theory-based projects, which I found difficult to start with. But in hindsight, it taught me a lot of the essentials, you know, how to properly design something in CAD. And whilst I was at university, I bought my first 3D printer, which was a very basic FDM machine. And I experimented with 3D printing plain aerofoils, wing sections, and what would be the best way to make them as light as possible and still structurally strong, like the wing ribs and the outer skin and everything like that. And I uploaded, it was probably like a 10-minute video onto YouTube about my experiments with it, and it gained 60,000 views in the first month, which at the time was really impressive. I think I made about $100 from it. And considering I was at the time just working part-time while studying, that was about equivalent to 2 days of work. So I thought that was, you know, there was some potential there.
But were you thinking about it as like this could be a job?
I thought it would be the path to a job of some sort. I didn't really know where it was going to go, to be honest.
And what point did you realize, wow, I could maybe just do this?
That took a little while, yeah. It was more the convincing my parents that I could do that than whether I could do it or not. Yeah, so after university, a lot of my friends did gap year and they traveled around the world. And I convinced my parents that I would do YouTube instead. And they were a bit hesitant at first, but my dad gave me 1 year to make it work. So that was a busy year, yeah.
And you made it work after that, that 1 year?
Yeah, fortunately, yeah.
And how did you figure out that, like, you thought you wanted to make real airplanes and work in aerospace, that was your intended path, right? Like, why didn't you go that way?
Well, I was interested in model aircraft from a young age, and I thought building the bigger planes was a similar path or a similar way of building, but it's a lot more, obviously a lot more strict because there's safety rules and everything like that, and costs, things to be taken into consideration. And I just wanted to just make things like quickly and see something fly, and yeah.
The time scale from actually designing and making and seeing an airplane fly is like 15 years these days, so you're just too impatient for that, I guess.
Yeah, and starting out in the aerospace industry, I won't be designing the actual whole plane to start with. You'd be designing parts towards planes, and then you work your way up. Whereas I just wanted to design experimental aircraft. And that's not really an easy area to go into.
And so you had that first hit with making printing airfoils, and how did you start to figure out what content people want to see or what you want to make? How did that evolve over time?
A lot of the time, it was just things that I wanted to make anyway, and just hoped that other people would find it interesting. It has evolved a bit since then. I have to think a lot more about how this will perform on YouTube. I have to get a certain amount of views and things, which does change the engineering behind it. But I think a lot of the time it's projects that engineers would like to do after work, in their spare time. If they had the time and the printers to do these projects. I get quite a few comments saying, oh, I had this idea a few years ago, but just didn't have the time to do it. So I think that sort of fulfills a thing in the back of engineers' minds.
So you're saying you get to make the things that people dream about making, but
in their
can't
spare
do
time.
themselves.
Yeah.
So they get to.
Well, they can do it. It just takes more time when you have a full-time job.
Yeah.
Yeah.
But they kind of get to have their kicks vicariously through you.
Yeah, hopefully, yeah.
Yeah. Nice. What are some of your favorite projects that you've built?
I've got a few favorite. I think one of my most favorite was a plane that was powered by compressed air. Back in, I think it was in the 90s, Air Hogs released a plane that you pump up, then you spin the engine and throw it. And I lost mine on the first flight, so I basically wanted that back. And I spent about 5 years, not continuously, but over time, designing my own compressed air engines and then the plane as well, so that I could have my own one in 2023, I think it was, yeah.
And what was, why did it take so long? What was challenging about it?
A lot of it was the printing technology that I had. I started out with an FDM printer, so I printed the engine out of ABS and then acetone smoothed it. But it was very hard to get accurate parts. Then I used an FDM printer with PLA plastic, and the layer lines were a bit of an issue with the cylinders and pistons. And then the latest engine was printed on the Form 3 because the resin parts are completely airtight, smooth as well for the piston and cylinder. And that's where the performance gains were really made.
I think we have a photo of that one. Should we flip that? Do we have a... You got the clicker there, Mike?
I think
that's the next one. Yeah, there's the SLA printed air engine. If you guys haven't seen any of this content, definitely check some of it out. It's really, really fun and shows you a lot of what you can do with tools like this. So you were saying having access to the tools, you talked about that a couple times, like that being able to do content like this in general depends on accessible 3D printing tools, and then you've been able to advance what you can do by getting to better tools. That's really interesting. You're currently working on adding another tool that you build yourself to your...
Yeah, I'm currently building a CNC mill for my garage, but I think 3D printing is still going to be the main manufacturing technique.
And what's so great about 3D printing? Why is it the main one?
I mean, for example, with this engine, it would be very difficult to manufacture in other ways, at least at the small scale that I'm doing. For example, the whole cylinder and cylinder head is all one part, and to machine those cavities would be quite difficult. You can maybe cast it, but then you need to machine it again afterwards. And then it's not really visible in this image, but on top of the piston, there's a very small flexible seal. And that was made with 3D printing a resin mold, and then pouring silicon into that to make the seal. So the fact that the whole thing was basically made on one machine is really fascinating to me.
Yeah, and I guess, so you're talking about the geometry flexibility, but also the speed of iteration, I assume, something like,
Yeah.
how many times do you think you've printed this engine?
A lot, yeah. I've got a box probably about this big, just full of them, and the engine isn't very big, it's only about that big.
Yeah.
So probably 30 times.
I think that's such a big deal of lowering the barrier to try something, because you can do it. You could have done it with less iterations, right? But it might have required more careful planning, and might have been more like building a real airplane in terms of
exactly.
time scale. Yeah, so lowering that barrier to try things, I think it's really, really important. Maybe we should click through a couple of these other photos. This is all things that you've done with SLA. Maybe you can explain what's this one here.
So this is an electromagnetic launcher. It uses a similar concept to scale X straight cars, where these copper brushes would run along metal pickups that would then attract the coil to the magnets and fire it along the rail. This was quite tricky to make because the magnets on the side of the rail attract to each other, so each side wants to bend in quite strong. So the best material I could figure out was with printing it was in resin. I tried printing it in FDM, but it would bend a bit too much.
Mm-hmm.
And also when I think it was in the introduction video, when it fires down the rail, the copper pickups, they spark as it switches the contacts. And it looks really cool when it lights up the clear prints.
Absolutely, you see it glowing down the line.
Yeah, exactly. Yeah.
Nice. What else do we have? That's one of the parts.
Yeah,
from
that was
the,
one of the parts, yeah.
What's
So
this?
This was an interesting one. The copper part in the center is fixed to the wheel, and the magnets around the outside and the sprocket, they rotate free with a chain. So basically the chain is only coupled to the wheel via the magnets acting on the copper. But trying to make this is actually a 3D printed sprocket out of rigid 4K. It had to fit within a 25 millimeter, or this whole thing had to fit within a 25 millimeter width, which is about 1 inch. And the bike wheel had I don't know what thread it was. It was like a 32 millimeter 1/4 inch thread or something. It was like an imperial and metric mixed together. But I was able to measure that and then 3D print it in a couple of pieces, which made everything very easy to assemble.
And so that sprocket is printed and worked. I think you broke one or two in the video, but you got it working.
Yeah, one of the ones I printed it a bit too thin, so I bought a slightly stronger chain, which allowed me to, instead of running a 2 millimeter sprocket, it was a 3 millimeter, and that held up fine.
But that's pretty awesome to see because it's a polymer part replacing what's typically a steel part.
Yeah.
Very cool. I think we have another. What's this?
This is an air-powered turbine, and then I used essentially a geared flywheel to measure the power output of it. So the turbine would accelerate the flywheel up to high RPM, and depending on the acceleration of the flywheel, I could determine the torque and the power output of the turbine.
But why were you making the turbine? It was for like a RC car, right?
Yeah,
Air-powered.
Radio-controlled car, yeah.
Nice.
And it's I printed a lot of turbines, yeah. But it was so easy just to adjust the angle of the blades. You can see sort of through the side of the turbine, just to adjust the angle and see what power difference it makes at different RPMs.
To optimize for efficiency
Yeah.
or something like that, yeah. Yeah, I think wherever there's fluid flow is a great place for 3D printing because you've got unusual complex surfaces and ones that need to be fine-tuned where you can maybe simulate it, but testing, ultimately you got to test it and iterate. Very cool. Do we have, is there one more in the deck or did we?
This was
this.
another turbine, which would be basically impossible to manufacture in another way. It's very thin channels that go from the center of the turbine out to the exterior. It may be possible in multiple parts, but in a single part.
What are you excited about working on in the future?
I'm currently working on another bike project. The black frame bike, which I use on a lot of my projects, is sort of my test dummy bike. But I'm trying to make a bike with a motor that it does regenerative braking and then powering the bike as well using supercapacitors. But it needs to be a custom plastic motor. It can't have any metal in it because when you have magnets spinning past the metal, even a non-ferrous metal, even like copper or aluminium, it applies a drag because of the eddy currents induced. So I basically need to make a fully plastic motor, apart from copper windings. There has to be copper windings.
Nice.
But that's the next step.
And it's with a supercapacitor rather than a battery, so it's kind of like doesn't power you the whole way, but it just helps you get up and down hills or something like that.
Yeah. So the idea is that it can be ridden like a normal bike, and there's no resistance on the motor. And then when you go down a hill, or if you need to slow down, you can charge up the capacitors, and then use that to get going again.
Do you, with projects like that, do you hope that they might turn into something useful, into a product, or like it might inspire someone to take it further, or where do you think it can go?
I think
I would kind of interested in that product because I need to not ride an electric bike because it's the only exercise I get on a bike, but I would feel okay with if it was just like, average.
just used up energy.
If I was putting all the average power in, then.
Yeah, I think there are some projects which could be adapted to product, but a lot of the projects, it's just to see if something will work. I mean, a bike is very hard to improve on because chains are so efficient nowadays, and you have electric bikes if you don't want to pedal that much. But I think a lot of the projects, they don't have a financial incentive behind them. It's more of the entertainment value. So a lot of the bike projects, in the introduction video, there was I stuck a 10-pound flywheel steel disc in a bike, so that it does a similar thing. When I go to slow down, it will speed up the flywheel, and then when I need to get going again, it will then use that energy to then accelerate. Completely useless on a regular bike because it doubles the weight of your bike. But it's just something that's quite cool to explain the physics behind. A bit of energy recovery.
Do you see people picking up some of your ideas and taking them further, or?
I'm not sure, to be honest. Maybe.
What is a good like? How do you know if what's your measure for is the content successful? Like, there's view count, but like, what's the what feels the best after you put out a video and you see kind of the response? Like,
I think it does always come down to the view count. That's a big portion of it. But some projects I've built where I'm really proud of it, I absolutely love the project, and it performs poorly on YouTube. Then there's some projects which I have built in a week, and I think, oh, that's not going to do well, and then it goes huge. So it's very hard to gauge what's going to perform well and what isn't. I spoke briefly to you previously. I used to get lots of emails about lots of people wanted me to develop a drone that could fly silently with absolutely no noise. And I thought that's a really complex problem to solve, and it doesn't really seem like it has that much entertainment factor.
Because quiet is not entertaining.
Yeah, it's just a quiet drone. You know, you just turn the volume down on the microphone. You know, but since then, Mark Rober's done a few videos, and there's been quite a few videos on making a quiet drone, because that does actually have a product viability behind it. So yeah, that's an interesting example I found.
I think it's a great project and challenging, and probably needs SLA to do well.
Yeah.
You probably need really nice, smooth surfaces, I assume. Cool. Let me just check my notes. Oh, of course, most important question. What would you improve about 3D printing? What do you want out of our printers or any printers, or where do you want to see things go?
I think, well, reliability and speed have all been, they've all been improved upon. They're all really good. I mean, the fact that you can chuck any design into Preform and just have it in a couple of hours is really impressive. I think the only thing that could be improved is, which you're obviously working on, is materials. Because once you can do any material, I know that's probably an unrealistic goal, like at least on one machine. But if you can do any material on a 3D printer, and you just have one machine in the workshop, and you just have a part, and you just click go, and then it's made. I think that will be the dream in the future.
Definitely.
I know realistically that's...
Yeah, any material is tough, but
Yeah.
but better and better materials, and like as you showed with the rigid 4K sprocket, that like you can, just as the materials get better, you can continuously displace other parts, even if it's not exactly the right material. Yeah, we that's usually my answer as well for like the single biggest unlock in 3D printing would be significantly better materials.
But like you have the investment casting stuff out on display out there, so you can make metal parts using the resin prints.
It's more than, it's a 3D printing and then sort of extensive manual process. It starts to lose the, I had an idea and made a digital design and printed it, got it out. You said, it sounds like you said you're satisfied with speed and reliability, but like, what if it was even faster?
I find my designing needs to speed up as well then.
The CAD now takes longer than printing,
Yeah.
even for relatively small things.
There's a bit of management to do with, I'll look at what part needs to be printed first, and I'll stick that on print and then work on the next part. So then if the printing is 20 minutes or something, I don't have time to design the next part. And then there's other processes that need to speed up.
Nice. And what else can improve about the workflow? Just like anything about saving time or make it easier to use, or is that all working well for you?
I think it's all pretty good. I think the only
You're
other...
easier to please than some of our customers.
Maybe. I think the only other aspect is to have, which I don't know how you would do, but have, a lot of the time you have to design stuff depending on how it's going to be supported, or how the resin will drain out of it, or anything like that, and having more freedom with that, so you don't have to design for manufacture, you just design for the design, that aspect of it.
Absolutely. Yeah, we just released the drain hole feature in Preform, which helps to address that issue, where you can, still might need to consider it, but at least you can add the drain hole sort of after CAD, after you figured out the orientation. But getting to that dream of like, you can throw any 3D geometry at it and get it out, that's the goal. But you mainly use FDM and SLA. You haven't used SLS yet, have you?
I haven't yet, no.
Yeah,
No.
the SLS is pretty nice. No support structures. Still got to get the powder out, but gives you even more geometry freedom. So you gotta try that out.
Yeah, definitely.
Cool. What else want to cover? Where do the ideas come from? Do you have like just like a big list of things you want to work on, or how does it? Yeah.
I used to create lists, but I find I like to just make things based on what I want to make at the time. A lot of the time I'll take two things and combine them. So one of my early videos was during the time when electric skateboards were quite popular, and you could buy DIY electric skateboard kits. I wasn't very good at riding a skateboard, but I like bikes, so I thought if I'd take one of those kits and put it on a bike, it's a relatively easy project. There were some issues because a bike wheel is far larger than a skateboard wheel, so gear ratios were a problem. But with some 3D printed pulleys and some motor mounts, I was able to make an electric bike using a skateboard kit, and that performed really well on YouTube because no one else had done it at the time. So it's projects like that where you take two ideas and merge them,
Remix them
in a strange way.
Yeah, well, that's I think how a lot of invention happens in the world, remixing ideas. What about like comments or things people ask you for, or is there any interesting input that comes from there?
I get a lot of suggestions about how to do things better.
Suggestions?
Yeah, but the thing people don't realize is that the whole point of prototyping is you learn from the prototype to make something better. So
of course they can tell you after you've done
after
this
I've
thing.
made it,
Yes.
you can tell me how to do it better. So, it's of course the second prototype should be better than the first one, but I didn't know that before.
People on the internet are so helpful with their suggestions.
But no, the comments in general are fine. Yeah, no, I normally learn quite a lot from them because a lot of them are engineers that watch it in their spare time, so it's good to read the suggestions.
Cool. Well, I think we are coming to the end of our time, and Tom will be around for the rest of the day. Come and chat with him about his projects. And thank you so much for joining us.
Thank you for having me.
All right, thank you, Max and Tom. Let's give another round of applause for Tom. That was so good. Tom, I fully recommend everyone, if you're not already subscribed to his channel, Tom Stanton Engineering on YouTube. It is one of my favorite watches. I don't think Max has a YouTube channel, but if he does, you can subscribe to his too. Next up is actually one of my favorite sessions of the day. This is something we've been doing since the very first User Summit in 2017. It's a series of vignettes from customers across lots of different industries. So when I talked about inspiration at the beginning, I think often that comes from people and organizations that are slightly adjacent to what you're doing or totally different and can kind of bring ideas that you might not have thought of or considered. And so this is really one of the parts of the day that I think can do that. We're going to kind of rapid fire through a lot of different users. So I'll just kind of give a quick agenda for this. We'll have Radio Flyer up there to talk about engineering and product design. We'll have someone from Brose for the auto manufacturing, Aurora Digital Technology Center, Northwell Health, to really round out all the different industries and people who are using Formlabs products to change the way they do business. So I think I will get out of the way. Let's give a big hand for our first speaker from Radio Flyer.
So I'm Ago. I'm from Radio Flyer. Let's go to the next slide. There we go. Hey, I'm Ago. I'm from Radio Flyer. I'm a product development engineer, and I'm really excited to share a little bit about what Radio Flyer does and what I do for Radio Flyer and how we integrate 3D printing into our workflow. So Radio Flyer is Chicago-based. We've been family-owned since 1917. And in addition to housing the world's largest wagon, our headquarters in Chicago houses all of our engineering, all of our design, all of our prototyping. So it's all under one roof, and that roof includes our Formlabs machines. So you may know Radio Flyer as the Little Red Wagon Company, but we do a lot more than that today. We have thrilling go-karts, our core line of wagons, our premium scooters and trikes, and most recently we launched our e-bikes, which we'll talk to Tom about a little bit later. But all of this is with a focus on serving the whole family while staying true to our heritage. So my role is, like I said, as a product development engineer. I'm responsible for taking projects from the concept stage through development and through production. So for us, all of our projects begin as a collaboration between our designers, our design researchers, and our engineers. And we very quickly iterate with rough form studies and benchtop prototypes. And then as projects are green-lit, we're building more high fidelity, iterating quickly, ideating on feature set, and really just drilling down on what is the product and how is it going to serve a consumer need. And again, 3D printing very deeply woven through that process. And even as we go further down this process, we build what we call roadshow prototypes, which are fully production intent. They look the part, they feel the part, they function the part. 3D prints that we show to our retailers to gain buy-in for store placement. And these are really powerful prototypes. So really excited to use the Formlabs machines in that process. And in addition to my roles as an engineer, I also serve as our internal advocate and ambassador for 3D printing. So I'm responsible for sourcing and bringing on board new machines, new materials, new technologies, and sharing that with the team and educating the team. So in the case of Fuse, we did that by sourcing that machine collaborating with Formlabs and really understanding how the materials that Fuse could produce lined up with our production materials. And what that did for us is it helped build confidence with our team to understand, here's the aesthetic capabilities of this machine, here's how durable the parts are, here's what we can do with it, and all the capabilities of that machine. And that really sold the machine in for us and was really impactful. So go back one. So I've got a couple examples here of what we've done with our Formlabs machines and how that process was really strengthened by 3D printing. So the first is our Flyer glider scooters. These are our premium lean to steer scooters. And what's really unique about these is they break down into a really small box for sustainability reasons. So what that means is it was really easy to print these all in one go on our Formlabs machines. So the products you see there are fully 3D printed scooters. They were fully operational. We did QA testing with it, we did treadmill testing, we did Flyer take-home testing, and learned a lot before we had to invest in tooling. So that was incredibly powerful and something we could not necessarily have done in-house before without engaging with a CNC shop or external out-of-house resource. The second one in the middle is a engineering development for our first pneumatic air-tired stroller wagon. So we used TUF 1500 to print that rim for the first time and validate it against our internal overinflation testing. We did ride testing with it, treadmill testing, and that really, again, helped us build that confidence we needed before we opened production tooling. And again, really impactful, very powerful use of 3D printing in our workflow. And then the third one is one of those design studies that I talked about where we were revisiting the shape, the size, the form of our footrests on our stroller trikes. So we went to our kind of daycare partner and tested dozens of footrests, shapes, and sizes with different kids of different ages to really drill down on what was going to be the best for that user. So that was really interesting and a great use case of very quick iterations on form to execute. So that's all I have for you today. If any of you are interested in learning more about any of those projects or how we use it in our workflow, please come up and talk to me. I love talking about my work. So yeah, thank you all, and off to the next presenter.
Yeah, hello everybody. First of all, thank you for having me. Great event. I'm so happy that this event is actually in person, so I don't run into that problem of like, can you see my screen? Do I have unmuted myself? So, yeah. Quickly to my person, my name is Matthias Schulz. I do work for Brose. Brose is a large family-owned global automotive supplier and e-bike supplier. So, yeah. Yeah, I do work for Brose since 2008, so you guys don't have to do the math, right? At this point, I'm bleeding Brose red, right? I do work in the seat prototype division. This is also where we host additive technology for our North America region, and we have 2 headquarters for additive technology. I will elaborate a little bit later to that. Yeah, to the automotive industry, right? You guys see it in the media, right? We're redefining ourselves right now. New means basically we have EV cars coming in more and more. There are new OEMs coming into the market. So all those really like leverage the development times, right? So our struggles right now that we face is that we have to reduce the development times drastically, right? Therefore, additive technology is truly like a game changer for us, right? In many sort of shapes of ways. So. Yeah, what you can see over here on the screen actually is we definitely leverage like all different technologies on additive technology. We do use parts for serial production. Like on this side over here, you can see like a climate compressor that we print for serial production, or kinematic levers out of metal, right? But we certainly do as well like combinations out of those, right? Which is like a motor connector over here that you can see, which is SLS printed, right? And then of course we use SLA technology as well. Yeah, for us very important is that we find ways to combine those technologies and make them more reliable for serial production. So we really wanted to get out of this one piece or prototype builds, right? Those are very important for us certainly, but serial production is really like where we see the most gains, right? Yeah, I do have later another speech where I wanted to get a little bit more in detail, especially on what are the problems that we face getting there, right? And how did we overcome those, right? I think if we work together as a community, it helps all of us, right? So yeah, see this video more as like a teaser for the next one coming up, right? Yeah, I love talking, so yeah, feel free to approach me, right? There's a QR code. Usually everybody tells you get your phone away. I'm asking you now to get it out there, scan that code, right? In case you want to connect, right? Feel free. And then yeah, we can chat a little bit, or you listen to the presentation later, right? Yeah, thank you very much.
Hello, everyone. Great to be here today. My name is Milos Markovic. I'm Director of CAD/CAM and Implantology at Aurora Digital Technology Center in Wappingers Falls, New York. Let's see. There we go. Oh, there we go. Okay, let's go back. So we're a large dental manufacturer. So what we do is we manufacture dental prostheses for laboratories and dentists across the United States. And so we have about 27 employees. We're rapidly growing. Our goal is to be the new Amazon of dentistry. We produce all of our restoratives in 3 to 5 days, and it's a very competitive market. For a little bit of context is we utilize, for years, we've utilized CNC milling to sort of like bridge that gap in manufacturing. Dentistry was a very antiquated industry, if you want to think of it in those terms, especially dental manufacturing for many, many decades. We used to rely on things like physical impressions. They used to be a compound that would go in a patient's mouth to capture the data. Then we would have to utilize stones. They used to have a lot of inherent inaccuracies with expansion and contraction. It used to be a very messy process. We used to have people grinding all the time. We cast metal using centrifugal forces, using the lost wax casting techniques, burnout ovens, a lot of hand pieces grinding, dust being everywhere. And so it wasn't up until 12 years ago that the industry started to change, where instead of taking all these physical impressions, we started to take intraoral scans. And those scans allowed us to start to digitize dentistry, really change the industry as a whole. Exceptional accuracy and redundancy that we have from digital scanning, now we were able to think a little differently about how we're going to produce our parts. And so 3D printing wasn't really active at the time. We're talking about 10, 12 years ago, but CNC was really starting to ramp up. However, there were a lot of limitations within CNC milling. And so as soon as 3D printing came onto the market, we jumped in right away. I was a Form 1 Plus user, a Form 2, a Form 3B, and today we're proud to say that we're using 4 and 4L in a very significant way. So we were able, this is our print room, this is our print shop. As you can see, we utilize printers from all different companies. We're pretty agnostic when it comes to brands. We use what works. And for years, we keep trying out different brands, but we keep coming back to Formlabs. And there's a reason for that. It allowed the company as a whole evolved in terms of materials, in terms of accuracy, in terms of reliability. And so the 4L was really what made a difference. And we've been using it for a while and doing some amazing work. So that's our print shop. We have a command station. We kind of like send all different jobs to different printers. They all have different specialties. But this unit has been the most versatile for us. And instead of seeing that messy room with lots of plaster and lots of dust and total chaos, this is our station now. We have a giant build platform, which in the dental industry is a big deal. We turn a huge volume of models. We're talking hundreds and hundreds of cases every day. So we really need a machine that can produce large volumes reliably and consistently. Speed is important, but we would rather have that consistency and accuracy that we're actually getting right now for the 4L. So here we can set up to 30 different models in one run, and especially with the gray resin, we're done within 20 minutes. It's really exceptional. So this allowed us to change the dental industry that used to rely on that accuracy, you see on the left, with lots of porosities, bubbles, expansion, that ranges anywhere from 50 to 140 microns, which is just not acceptable. Dentistry is a very precise industry. We deal with very small tolerances, to getting something like this, a nice, crisp, precision model resin that we're able to make out all the finest details, and we're able to replicate over and over and over again. In implant restorative dentistry, we deal, like I said, very small tolerances, with usually 0.01 millimeters. That's the space that we work with. Here you can see we try to bridge some of that gap with CNC milling. But again, the CNC mills have a lot of limitations with how many degrees a certain arm can move. XYZ axis have very definitive limitations. And so 3D printing allows us to bridge that gap and very quickly execute some of the planning that we do. Just to finish off, I want to give you an example of how we actually change patients' lives. This was a patient that had severe tooth loss. There was implant placement right there. So she really needed to see what she can look like. And this used to take many days and many weeks to be able to draft, to create a product, usually polymethyl methacrylate on a CNC mill, a lot of CAD design, or a lot of manual manufacturing, to just give her an example of a temporary restoration that she could go home with and a prototype that we can verify before the final restorative. Now, she can come in, she gets scanned, and we do a quick CAD design. You can see right there on the left, move all the screw channels, and just within an hour, she can get a prototype of her future restorative, and the best part about it, she can go with it to her home, and she can wear it for several weeks and really give us the ability to like change her life on the fly. So this is really the beauty of 3D printed technology, what it has done to dentistry today. It really allowed us to change people's lives in a very significant way using reliable and consistent 3D printing technology that we get from Formlabs. And so if you have any other questions about dentistry, and just like my other colleagues, I like talking about my work as well, come over and we can talk more about it. Thank you so much.
Good morning, everybody. My name is Todd Goldstein. I work for a health system in New York called Northwell Health. We go from Staten Island to the Hamptons, up now until Connecticut. It's like soon to be 30 hospitals, I don't know, 100,000 employees, pretty large place. And I run the single 3D printing lab that we have for the whole health system. So we get to print anatomical models, cutting guides, we do some dental work, which you'll see, and we also help prototype multiple different devices that our doctors come up with, whether it's they come in with something on a piece of paper. We had one doctor who comes and whittled something out of wood in his garage and said, hey, can you make this into a medical device? And now we've created it and it's being licensed out. So we go lots of different areas that we're operating in. We couldn't do it without 3D printing, and I wouldn't have a job without 3D printing, so thank you, Max. But I'll show, so for example, some of the things that we're doing, no way you're gonna mill this out. So this is a patient that had these are zygomatic implants, so this would actually merge with the previous speaker's prosthetics that they're making for dentistry. We didn't plan this, and there's no business being done here, but this is a doctor training on a model. We're able to make the patient multiple times. They can train the residents, the medical students, whoever wants can actually practice on the case before they actually go into the operating room. And so these are called zygomatic implants, and they can mount dentures to it. And so you have a way to actually train ahead of time, which you wouldn't be able to do this unless maybe you want to use Cadaver Lab or some sort of saw bone models, and then they're going to be different than what you're actually seeing. So it's a nice way to practice and train on the surgeries. And for me, when I started doing this, I feel like a dinosaur now. We started with 2016 doing these types of work where the focus would turn from the training model to the actual patient. It would obviously they were working on when I say patient, I mean like a sawbone or something, not an actual person in the operating room. But the focus would change from the computer screen to the sawbones to the actual 3D model, and then all of the clinicians were focused on this model because that's what they're going to see when they're actually in the operating room. So it changes the way you educate. So technology is actually helping with this, and we've done some studies, and it's a great outcome. And I'm in a very highly regulated area. The parts that we make have to be perfect every single time, and they have to be done quickly, because if we have someone who comes into the emergency room and we need the part within 24 hours, you couldn't do this with standard manufacturing. You couldn't make molds, pour it up, do that kind of stuff. So we have really rapid turnaround time with basically production-ready parts. Let's see. So we've done studies where you can actually educate the patient on what's going on with them. So here is a breast cancer study where how can you really get informed consent about a procedure without understanding it? I'm gonna make an assumption that anyone in the room here or online is not an expert in reading x-rays, MRIs, PET scans, et cetera. And if a doctor shows you on the screen, hey, this is what you have, it may not click as much as if you show a model in multicolors and be like, this is your body, this is what's happening, this is what we're gonna do, and they can really show what's happening. And it gives a better understanding of informed consent of what's actually going to happen in the procedure that you're doing. Whether it's going to be something like this with a breast cancer patient or a brain tumor that the doctor can open up the model, show exactly what's going to happen, and go from there. So like this is multiple different types of materials that are being used. It also can be a nice Halloween decoration when you're done with it. But we have here flexible materials, we have hard materials, and we're able to assemble everything with really good margins showing the patient what's actually going to happen, but then also doing training, whether it's this or some sort of spinal tumor. And so these are really complex surgeries, complex areas, and even though we won't talk about the material that starts with an F and ends in an M here in the middle of that, but there's Formlabs materials mixed in there too. So we really sit down and try to make the perfect piece of anatomy for our doctors to train on, and we don't have the time or can run the risk of not having being perfect every single time off the printer in very quick turnaround times. We've been customers for Formlabs for a very long time. We have, I'm going to make an assumption now, probably the only form cell, if anyone remembers that, still running. So we have Form 2s, 3s, the 3BL, 4, 4L, Fuse. I don't know if there's any other products left, but we have them all. We make molds for our CNC machines. For our injection molding machines, we do have a CNC machine where we actually CNC some of the printed parts if we need to make slight adjustments, which is very rare. And we realistically use this Formlabs equipment as our workhorse, not only for emergent cases that have to be perfect right off the bat. If you get like a case comes in and you have 24-hour turnaround, how do we get a device that is ready to go into the operating room in that short of time? Like, it's nice to be able to iterate, change, design, but we don't have that luxury. Like I said, being in a highly regulated environment, we need the materials to be certified. We need the workflow to be validated. We need the printers to work on time, every time. Hopefully no errors, no failed prints. We don't get those luxuries. So it's high risk, high reward, right? We get to really see the outcome of our patients right away. It's not like we're talking with the Fireside chat where it takes 15 years for a plane to take off a new design. We don't get that. It's, Friday someone comes into the emergency room, Monday they're being operated on, remote start the print, pray it works, come in on Monday, hand it off, and we can actually treat some patients. We use this now not only just for models, but we have devices that are basically prototype ready and commercialized. We send them out into the operating room. We send them into the hospitals. We have, devices that are certified and are approved, by the FDA that are commercializable, whether it's prosthetic accessories. Like I said, we do some dental work, medical devices that we prototype and then actually bring out into the clinic, and they're commercialized. So without 3D printing, there really would not be this whole process, especially as we support people who are healthcare providers. And so, they need their equipment ASAP. And we learned this during COVID that supply chain issues can really happen. And we were one of the hospitals, along with partners at USF in Tampa, to produce COVID swabs. So we took our Form cell running Form 2s, was printing 365 days a year, basically, making nasal swabs. If everyone remembers having them shoved into the back of the nose, like not the tip here, like literally touching the back of your brain. We ended up printing like 200,000 of those, quality controlling, sterilizing, and deploying them across our network in New York. I think someone here at Formlabs was keeping count of how much they've sold. I think it was like 100 million, equivalent of 100 million swabs around the world. So my little lab with our partners in Florida managed to deploy a product, do benchtop testing, clinical trial, deploy it all within a matter of a month to help with a supply chain issue. So the power of 3D printing this locally and around the world was pretty amazing. You create the file, validate it, send it out to whoever has the correct printers and protocols, and they can start deploying it in need to, whether it's here in the US or Singapore and any other continent. I'm also going to be around all day if anyone has questions about working in the medical field. Please let me know. Thank you.
All right, that was awesome. Thanks again. Let's give another round of applause for all the vignettes. I love those. It is working in the communications team and marketing, one of the best parts of my job is working with the customers. Every one of those vignettes is like a keyhole into a whole world, and so I love seeing those. We are going to shift gears now a bit and go from outside of Formlabs back into Formlabs. We had a big year in 2024, and so we're going to hear from two speakers, Chief Product Officer David Lakatosh and Chief Revenue Officer Nick Graham, to talk a little bit about what happened in 2024 and some of the highlights. So I'll pass it over to David.
Thanks, Mike. So first of all, I just want to say this is my favorite day every year. I love launching products. That's one of the things that I'm really proud of, but today is what I really enjoy the most. I would love to connect with as many of you today as possible, and it's really awesome over the years to see like real friends like Dr. Goldstein. Like we've been, the swap story is something that I think I will remember forever. It was yelled at by several people on delivering more and more swabs. So this is a traumatic and beautiful and very impactful story. But thinking about impact, our mission is to build the tools that make it possible for anyone to bring their ideas to life. And we take this very seriously. We keep on working on new hardware, new materials, new software. And this is one of our scoreboards, all of the things that we have got out into the world over the last 11, 12 years. And 2024 was our biggest year ever. We've launched more things into the world than ever before. Zooming in, Form 4, Form 4L, tons of accessories, new resin, new powders, and this new thing called the developer platform that we're going to get into a little bit later today. And this is the point where I was asked to kind of go in great detail into every single product. But I realized that one, I'm not maybe the best person to do it because there's so many talented people here that work super closely on these, and you will have a lot of sessions about them. So I want to do something different, unless you tell me that I should go into the details. So I want to hear if you want me to go into the details or if you want me to tell you about a personal project that I made for my daughter that is a projector. So products or projector? Okay, thank God. I don't have a size. Okay, so a little bit of a story here. I'm originally from Hungary, and one thing that is very personal to me is that when I was growing up, at bedtime we used to do this thing called the diavetítő, which is a kind of a projector that you would read these 35 millimeter films together with your parents, and it was super awesome, very memorable story that instead of reading books, you would sometimes they would break out this projector. It was a big deal. But they were not great. They were very bulky, and they got hot. I got burned. I still remember I got burned multiple times by them. So when I became a father, I pulled it out of the closet, and this is kind of how it looks like. It's a really cool piece of engineering. It has an incandescent bulb, two lenses, a condenser lens, an objective lens, and unfortunately, you guys are using the wrong voltage here. So here I have to use a 120 volt transformer to be able to use it. Anyway, it still gets really hot. It's still not great, and it doesn't really belong in the 2024. Even though Soviet engineering is something that I think we should all really take a lot of notes from. So you can get rid of a lot of this stuff. It doesn't really didn't transfer into the 21st century, and you can replace most of the optics with just a flashlight that has the right lenses in it. So started playing with it a little bit. Can you really use this flashlight? Looked into some lens designs. It's been a while since I studied physics, so lens systems, and designed this thing. And it's fully 3D printed. It uses a lot of our products. So I thought that even though this is a personal project, it really belongs here because it uses so many of the things that we launched this year. So I'm going to go through, show you how I designed it and how I printed it out, and maybe we can even look at it later. So first of all, Preform. Setting up these lenses. All right. I used, if you haven't used the manual support editing mode, you can support the minimals automatically. After that, you can brush on supports. This is really important because I don't want any supports in the middle because that's where I need the most optical clarity. Once this was designed, I moved on to the body part. This is printed in white nylon. I'll show you why. A lot of these smaller parts of the projector, I wanted to cage them together. I printed 3 sets of them, -1% and +1% and at tolerance, to make sure that I can kind of play around with and get the best fit ever. Once I caged all of them, I was able to pack them together in Preform, and boom, I got a fully printable file. Here I have 2 projectors in there just to make sure that if I break one of them, I can still make bedtime. Went on to actually printing them. I used the Fuse 1 Plus and white powder. If you haven't used it yet, it's really awesome, even easier to decake than nylon 12. Went on to blast. We announced this with polishing this year. I used the manual mode for the large parts because it has a print-in-place assembly that is quite intricate. You can see that, I zoomed in here, the moment when that little toggle became unstuck. So that's a print-in-place assembly. Got all the cages, unpacked them very quickly, and this is really nice because you can just toss them into to blast and polish. Blast and polish is great because it massively reduces the amount of time you need to post-process. I'm pretty strong, but I bet that everybody here would be able to, with one hand, remove these cages, and you have these beautiful parts. And then on to dyeing. This is why I printed in white. My daughter requested yellow, but I didn't have yellow dye, so I did that later. I have those there, promise. This only took 4.5 minutes, super quick. Clear resin is what I use for printing the lenses. It's all done. We have these people really are inspired by their own sketches for the adjective and animal names. Use form wash generation 2 to post-process and form cure. You can see that the lenses are not clear yet. You can't really see what's going on there, so I need some buffing. I used a wet and the dry polishing buffing setup that we're using for a lot of our dental parts actually here. You can see beautiful clarity, and I'm not a super big expert at this, but still got a nice one. Final part, assembly. That's the objective part. Putting together, you can see the slide advancer being unstuck, and the press fit kind of focusing part. You can really nicely tighten it, and then you can adjust it. That's the condenser lens with a little jig that kind of holds it into place. And finally, the off-the-shelf $28 little flashlight. And that's it. These are all of my these are actually my old 30 many-year-old little films that my parents bought me. This is a 35mm film. I think this is a Grimm story, if I remember it correctly. And you can see that's how you advance a slide. That's how you can focus. And we'll turn the lights off, and that's kind of how it looks like. And then you can kind of go through and see the story. You can kind of see that it has a really nice focus, and it's pretty. It doesn't have a lot of aberration, so it's a pretty decent lens. I'm pretty happy with it. So this is kind of how the final product looks like. It really kind of has an entire. It went through 4 or 5 different iterations, but it works really well. But it's really not for me to say. So no product is real without real user testing. So actually, yeah, yep. So this is the final part. You will be able to see it out there as well. But yeah, it works pretty well. So you can kind of, I was thinking we'll show it there. But it has a pretty large throw if you wanted to. Just gets a little bit less bright. But I think it's even better if you see a user. So here it is. And if you can put some volume on it, that would be great. One more.
K-S-S-Z. Very good.
All right, sorry, I wanted to cut that part at the very end. All right, so I know it's a kind of a personal, fun story, but hopefully you really saw that I was able to use a lot of our different features and products that we announced this year. And again, there will be tons of breakout sessions where you will learn in depth about every single one of these. So really excited about all the products. And we have an amazing agenda today. You will go much deeper into every topic, and excited to announce Nick Graham, our CRO, to tell you what makes our Formlabs community so exciting and powerful. Thank you.
Thanks, David. That is a hard act to follow, but I'll do my best. 13 years ago, Formlabs started from scrappy entrepreneurial roots with a Kickstarter. Some of you joining today were probably backers of that Kickstarter, and for that we are eternally grateful. And you backed a vision at the time that's fairly simple. It was to make 3D printing much more accessible in the world. And together, we brought that to reality, right? Formlabs has created in stereolithography first an entirely new category of printers. Traditionally, there were the high-quality, expensive printers that were inaccessible to many professionals in the world. And we created a thriving category of industrial quality at an accessible price point. And we even inspired some lower quality and lower cost competition along the way. And today, we are a market leader in that new category in stereolithography. We ship more SLA 3D printers to professionals than any other company in the world. And we are in the top for revenue, only behind 3D Systems, one of the founders of the industry. That would be impressive for any company to truly disrupt a market, right? A lot of companies talk about disruption, but let's be honest, very few actually do it. Formlabs, we weren't satisfied with doing it once. We took a second crack at it, at a new technology. And as you know, we moved into selective laser sintering, and once again tried to repeat history by taking the status quo, the high performance, high cost machines, inaccessible to many, $300,000, $400,000, $500,000, and deliver that industrial quality at an accessible price. And we were successful in doing that together. And today, we are perhaps even more dominant in SLS 3D printing than SLA because we ship by far the most units of any company in this category, and we are only behind in revenue to some of the most successful industrial players like HP and EOS. And we did all of that together. So I wanted to share a little bit of why I think we got there and what it means for our future working together. I think there's a few things that made Formlabs special in our DNA over the years. One is that we innovate relentlessly. If you walk the halls of Formlabs, you'll hear people talking about how we deliver more value to all of you and obsessing over it. We have arguments about whether a product or feature is ready and it's met our bar for quality and giving you a great experience, but also getting it in your hands so you can create value. And that is real tension we feel every day. We also try to make products that first we love, and then we put them out on the market, and we really hope you love them as well, and that is an incredibly important part of the equation. We're also building this company for the long term. We're not trying to meet your needs for today or tomorrow. We want to be partnering with you for years and decades to come. And then because this is User Summit, we should really celebrate this, and probably the most important, we listen to all of you. You're very generous in your feedback, your ideas, your critique, your criticism, your passion. We take it all on board, and it really influences the decisions that we make every day. David showed you kind of our scoreboard for the past 13 years, and 2024 was incredible for delivering new products to all of you. And that's one way to think about our investment in delivering more value to our customers. But another one is just actual investment of time and dollars. So Apple, one of the companies we look for to inspiration, they invest about 9% of their revenue in R&D. Another big player in 3D printing, Stratasys, invests about 16%. We invest 27% of our revenue in R&D. And that is a massive investment as a company because we want to keep solving your problems not just today, but 5, 10, 20 years into the future. We also, we build the products that you love. And we're very happy that we get a ton of feedback from you in different forms, surveys, forums, Reddit, anything. We scour all of it to see how our products are meeting your needs. And one of the ones we like for customer satisfaction is Net Promoter Score, which is on a negative 100 to 100 scale. Both of our product lines are right around 50, which is an incredibly good score that we look at a lot and we think about how we can increase. To give you a benchmark, the Apple iPhone, which is one of the most successful and loved hardware products in the world, is about 51. So we're right at parity. And I'm excited to tell you that the Form 4 is officially our most loved product ever and is scoring right now, based on your feedback, an NPS score of 67, which is a new benchmark for us and makes us super excited about the success of the product for all of you. And you've seen the praise roll through. TechRadar Pro gave it 5 out of 5 stars. Tom's Hardware gave it 4.5 out of 5 stars. Time listed as one of the best inventions of 2024. And maybe more importantly, all of you have told us one-on-one that you're thrilled with what it allows you to do in your work. We're also building a business for the long term, like I mentioned. And this is important to talk about in 3D printing right now because there are a lot of companies out there struggling. They're struggling to grow, they're unprofitable. Some of them are unfortunately even going out of business. And we're on a very different path thanks to all of you. We have a long track record of rapid growth. This year is no difference. Our business is growing off of the success and your enthusiasm for the Form 4 and the 4L. And we're doing it profitably and sustainably for the long term because we want to be here, once again, to meet your needs 10, 20 years from now. Listening to customers is what today is all about, and I wanted to try to give you like a little insight into the types of conversations that happen at Formlabs and how important your feedback is to us. So I extracted one piece of feedback out of the thousands and thousands you guys have provided in one of our surveys and wanted to show you how it connected to our decisions this year. So this customer said, I like almost everything about your closed system. I would like better pricing on resins and compatibility with third-party resins. And this is really representative of a lot of feedback we got. And so what do we do this year? You know, we did a massive price reduction for our general purpose resins while making them better. We went farther than that in bulk material pricing because some of our higher volume customers who are using us in production have even more aggressive targets for their cost per part. And then, of course, we unlocked open material mode so anyone can use third-party resins and powders in our printers across the board. And this is really how the decisions happen at Formlabs. So you guys give us feedback, and we think about all of it and debate the different options, and then we make decisions and changes to serve you better. So this is the most important one, and it's probably my key message for you, is that at the end of the day, everything flows from you guys. Everything that we think about in terms of our success is defined in delivering more value and putting that into your hands, and it truly guides what we do every day. If you look at some of the products and features we've shipped, I think there's some ones that stand out. Hollowing is an interesting one. This is a product and feature that tons of people have been clamoring for, probably for years in Preform. They didn't want to leave and use a third-party software to hollow their parts. That makes total sense. It's not a product that's going to make us millions of dollars or anything, right? It's part of free software. You actually reduce material consumption because you're hollowing parts, right? But you guys wanted it, and so we put it into Preform, and your response has been fantastic, and that's how it should work. Another one I like is this accessory for the sift for the fuse, the glove box, right, that allows you to have a fully enclosed system where no powder can possibly leave the sift. This is an example of a product that we don't actually use a lot at Formlabs ourselves. We just use the standard sift setup because the powder is generally contained by the back pressure in the system. But a lot of customers asked for it. They wanted that extra safeguard, that extra sense of security that the whole system was contained. And so we developed it, we released it, and the reception has been fantastic. And once again, that's how it should work. And then probably my personal favorite, and I hope one you love, is the Build Platform Flex. Once again, not a product or a feature that makes millions of dollars or anything like that, but if you've chiseled parts off the Build Platform and then you've used the Build Platform Flex, you know the transformative difference and that moment of great feedback when you pull the tabs and your parts pop off and slide off the platform seamlessly. It is truly, to me, one of the great delights in 3D printing. And it's not just about you guys giving us feedback of what we're doing today. We saw the user vignettes. We take inspiration from how you use our products so we can look forward to the problems that we need to solve 5 or 10 years down the line. We talked to Radio Flyer earlier today, and I think that's a great example of taking inspiration from one of our customers in speed to market. A lot of our customers, they use us in prototyping, and they push themselves constantly to get faster and faster and faster because that is their competitive edge. We have big customers like Tesla and Radio Flyer and many others where this is how they take market share. This is how their company succeeds, is by getting better products to market faster and by using the entire Formlabs ecosystem. Radio Flyer is showing how you can do that in a really seamless way. Very different speed. One of our customers, Tan Tock Seng Hospital in Singapore, put in a ton of time and energy to make a prosthetic nose for one of their patients. They had unfortunately suffered from skin cancer and lost their nose, and they wanted a prosthetic to make themselves more comfortable. And the doctors there really iterated tirelessly to try to get the fit right and also the look right by painting our SLA resin to make this prosthetic. And to me, it's very inspiring because of their dedication to the patient outcome and wanting to deliver a better quality of life, but also because the process took a while, candidly, right? There were a lot of iterations in the process, and our job is to make that more seamless and easy. So you can imagine how that might inspire what we do in the future. And we also talked to Brose earlier today. There are a lot of inspiring things about what Brose is doing with our technology. They are power users of SLA and SLS technology. The single part that I think is really interesting is their push for serial production. A lot of times when people think about 3D printing or talk about it, they talk about part counts that are in the tens or hundreds or maybe low thousands, and they're trying to do 250,000 end-use parts for the BMW X7. And they're putting that positive pressure on manufacturers to change the way things are built. And that's the type of thing that brings the entire industry forward. Thank you.
Thank you, Nick and David. That was a great session. I definitely love that projector project. That was really cool. Hopefully you guys are not sick of me yet. I'm up here for 2 minutes. I told you one of my favorite things today was the user vignettes. My other favorite thing is this part. So this is the Formlabs Impact Award. It really flows nicely from Nick's talk about celebrating our customers. A lot of you here are doing amazing work, and in the community, a lot of really, really impressive work is getting done. And so every year we do recognize members of the Formlabs community who really take a different approach, have an impact in a variety of ways, healthcare or really deep innovation that kind of transcends just a single organization and really broadens out that. So we have a couple of awesome nominees this year. This was nominated by the community, and so I'll just quickly show these four here. These Dr. Frank Rabicki, Christophe Debat, Dr. Lisa Ovetro, and Dr. Stefan Kreimer. These are people who came from the community. They are all doing really impressive work. We would love to honor all of them, and in fact, in many ways we have by making videos and content about them, which we can share out after this to check out, but we only have one winner, and that winner today, with a dramatic pause so everyone can anticipate who it's going to be, is Dr. Christophe Debat. So we'll give him a round of applause. I'll tell you a little bit about what he's doing. This is really one of my favorite stories. I've known Christophe works at Romans Ferrari, which is in France. It's a healthcare organization that treats juvenile burn victims. And so I've actually known about the organization for a couple of years and seen them evolve, and it's really amazing what they do. So they treat about a quarter of all of the juvenile burn victims in France, and they do that with a really innovative approach. They have transformed their workflow from analog to digital, and they create custom treatments for all of their patients. They've gotten rightfully a lot of recognition locally in France and globally for the work that they're doing. I would love, like I said, to honor all of the nominees that we had, but this one I feel really, really grateful for. In the chat, we can share some extra content about this that we've done around Romans Ferrari and Dr. Debat as well. This is a really great story, and hopefully everyone in the room afterwards can look it up. We can send it out as well because it's one of the most heartwarming stories we know. So one more congratulations for Christophe and the team at Romans Ferrari. Thank you so much. This is actually going to be a very quick break, so everyone here in the room should check their schedule to see where they're going next. This is for the first time we are breaking out into different sessions here in Boston. Online, for all of our viewers online, give yourself a couple of minutes, use the restroom, get some food. You will join us just shortly here on the main stage for a great session about materials. So thanks so much for everyone for the great first half of the day, and we'll see everyone soon.
Okay, awesome. Can everybody hear me okay? Cool. All right, so with that, we're going to get started on our next session. This session is titled Materials Matter, Materials for Every Application. So I'm Evan. I work at Formlabs on our product marketing team. I'm going to speak to the materials side of the equation and our awesome material portfolio here at Formlabs. And then I'm going to hand it off to Ryan Laprise, who's a prototyping engineer at Microsoft, and he's going to speak to how these materials enable really awesome applications at Microsoft's prototyping lab. So with that, let's get started. Okay. Maybe. Oh, okay, there we go. Hopefully I didn't over-click that. Okay, I think we're good. So I'm going to open with this question that I'm trying to answer in my half of the talk, which is how do we organize our 60+ materials here at Formlabs? We have a lot of materials. Materials are very complicated things. They have a lot of different properties. So how do we think about it? And I have a picture and a quote from a famous Swedish scientist here who was responsible for binomial nomenclature and knows a thing or two about naming things and the importance of naming things as a way to convey knowledge and understanding. So with that, I'll dive into it. So these are the way that I think about our materials, but it's not necessarily the only way to think about our materials. Materials are complicated, so you can organize them by application, by property, and a whole bunch of different things. But the way that I like to think about them is starting from what are some really versatile materials. So these materials have a really good blend of properties for a bunch of different applications. On the SLA side, we have our gray V5, or sorry, our general purpose V5 family, all the way on the left side of the column. We just launched the 5th generation of those materials this year. They're really awesome and have better properties across the board. And within that family, you have gray, black, clear, and white. On the biocompatible side, we have sort of a similar analog to this in the general purpose Biomed family. And in that family, it's Biomed white, black, clear, and amber. Same thing, they have sort of properties that are balanced for a wide variety of applications, and with the added benefit of being biocompatible. You'll notice in the names of these materials, the name is based off of the color or the aesthetic of the material. These materials are going to give you the most aesthetic options of our portfolio. Going down the line on SLA, the next material is fast model resin. So like a general purpose material, but faster is basically the idea behind fast model. So if you need to print things quickly. And then if these materials didn't give you the aesthetic options that you wanted, you can always go to Color Kit, which lets you dye your resin to a custom color and have whatever color you want your resin to be. And then on the SLS side of the spectrum, our jack-of-all-trades material for SLS for a long time has been nylon 12. It's got really good properties and a little bit higher heat resistance than the SLA general purpose materials. But at least up until very recently, if you wanted to print an SLS, you were kind of locked into a gray material. But with the introduction of nylon 12 white, not only can you now print white SLS parts in nylon 12, you can also dye those parts to be whatever color you want them to be. So finally getting to sort of the aesthetic options that we've had for a really long time for the SLA side of the family. So the next category I'm going to talk about, the next grouping is tough materials. And so toughness is a really important property in material science, and people sometimes mistake it for strength. Strength is, how hard can you pull on something before failure, or how much stress can a part withstand? Toughness is actually measured in energy, not in terms of force or stress. And so it's the amount of energy absorbed before fracture. So whenever we're looking at a TDS for a material property and we're trying to evaluate toughness, we need to look for something that has units of energy. So the most common way we do that is with impact strength. That will have units of joules per meter, typically. But there are other ways to measure it as well, like worker fracture, which is done at a slower strain rate. The least tough material in our family is called Tough 2000. So it is the stiffest tough material. When we have materials that have a number in the name, usually the number is the tensile modulus for the material. Tensile modulus is how we evaluate stiffness in materials. So Tough 2000, having a 2000 next to its name, is stiffer than Tough 1500. At the same time, tough materials usually trade stiffness for increased toughness. So Tough 2000 is stiffer than Tough 1500, but Tough 1500 is tougher than Tough 2000. So that's kind of the way to think about the portfolio is you're going down in stiffness, but going up in toughness. And so at the end of the spectrum, you have durable and biomed durable, which are considerably less stiff, but they are tougher still, and kind of the tougher of sort of the standard resins in our portfolio. The SLS side has a really awesome material that we launched this year called Nylon 12 Tough. That is tougher than standard Nylon 12 and has really good properties as well. It falls about between 2,000 and 1,500 in terms of its toughness. And the next option for toughness in the SLS materials portfolio is Nylon 11. Nylon 11 is even tougher still, but it's a little bit harder to use because you're going to need nitrogen to ensure that you can get really consistent results and lower refresh rates. So that's the tough family of materials, which I, again, have grouped across SLS and SLA and biocompatible materials all in the fold. The next family we have is going the other direction. So these are our most rigid materials. In this case, we're going to have that elastic modulus number be higher. So rigid 4,000, rigid 10,000, you can see that number is going up. And these materials are most frequently filled with something. That's how we usually get stiffer plastics, is we add fillers to them to get stiffer parts. So starting with our least stiff material is Nylon 12 glass filled all the way on the right. Nylon 12 glass filled has a glass bead filler. Rigid 4000 is one of our first glass filled materials, and it's a glass filled SLA material. Nylon 11 carbon fiber is a long fiber carbon fiber reinforced material. And one thing to call out is usually these rigid materials sacrifice toughness for stiffness. So to get increased stiffness, usually you're sacrificing your elongation to break and your toughness. But in the case of Nylon 11 carbon fiber, the long fibers actually help with impact resistance. So whereas Nylon 12 glass filled, rigid 4000, and rigid 10,000 all decrease their impact strength for their improved stiffness, Nylon 11 carbon fibers actually got a really good impact resistance. But just like Nylon 11 without carbon fiber, it does require nitrogen to use, and it's a little bit more involved than some of the other SLS materials. Our most stiff material across the entire portfolio is a really big fan favorite. It's called rigid 10,000 or rigid 10K, and that is for its modulus, which is at 10,000 megapascals. So another group that I have is now going the other direction again. Some materials have a really low elastic modulus. In fact, their elastic modulus is so low that elastic modulus doesn't become a really useful criteria anymore, right? It takes so little force to elongate these materials that we kind of want a different metric to evaluate them and put them next to each other. So we use a property called hardness. Hardness is just localized deformation in response to stress. So we're still doing a stress to deformation relationship, but it's localized in the material. And we measure this with a shore hardness gauge is one common way that we do this. And you're just pressing into the material and measuring the response. So it's just basically an artificial scale. We're typically using the shore A hardness scale. And you'll see that all of our materials are labeled with their shore hardness value on the material. So our least soft material is TPU 90A, and that has a shore hardness of 90A. It's our only elastomer within the SLS family. Then we have the flexible ADA and Biomed Flex ADA, which are at the ADA durometer, so getting a little bit softer, but still in sort of the more harder end of the softness spectrum. Then going to some really soft materials, we have Elastic 50A and its biocompatible counterpart, Biomed Elastic 50A. These materials offer really good elongation and softness, and they're softer still. Silicon 40A is our softest material. It actually uses a different chemistry to achieve this softness, but it's the softest material that you can print here within Formlabs material portfolio. Moving on, there are some materials that don't really fit into this bounding box that I've laid out between elastics and rigid materials. And they also don't really fit into the typical material portfolio of Formlabs, where I grab a cartridge, I grab a tank, I put them into my printer, and I print my parts in a standard workflow, or in the case of SLS, I add powder to a hopper and go through and sift and blast it. There are a couple materials that don't really follow that workflow, but also don't really fall into this bounding box of properties. So we're bringing back an old brand name that we had for these types of materials back when we launched the original ceramic material that we had. And that is called Form X. And so the idea is that these materials are for experts. They exceed the capabilities of the existing printing portfolio, but they're not as plug and play. as you would expect with a traditional Formlabs material. They require extra equipment that's not provided by Formlabs. They require more attention to detail in the workflow to get really good, consistent parts, with taking a lot of care in the post-processing steps to ensure that everything goes well. But at the same time, you're able to really get amazing properties out of these. So polyurethane and alumina 4N are kind of the two things that are in this portfolio to start. And if you look at polyurethane rigid 1000 resin, you'll see that it actually has a really similar tensile modulus to durable resin, which I talked about being a really tough SLA material. But it has a almost double the impact resistance. So at the same modulus, you're getting double the impact resistance. If you go ahead and drop the modulus to what it is for polyurethane rigid 650, you're able to get to like 3 to 4 times the toughness that you're getting in the standard SLA portfolio. Likewise, the fun anecdote I have for alumina 4N is if we named it like we did for the rigid materials and used the elastic modulus in the name of the material, it would not be called alumina 4N, it would be called rigid 390K or rigid 390,000 because that is its tensile modulus. It is just that much higher than a rigid 10,000. It's higher than a stainless steel. It's a very, very stiff material because it is a ceramic at the end of the day, not a polymer. Awesome. So that is Formex. Diving into another category of materials I have, these are specialty materials. So these are ones I'm not grouping by mechanical property because they rely on another property to be their defining characteristic. So rather than toughness or stiffness, these materials have a defining characteristic around flame retardant, for example, ESD, so flame retardant being defined by having a UL94 V0 rating, ESD being defined by its surface resistivity, and high temp being defined by its heat deflection temperature. On the SLS side, I've put polypropylene into this family. Polypropylene is not significantly tougher than nylon 12. It does have higher elongation at break, but it's really defining characteristics that differentiate it from a nylon 12 are things like chemical resistance and moisture resistance, as well as its ability to act as an analog for injection molded materials like polypropylene, which are all kind of separate from its standard mechanical property profile. So jumping on to another category that we've had for a long time is castable materials. And we've had castable resins for jewelry applications. They come in the form of various waxes, and they can be burned out, and then you can pour metal into a mold to get a final metal part. This year we released clear cast resin, which is a resin that is for investment casting, but for investment casting larger parts at foundries for industrial and engineering applications. You're printing larger patterns, and you're using this tetrahedron lattice within the patterns to enable your parts to burn out cleanly, which is a really awesome material. There are some really great parts over at the expo if you guys want to check them out. Cool. A different way of naming our materials is one that we use for dental. So I talked about you can also name or categorize materials by application, and within the dental portfolio, that's what we do. Our material for surgical guides is called surgical guides. Our material for custom trays is called custom tray. Just to keep it easy, it's for the application. And that's how our dental portfolio is named. We have a whole bunch of different materials there that I won't go into in too much detail. Then jumping on, one really awesome thing that we've done this year is open material mode. So we make a lot of different materials here at Formlabs, but we're not going to be able to make a material for absolutely every single niche that exists. So the way that we're going to continue to grow and continue to enable people to print more things is to enable them to make their own materials for their particular applications. And open material mode is our way of doing that. I have two really awesome customer examples here. One is from Figure Engineering, and they are printing masks for, or masking jigs basically for electroplating. So in this case, this screw is going to be electroplated, but you don't want to electroplate the threads because you'll change the thickness, the offset, the tolerances, and then your threads won't thread together. So the material is specifically designed for that application and what they need for doing that masking. On the bio engineering side of things, PolyMed has a really awesome material that is bioresorbable. So it is designed to be put into the human body and then dissolve and be absorbed, which is really cool. Not something that we've ever done here, definitely outside of our knowledge bounds and scope. So really cool to see customers taking our platform and taking it even further to do some really, really awesome things. And then one other thing I want to call out is, like I said, this is the way that I think about our materials portfolio. It's not necessarily the only way to think about our materials portfolio. And so one really awesome tool we have, if you go to formlabs.com/materials, is what we sometimes call the materials catalog. And it is all of our materials listed, but you can do things like organize them by a particular property. Here I have it organized by ultimate tensile strength. So it is a ranked list of materials going down in ultimate tensile strength. And then you have sliders and filters on the left-hand side, so you can pick for applications. You can add another property. So here I think I slid a notched IZOD slider up a bit, so I want strong materials, or materials ranked by strength, but I also want a floor of how much toughness I'm willing to accept. And it's a really cool way to just explore our portfolio and to find things for your applications more easily than trying to read through every single TDS individually. So I want to call that out, and I encourage you all to use it as a tool because it's really awesome. So that is all I have to say. So I'm going to hand it over to Ryan Laprise, who's the prototyping engineer over at Microsoft, to talk about some of the applications that he does with our materials.
Thank you. Hi, my name is Ryan Laprise. I work at Microsoft in the Advanced Prototyping Center, and we're basically an all-encompassing like model shop and prototyping lab on the Microsoft campus in Redmond, Washington, and we kind of help support all aspects of like product development for Microsoft, so any of the hardware that they do. The majority of the company is software, but we're in one of the few buildings that does focus on hardware, and we help through the entire spectrum of product development, from initial concept ideation with the designers who are designing what our new products look like, all the way up to helping the manufacturing side, helping solve manufacturing either errors or like problems that they're having, and that can be anything from like fabric for our type covers on our tablets. We've had issues with kind of solving how the fabric adheres to the product, down to like machining aluminum buckets for tablets and laptops and stuff. We have a team of CNC machinists who will actually iterate tool paths to kind of streamline the production cycle. And so what my job is, I'm a prototype engineer. My role is kind of called architect, or like CAD architect. And I work, probably 80% of my job is working with the designers and doing initial product concepts and getting the designers like physical models to hold and feel and evaluate. And so, oops. And so we do a pretty broad range of different prototypes. The designers are working on like initial concepts, like I said, where you're exploring things like aspect ratio, device thickness, and once you're further along in like the design process, you can get into more involved prototypes that are like machined aluminum. We paint them to look like real anodized parts, and yeah, it gets really, you get really into the details of like making a model look like a real product, so that way the designer can hold it and actually really evaluate how that product is going to feel in the real world. And so to handle those requests, we do, in the initial stages, we do polyjet, a lot of polyjet parts, where surface finish isn't really critical. And then on the other end, like I said, we do CNC machined models. And where Formlabs has come in is we've, like we always want to make things faster, and the faster we can evaluate things, the faster we can move in the product cycle. And so where Formlabs came in initially, we were printing these kind of like drop-in connectors And so to make machining the like really nice models faster, instead of machining a bunch of internal components to put real connectors in, or sometimes we don't even have the connectors, we'll do just a side pocket in the side of the device. That's super easy to machine for our machinists. And we'll print like dummy connectors and throw those in. These are in gray here, but we usually print them in black so we don't have to like paint or anything. And that's super useful for like the Surflink connector, which is like our kind of power connector. We have stock components that we could use, but sometimes the external geometry of the part dictates that we can't use a stock part. And so instead of machining really tiny details to get the look of a real connector, we can just print one and just tape it into the side of the device. And we do that for like USB-A, USB-C, and even some speaker meshes. We have speaker mesh that's on a little cutout on the side of our tablets. And that was super useful in the beginning stages of like developing that. And then actually we also did some elastic prototypes for our earbuds. And we eventually moved on to like CNC molds and casting real silicone. But the initial stages of prototyping and getting like the fit in the ear, we did a lot of elastic prototypes for our earbuds. And then I don't have a picture here, but we do have like headsets. I worked a lot on our Xbox headset. We had some really nice Surface headsets. And for those, we did a lot of polyjet models initially. And if you know polyjet, it's very brittle, or more brittle than we'd like to have for our models. And so where that came in, where we used Formlabs for that, we used a lot of like Tough 1500, Tough 2000 for the actual headband. And that made it so that we could print like looks like models of headsets that won't snap when you try to like put it on your head. Because I don't know if you put a bunch of headsets on a table that are just like printed models in the middle of a design studio for people to review, there's going to be at least one person's going to walk up to that table and try to put that headset on. And if it's all a polyjet model that's painted to look like a real thing, we have people coming back to us all the time to like glue models together because someone picked it up and tried to put it on their head. And so the Formlabs tough materials have been super handy for that kind of stuff, just making the products more usable and much more useful to evaluate the look and feel. And then we use a lot of rigid 10K in our model shop. A lot of it's for like sheet metal stamping. We do a lot of prototypes for like shield cans on our electronics, like on our circuit boards. I'm not super familiar with that realm, but this model's from one of my coworkers who's done a lot of experimentation with that. And we have on site, we have like water jets and laser cutters, laser etching machines. And so we're able to cut out sheet metal parts and stamp them using printed molds. And that's helped immensely because our biggest bottleneck is usually on the CNC side. And so if we can bypass CNC machining and get a product faster, it's super helpful for us. And then I don't have a lot of pictures of our like work stuff just for confidentiality reasons, but I do have some like, we're able to work on like personal projects outside of work hours, and I use that one to work on my car and also to kind of learn new processes, which only helps use those processes in our model shop. And so this was a lock cylinder that I was trying to make for my car. And we were messing with injection molding. We just got like a little bench top, just like manual injection molder for doing like overmold stuff, injection molding like Xbox components and stuff like that. And so using the rigid 10K, I was able to kind of get a feel of like one, mold design, and two, just how the molder itself worked. And so I was able to make some lock cylinders with some like pretty complex like side pulls and stuff And you can see like some of the details are super fine, and so like pieces break off just because of how rigid the material is, but the parts being so small and so fast to reprint, you can kind of treat those as consumables, and you can do like risky stuff like having zero draft on a part if you're just kind of messing around and having fun with it. And then this was another like passion project that I had. This was a fender mirror for my car, and a lot of the ideation on it was using Formlabs parts, mostly for the clear part that you see. This part right here is actually a clear Formlabs part that I sanded and then clear coated to get it as optically clear as possible. And then I was able to print a like cap to create a silicone mold of this so I could cast the clear part in a stronger clear material, just because the clear itself isn't, I didn't trust it to be on the road for thousands of miles. And so it was super useful just being able to print a cap that has all the indexing features and all the mold making features that I want. And I was able to do a two-part mold for that, and that's where that part came in. As well as this knurled part here is actually just a raw rigid 10K print that I painted silver. And then the lower stalks are printed in stainless using a Mark Forge printer that we have on site as well. And that picture at the end, you can see that was after a 3,000-mile road trip that I did with my dad in Utah. Drove down to Utah and back to Seattle, and everything held up like great. And so, yeah, we just kind of mess around, have fun, fail fast is a big thing at Microsoft, and yeah, just kind of utilizing Formlabs to get better looking products and better looking models for our designers, and getting it faster. And I think that's it, yeah.
Awesome. Cool. Just want to let everyone know that it's now a 30-minute coffee break. So if you don't feel like sitting and you want to get up and get coffee, please go and do that. Otherwise, we'll see you back here for the next session, which is what's new and latest applications about SLS.
Welcome everyone to the Formlabs User Summit 2024. I am Dr. Elisa Praderi. I'm the Senior Clinical Protocols and Key Opinion Leader Manager at Formlabs Dental, and I'm reporting from our Berlin office. Today I'll be covering Formlabs Dental, a year of innovations. This year we had a lot of new hardware, updates, new software, and materials coming to the market that actually will enable dental professionals to take their workflow to another level. So we have a little bit of the snapshot of everything that happened this year for you today. So let's get started. So as part of our mission and vision in Formlabs Dental, we always wanna, let's say, be in line with our motto that is dentistry made easier. And this year in 2024, we believe we have brought solutions that still align with this value proposition and that actually do make dentistry even easier with the 3D printing solutions. Let's see a little bit what these consist of. So we're going to be seeing a little bit of the Form 4B and the Form 4BL, as well as also post-processing hardware solutions and the Formlabs resin washing solution. A couple of new materials on the model production side, as well as on biocompatible resins specifically for tooth color materials, as well as software features, and also open platform with Formlabs certified materials, Preform print setting center, and open material mode. So let's start first with the hardware updates. Let's look at the Form 4B. So the Form 4B comes, let's say, with a blazing speed that meets unmatched accuracy. So this new, let's say, hardware unit enables users to print 11 models in 9 minutes. So this is a fast printing solution, also accurate for a perfect fit every time, intuitive so anyone can learn in 15 minutes, and much more. So the Form 4B is powered by low force display technology, which sets a new standard for print speed, reliability, print quality, and material performance. The LFD, it's how we abbreviate this term. It's all the print engine that consists of the Form 4B that will really enable you to get not only parts that you can print fast, but also that are really accurate. So when we compare the Form 3B to the Form 4B, we can see already that in this case, we have a different light source. So instead of having a laser, we now had 60 LED lights that are being, let's say, always turning on all of them at the same time. And as you can see on both animations, on the left and the right hand side, you can already detect by simple looking at this animation the print speed differences. So you can see on the left hand side we have the low force stereolithography technology of the Form 3B and the Form 3BL that actually it's curing our object, let's say spot by spot with the laser. On the right hand side we have the Form 4B technology where we're going to be having all those 60 LED lights emitting the light, and then we're going to have all our optical components from the optical baffle and the lens array that will be responsible for projecting that light, and then the light processing unit 4 will be masking that light to create our object. But as you can see, if you see also how many times the build platforms ascends and descends, already on the right hand side we have seen much more times that this happened versus the animation on the left. A couple of important things to note is that the low force display technology, the print engine, has 6 advanced subsystems. For instance, we have the automatic resin handling. So we still keep the fact that the resin is automatically dispensed to the tank. We also are going to see in a second that we redesigned the cartridges. Then we also have intelligent control systems, which we will see in a second. But important to know that we have the resin tank with a flexible film. It has a durable, it's very durable and really, let's say, it's resistant to any scratches and punctures, and is going to be also part of responsible of reducing those forces during the print process. As we saw before, we have the backlight unit and the light processing 4 with the release texture that all of these elements are responsible for, let's say, emitting our light and masking our light, and also helping with the low force, let's say, print process per se. So about the intelligent control systems, we also have a very nice feature that we have a camera that enables remote monitoring and troubleshooting of our print jobs. There's also a resin level sensor that measures the exact amount of resin in the tank, so we can keep consistent, let's say we know exactly what resin is within there. They're printer leveling sensors, so we know that whenever we have to, let's say, to level our printer, so that actually also stays in the printer and ensures equal resin distribution in the tank. So it's very important to level your printer when you're using it, before using it. Then there's the force sensor that optimizes print speed and quality across materials and geometries. That force sensor is super important for the print process. Also the resin temperature sensor, as we discussed before, that adjusts the temperature for optimal print results, and you can see that also in the light processing unit 4 when you turn it around. And the mixer being responsible for checking for debris and can help us to reduce the risk of any print failures because it detects that there's maybe something in the tank that can jeopardize our print. As I mentioned before, this is how it looks like, for instance, when we use the camera that is inside the printer to monitor our prints. So you can also record time lapses, and you can see on the left hand side that is a time lapse of when we printed occlusal splints, and on the right hand side a time lapse for printing the models that we were going to use to fit those splints upon.
Let's see how to set up your Form 4B for printing. So before getting started, it's very important to always wear gloves. So I already have gloves on, and we're going to be setting up the Form 4B, which you can see here. So we already seen that the Form 4B consists of different parts. We already saw what's inside the Form 4B with the backlight unit and the light processing unit 4. The Form 4B has this cover, the printer cover, that enables us to keep like a very, let's say, constant environment inside the printer, and also avoid whatever resin, liquid resin is, let's say, printing to cure from external light. So to set up the printer, we need a couple of elements. First one is the resin tank and the mixer. So for the resin tank, we have the resin tank here. it has already been used for fast model resin, so it already contains liquid resin, and it has a flexible bottom of the tank, as you can see. And I'm always grabbing the tanks from the sides because I want to avoid having any fingerprints at the bottom, because that's going to be the surface where the light is going to come through, so I don't want to have any fingerprints there. As you can see, the tank, it's already protected, and I have the plastic lid on. This enables me to, for example, when I'm done with a print job, take the tank, put the plastic lid, store it on the side, change and swap materials very easily. So what I'm going to do now is I'm going to place the tank in the printer. You can or remove the plastic lid already outside or place the tank with a plastic lid on. That's what I'm going to do now. So we slide our tank in the printer, okay, and I'm going to secure these lateral latches to the tank. So that's going to secure the tank in place. So that's it. And actually the printer detects that I already inserted the tank. I'm going to remove the plastic cover, put it on the side. And now I want to secure my mixer. My mixer has already been, let's say, used for printing. The mixer, as I mentioned before, is going to be used to keep our resin homogeneous and correct conditions, and also will be responsible, the mixer, for detecting any debris or let's say impurities in the tank. So I'm going to place, the mixer has a little area where I can place it and secure it. So I already secured the mixer. Next up, I need to place my build platform. I have two options here, or to use the build platform standard or the build platform flex. So what are the differences between these build platforms? So the build platform standard, as you can see here, it's this one, and the build platform flex is using the quick release technology to remove parts from the surface. So when you open Preform, you see also that you have a grid where you're orienting your parts when you're, let's say, giving orientation, adding supports, or maybe snapping the model's base directly to the build platform. That surface is exactly this one. So for the purpose of this demo, I'm going to be using the build platform flex. The build platform flex, as I mentioned before, has a quick release technology, which enables me to snap out the parts after the print is done. And it's really, really convenient because it really streamlines that part of the workflow of removing parts from this surface. So I'm going to place the build platform in the printer. And the printer already detects, do you have your build platform locked and clean? I'll press yes. The internal elements of the printer are already set up. Last but not least, I need my resin cartridge. As I mentioned before, the resin cartridge comes in this presentation. It comes in these plastic containers that are light tight and contain the liquid resin. It also contains, if we can see a little bit closer, the resin valve. The resin valve is where the resin is going to be, let's say, from where the resin is going to be dispensed to the resin tank. And this also contains the cap. The cap needs to be opened once I place the cartridge in the printer. So to open the cap is very simple. It's just that. So I'm going to place the cartridge in the back of the printer. So let's do that. This is fast model resin. Place it, open cap. That sound is the printer detecting that I placed a fast model resin cartridge. So if I go to the printer screen, I select that I have my tank secured with my mixer, the build platform, and cartridge. And those are all the elements that you need to set up your Form 4B. Next step would be to send our print job for Preform, or if you already have your print job here, you just, let's say, select the print job that you want, and the printer will automatically start next up the job, and the print process will continue.
So how does this affect the digital workflow on the printed part? How does this is clinically relevant or for the lab workflow, let's say, an impact? So if we look at, for example, model production, models for thermoforming, diagnostic models, or restorative model, we can see already that if we want to print a full build platform, we can range from 9 minutes to 31 minutes, 28 minutes, which are all times around 30-minute workflow for thermoforming, models for thermoforming or diagnostic models. But if we look at restorative models, for instance, that we're printing now at 50 micron layer height setting, we can see that we can print a full build platform in 110 minutes. And that is actually a significant improvement from the Form 3B or even Form 2. When we look at biocompatible resins, now we can see that we can print occlusal splints and guards, a full build platform with 8 splints in 49 minutes, or also in direct bonding trays or guides for direct composite restorations in 43 minutes. And if we look, for example, to surgical guides, 12 guides can be printed in 48 minutes, temporary all-on-X appliances in 37 minutes, or digital dentures, the teeth in 37 minutes, and denture-based resin, bases printed with denture-based resins in under 4 hours. Other applications, for instance, permanent restorations, also 1 crown in 29 minutes, temporary restorations in 25 minutes, and custom impression trays in 44 minutes. So you can see that the print times are actually significantly reduced as a whole. So important to know, because we have been looking at production of a full build platform, and you might be asking then, how much time does it take me to print one single model? It's important for you to know that because the print engine is changing, it doesn't matter really how many parts you have in the build platform, the print time is not going to be, let's say, affected. So you can print one model in 9 minutes or a full build platform also in 9 minutes. So it's important for you to bear in mind, because before, with laser-based SLA, the more parts you add, the more it will take to print. But now actually we can see that a full build platform does not affect the print time as a whole, or whether you print one model or a full build platform. So let's look at actual parts. We see here the same model printed in different printers and with different materials, but you can see here this printed at the same layer height. And you can see, leaving aside the color difference, that the surface resolution obtained by the Form 4B is actually quite nice. And especially if we look at the area of the incisal edges. But if we look at the molar area, the cusps, we can see also that this is actually very good models for thermoforming appliances, for instance. And if we look at the same resin, and this is actually a picture for one of our key opinion leaders, Dr. Antonino Cacioppo, the same resin in different printers, we can see that there's also an effect in the optical clarity of the part, where in the Form 4B, we now get a much clearer part than in the Form 3B. But we know that speed is nothing without accuracy. So this video is also from Dr. Antonino Cacioppo. He actually tested the accuracy, for example, for this, let's say, full arch surgical guide, testing the fit of the metal sleeves. And we can see that actually the fit, it's really good and it's superb, and it fits perfectly. And this microscopic, let's say, recording actually enables us to really make that judgment a little bit, let's say, more realistically, and you can see here the fit of the metal sleeve adjusting to the printed surgical guide. So again, speed is nothing without accuracy, and this is a proof of concept of that. Now let's look at the Form 4BL. So the Form 4BL is using this, in essence, the same low force display technology, but of course, as the name says it, is a larger volume production unit. So we want to actually bring this hardware a speed that scales, so opening a new era of dental manufacturing. So this new hardware unit enables for high throughput. You can print more parts per print with fewer interactions. You can also print very fast, so you can print 32 models in 14 minutes. Also, we wanted this to be a reliable printer that you can really rely on and print all your full production here. It's accurate, so the same accuracy as we see in the Form 4B, in the Form 4BL. So if you want to print restorative models, you would get that accuracy on spot. Also that you can, let's say, swap between materials. There's a lot of dental applications that are also enabled in the Form 4BL. And also, it's still easy to use, and you will see, because of the cost of the resin, the cost of the hardware, and the fewer interactions, you will achieve a faster ROI with the production with this hardware unit. So a couple of differences we see that compared to the Form 4B. The Form 4BL does have a bigger build platform, so specifically 2.7 times larger build surface compared to the Form 4B. So we expect 3 times fewer interactions also with the printer. So you can, for instance, print everything in one batch, and then instead of coming in and out to, let's say, post-process parts, you can just print one thing in one go, and then just have one single moment where you do all the post-processing. Important thing to know is that this, let's say, hardware unit is also going to be compatible with the resin pumping system. So you can use the 5-liter resin containers to keep on feeding your printer and not having to swap, let's say, the cartridges of materials. So here we see a little bit of the Form 4B and Form 4BL also compared to the Form 3BL. So the Form 4BL is less wide and similar depth and taller compared to the Form 3BL. One thing to note is that compared to the Form 3BL, the doors open sideways instead of upwards. So that is important to know when you're considering structuring your space. Now you don't need to have more room on the top, but because the door opens sideways, and you can see here how you can fit 32 models flat on the build platform instead of 11 like in the Form 4B, and the footprint. So again, this is a very clear comparison of how you can get 1.9 times more throughput. So if we do an estimate, you can produce more than 120 models per hour. And if we look at, for example, restorative models printed with precision motor resin at 50 microns, you can print 28 models in roughly, let's say, in about 3 hours. Whether in the Form 4B, you can print 10 models in under 2 hours. So now let's look at the post-processing solutions that became available this year. First, we also brought the Build Platform Flex to enable to use that quick release technology to remove the parts that are printed directly on the Build Platform in a much simpler way. So you have this platform for the Form 4B and the Form 4BL. So we brought that same mechanism, but to newer hardware generation printers. We also have a new Form Wash, second generation. So you will see if you have the older Form Wash compared to this one, there's an improved agitation. It has 3 more times power agitation, and which does affect in the optimal, let's say in the part cleaning, you will get a more optimized wash. It also comes with adjustable arms that enables you to adjust if you want to wash parts on the build platform, that you can adjust those arms to fit whether Form 3B build platforms or Form 4B in one wash. You also will see that you, let's say, can adjust those arms not only for depending on the build platform, but also of how much IPA you have in your resin in the Form Wash bucket. You can adjust it to be lower, so you have to fill less amount of the Form Wash with the solvent. And also, yes, you will see that you can also fill it in different levels. You don't need to fill it up to the very top to wash. You will now have indicators in the Form Wash bucket with 6, 9, and 10, 14 liters to see how much you want to fill it out. Up next, we got the Formlabs resin washing solution. So this is a new solvent brought by Formlabs with the objective of actually solving some problems that IPA or TPM have. So one of the things that happens is we know IPA is a very good solvent and still needed for biocompatible resins. So this washing solution won't substitute the post-processing for biocompatible resins. But we know that IPA is a good solvent, but it's volatile. It has, let's say, has a risk of being a flammable material and other hazards. And that's how the Formlabs resin washing solution came as an option. So what is things to stand out about this wash solution? So it's stable and cost effective. It's stable, low order chemistry, so it doesn't smell like IPA, and it cleans parts as well as IPA. And also it's a longer solution lifetime because it has twice of the longevity of IPA, so it will saturate much less. And also because it doesn't evaporate or has minimal evaporation compared to IPA, you will need to, let's say, top up less amount of times or to change it, the solvent as frequent as IPA. Actually, that it's going to be required less. It's validated non-flammable per GHS classification. So, for instance, for people that have concerns about storing solvents because of the flammability, this should not be a concern with this wash solution. And also, we wanted to simplify the sourcing, so you know that IPA and TPM are not manufactured by Formlabs, so we wanted to be able to, for users that purchase via Formlabs or via our partners, that they can also get their, let's say, solvent in the same place. Another interesting topic are the materials. So there are a couple of new materials that were brought this year specifically for model production and enabled exclusively for the Form 4B. These are fast model resin, precision model resin, and gray resin. So for fast model resin, you can print models for thermoforming clear aligners or retainers. And as we saw on all the examples before, you can print 11 models in 9 minutes. So this is a completely new formula that enables to really print super fast, even 3 times faster than rough resin on the Form 3B, and being able to, let's say, get models super fast, but also the post-processing is quite efficient. So applications recommended are actually models for thermoformed appliances or wax-up models to fabricate the silicon indexes to do the mock-up in the patient's mouth, or even if you need to try, for example, an indirect bonding tray or occlusal splint, you can print the fitment check models in this material. And also for restorative applications, we brought precision model resin for printing highly accurate restorative models. So this was also developed from scratch, solving a couple of issues that Model V3 had. So for instance, printing with a much, let's say, a less yellowish color material with a more matte surface, and also that meet the accuracy requirements for restorative applications. So when we look at the accuracy numbers in a model printed at 50 microns, when we do the surface scan analysis of the printed part with the CAD file, we saw that, for example, 99.7% of the printed surfaces are within 100 microns of the CAD model. And if we change that to 50 microns, we saw that still above 95% of the printed surfaces are within 50 microns of the CAD model, which is very, let's say, important for restorative applications and also, for instance, implant analog models. So if we look at the overall workflow time, we see that precision model resin actually enables you can print the full build platform. You can print a full build platform under 2 hours. You will wash for 5 minutes, and then the post-processing is actually no more than 5 minutes, which is actually a huge advantage when you're thinking about producing restorative models. The print time compared to Form 3B is actually significantly different. But then we also brought a couple of very interesting biocompatible materials. For instance, premium teeth resin is a ceramic-filled tooth-colored resin that has indication of temporary full-arch implant-supported appliances, what we normally refer to all-on-X appliances, teeth for full and partial dentures, so this is more like a longer-term solution, and also temporary bridges and single units. So you have both permanent and temporary indications for this material. But what we can stand out about this material is that not only comes in 4 shades like A2, A3, B1, and bleach that you can see here according to the beta, let's say, scale, is that we work to have a really lifelike aesthetic. So we work on the translucency. So for example, in the sizzle edges, you can see here that the translucency and the transmittance of light actually is quite nice. And the opalescence and the polishability. It actually polishes very nicely. I also tested this out myself, and you don't even basically need a glaze. But one of the things that I do want to stand out is that we did test the flexural strength intraorally. We tried to mimic the intraoral environment conditions and check how the flexural strength behaved in those conditions. And when we compared our material to other competitors, we saw that competitor materials actually, their flexural strength did drop when we tried to simulate the intraoral environment, but the premium teeth resin actually didn't have a statistically significant drop in the mechanical properties, in this mechanical property specifically, which indicates that the flexural strength should, let's say, remain the same even in intraoral conditions. Last material that I'm going to be sharing today is actually Bego Varseo's Trinic resin. This material actually is the first material indicated for permanent units and permanent bridges and single units of the market. You can also print denture teeth for full or partial dentures, as well as temporary single units and up to 7-unit bridges. So again, a little bit similar to premium teeth. It's a Swiss knife kind of material that has multiple clinical indications. One of the other features that are actually very interesting for dental users that also became available this year are actually some features available in Preform. So if we look at these, we now have the possibility of labeling our models directly in Preform. So for instance, you can see here this upper arch, and you can whether have that label embossed or engraved. You can also alter the text size and also define the depth. And in this case, I'm using this to label an upper arch model. So you can see that you don't need to use a third-party, let's say, system to do this, and you can embed this already directly in Preform. The second option is now that you have the possibility of creating hollow models, or more specifically, actually honeycomb models. So if you open the Scan to Model feature, you're actually able to select hollow models while creating the base. And you will see that after the Scan to Model feature ends its work, you will see the honeycomb structure and that you have this base. And also the ventilation holes are added, which enable you to print the model directly on the build platform. And if we look at the slicer, you can see further detail of the honeycomb structure. And last but not least, if you already have an existing hollow model that you're importing into Preform and you want to print directly on the build platform, you still need to add ventilation holes to avoid that suction cup effect on the model. And before you had to use let's say another software to do this, but now you can do this directly in Preform, which really streamlines the workflow and enables users to do this step already in one software. So this actually empowers our users with these new features, especially for model production, and that these also became available this year. So now let's talk about Open Platform. What is Open Material Platform? It's actually a collection of 3 products for users that are compatible with the Formlabs SLA line. So this has 3 things: certified materials, Preform print settings editor, and open materials mode. So what are these? So basically these are actually, you can see here, so Formlabs certified materials is a curated selection of premium certified third-party resins on Formlabs printers. It's free to access to anyone with a Formlabs printer. So this means, and this is exactly the example of Bego, our sales maltrinic resin. Then there's also Preform print settings editor that basically you can access that already in Preform. You can adjust a couple of print settings, for example, control exposure, layer height, resolution, heating, wiping, etc. for some of the existing Formlabs resin, except the biocompatible resins. And last but not least, there's also Open Materials mode that is going to unlock the possibility to print with any 405 nanometer photopolymer resin on the Formlabs SLA printers. So this will empower really researchers and expert users to experiment with this advanced print tool. So how to access this? This one, yes, has an additional cost per printer, but is a one lifetime license fee per printer. So you can see this has been a very busy year with a lot of new things, but Formlabs is always working on bringing new solutions. So stay tuned to learn more in the next upcoming years. So there's definitely going to be more to come. I really want to thank you for your time. We hope that you find this session as a very comprehensive summary of everything that has been launched this year relevant to the dental field. And that if you have any questions or need any extra information, we will be happy to answer any of these. You can just reach out to us and we'll be happy to assist you. So we hope you enjoy the User Summit and we see you next time.
Hey everybody. Thanks for coming in, coming back, sitting down, and hopefully getting some SLS learnings out of your next 20 minutes. We talk a lot about our SLA products and our SLS products, and today I'm really excited to give us a little bit of insight into what's new in SLS. I'm Matt, I'm a product manager on SLS, and after me we'll have Matthias again from Brose with his promised second half of his presentation, which I think you guys will enjoy very much. So today we're going to do a quick recap on what's new with Views, but this is a user summit. I think you guys, more than getting the updates, you really want to walk away with something interesting that you can learn more about your ecosystem. So we're going to get into some productivity tips and tricks, and then we'll finish up with a user highlight from Brose. So at some point, we will get to, there we go. So if you know our products, which I think all of you guys do, you know that they're very easy to use, they're very reliable, and they're very versatile. And this has earned us many, many happy customers across SLS as well. There's a reason why more than 50% of all SLS users choose the Fuse ecosystem. For one thing, it's very easy to use with a complete end-to-end ecosystem that takes you all the way from creating your parts in CAD all the way to getting a finished, clean part with automation in between and a very simple, easy-to-use ecosystem. We're also a very versatile ecosystem with a bunch of different industrial materials for pretty much any application you might need, whether that's soft or stiff or flexible. And of course, the ecosystem is also very reliable, which has earned us many happy customers who trust Fuse for the toughest jobs, for innovating, for driving that innovation as fast as possible, and for all kinds of new types of applications that we just keep building on every year. And that is powered by the Fuse 1 Plus. I'm a huge fan of this printer, obviously. It's a industrial workhorse. You can get your same-day SLS parts. It's incredibly fast. And you can get a very large set of materials, all of which work very well for different applications. But productivity isn't just about printing. It's also about post-processing. So the Fuse Blast, which we announced last year, really takes you to that next level of productivity with automated, completely hands-off part cleaning. We now also have a polishing add-on. So if you haven't tried one of the samples, we've got a bunch over in the other room. But you can get really nice, smooth SLS parts that don't necessarily look SLS printed. Very cool. As well as really nice ergonomic functions for manual assisted or manual handheld cleaning for all kinds of parts. And you know, as Nick said before, all of this innovation is driven by you guys, our users, who have been telling us that you need accessible SLS, you need performant SLS, you need productive SLS. And we were going into 2024 trying to think of what is it that you guys need. And you told us that you need even more of all three of those things. And I'm happy to say that this year we delivered. So we had the biggest SLS set of products that we launched this year ever. And we're continuing on an awesome path forward. Just to highlight a couple of these things that I think are really exciting, we have even higher throughput through awesome algorithm and software improvements. Now you can get 14 hours for 95% of all full nylon 12 builds, or 8 hours for an average customer print, to really get you that same day part throughput. And that means that our customers have been able to get massive productivity gains. So now they've got fuses printing end-use parts in industrial situations. For one example, we have this a real customer printer that is going almost half a ton of printed parts per year over 349 jobs, so almost 1 print per day. And we're getting more and more customers getting up to this level of productivity and really pushing the limits of Fuse. So we've also really focused on production economics as well as production throughput. So with bulk powder pricing, your part costs can scale with your usage to make sure that you're getting the most out of your fuse as you continue to ramp up. And of course, we've continued to give you even more applications. For example, with nylon 12 white, for the first time on an SLS printer under $100,000, you can get white parts that you can then color and dye and polish with the Fuse Blast polishing system with a really easy off-the-shelf setup. So that's just a little bit of all of the different products that we've announced this year. There's a lot more, but as promised, I'm not going to just give you the pitch on the ecosystem. You guys know why it's awesome. But I want to give you guys a little bit something to walk away from this with. So we're going to pivot a little bit and talk about mastering productivity on the Fuse. So how do you get to be those customers printing half a ton of parts per year, right? We're going to talk about packing and packing density, a quick recap. We're going to then talk about refresh rate, and we're going to wrap it up with how do you think about labor across the Fuse ecosystem. So real quick, you guys know this already, but on SLS, you get your sintered parts, and that's supported by the supporting powder, which is why you don't need supports on SLS. They're all built up within the cake. And if you take that cross-sectional view through the build, this is what it looks like. You have sintered parts, and you have the supporting powder. Now, packing density is the proportion of that fused sintered powder in your build to the unsintered and supporting powder. So for example, in the image on the left there, you've got your parts floating in the powder. If you were to calculate, it would come out to about 15% of all the powder is sintered, and that is a 15% packing density, right? And the really cool thing about SLS, as you guys know, is that you can reuse that unsintered supporting powder, and that's defined by your refresh rate, which is the proportion of that reused powder to the new powder that you add into the next build, right? So for every build, I go to my SIFT, I tell it 30% refresh rate, 30% new powder, 70% used, and then I start my next print, right? Just to plug again, very easy to use ecosystem. SIFT does this for you. You just push a button, it handles all of that for you. There's a reused and a new powder hopper. It's all very good. But if you've been paying attention to the last 5 minutes, I'm going to do a little bit of a pop quiz here. So we're going to show you a couple different builds and see if you guys can guess which one of these, given packing density and part cost, you think would give me the lowest part cost? So which one? Which one do you think? Is it A? Let's get a show of hands. Is it A? Nobody. B, C, or D? D? Okay, yeah, we got a lot of hands up for D. Okay, we got a lot of smart people in the audience here because yes, in fact, the lowest part cost is number D, or letter D. And that's because we've got a really high packing density. We got a lot of parts in there, making the most out of our 3D space. But if you were to look at B, you might see that that is very expensive, right? What is different about B? I thought that I can reuse all my powder. This is where the interplay of packing density and refresh rate comes in. So if you have an average build that you keep printing and it's at 15% packing density, you actually can't reuse all that powder for the next build because you can only get 70% used, right? So you see there's a mismatch between that used powder that I'm producing and the used powder that I can reuse. So a quick thing to take away from this is match your packing density to your refresh rate as much as possible. Get the most out of that build space, get the most out of that build volume, and then you're going to get the best part economics. Now, that's pretty easy to say and not always very easy to do in every case. In fact, I just pulled this from our some user data, and it turns out most builds are not hitting 30%. You're just throwing parts in there. You want them next day. I totally get it. So if you're in a really production circumstance, then yes, you can iterate and optimize. But what you can also pull away from this is when we're talking about labor and costs, something you shouldn't do is spend time recovering more powder than you can reuse. Now, before the fuse blast, people felt they really had to clean in the sift a lot. Now that we have that, you can throw your parts, they'll get cleaned. But we still have a lot of people who are wondering, how much powder do I need to recover? The answer is only as much as you need to actually reuse. Now that's, again, really easy to say, but in practice, this is kind of the decision that people have to do on a day-to-day basis when they're cleaning off their parts in sift. And the question is, what is enough recovery? So again, we're going to do a little bit of an exercise together, some shows of hands. The exercise here is we're going to track this build. On the top left, you've got 0% recovered. It's still in the cake in sift. And the bottom right, you've got fully cleaned after a fuse blast session. And we're going to step through different stages of clean and try and figure out which one is 70% recovered. If it's A, B, C, D, or E, none of the above, just doing it visually. So can I get a show of hands? Who thinks that D is the 70% recovered? Okay, no one really. Okay, one, there we go, one person. Okay, how about C? Does anyone think C is 70%? Okay, we got a couple, 3 hands. How about B? Is B 70? Okay, we got 3 hands, 4 hands, great. How about A? Is A 70% recovered? Okay, most hands for A. How about E? None of the above. Ish 2. Okay, we're really evenly split here. We got a bunch of experts here, and I think this kind of shows that it's not super straightforward. The answer is actually E, none of the above. These are all more than 70% recovered already. After 5 minutes, you've already gotten back more than 70% of the powder that you need for the next build. And I wasn't just doing this to point out that you guys don't necessarily know how clean it is. Experts spend too much time recovering powder. I actually went out and, as a good product person, did some surveys, in this case of internal formling experts across the globe, to try and figure out when they would stop cleaning. And you've got there a step 1, 2, 3, or 4. And as it turns out, only 4% stopped too early, and more than 50% of respondents would have lost money based on the amount of time they were taking recovering powder. So the first cutoff that you have there is the refresh rate cutoff, which is when you'll actually be able to reuse all that powder. And the second is the labor cutoff. At that point, you've already recovered more than 93% of all your powder, and every extra minute you're spending is actually just labor. You're just, I mean, I know it feels good, it might be therapeutic, but at that point, if you're thinking about it in terms of cost per part, that's actually where you should probably stop. So if we can pull anything away from here, it is that, number one, yes, match your refresh rate to your packing density as much as you can for best economics in a production circumstance. Keep iterating, increasing that packing. And number two is you're spending too much time on sift. Most of the time, you're probably spending too much time trying to get powder back. Take the parts out, knock them off, and you're probably already at 70% in the first 5 to 10 minutes. And if you have the fuse blast, it makes your life a lot easier as well. So With that, I hope you guys have learned something. I hope this was really educational. And now I'm going to hand it off to Matthias, who's going to take you through more real-life user experience of getting the most out of a fuse. So I'll pass that along. There you go.
Thank you, John. Yeah, welcome back, actually. And thank you very much again for having me. In case you missed the earlier introduction, I don't want to make it too painful. So my name is Matthias Schulz. I do work for Brose. Brose is a global automotive and e-bike supplier. One thing to add to what Matt was just saying, right? And when we talk about sifting, right? And I didn't prepare that in the presentation here, but when you talk about sifting, one option that really helps us is you can play with the temperature for your cookie, right? And then when your powder cookie comes out, right, you can, when you play with those temperatures, you will find out it can break a little bit easier loose than otherwise. So yeah, make sure you use that feature. That's a really good option, at least for us. It works. It really depends on a little bit on pack density, right? If you have to go up or down, so you really have to play with it. But if you have repetitive prints, that really helps. Okay, let's talk about Brose and how we are set up, why we choose Formlabs, why it is important for us to work and continue our work with Formlabs. So first of all, we have additive technology split up in 2 locations for Brose, right? There's a headquarters in Germany, which does also R&D work, right? They also hold some patterns and have some PhD folks available to actually push the envelope, right? And then we created another location within my department in North America. We're located in Urban Hills, Michigan, right? And from there, the initial idea was to create a chop shop. To create a chop shop that prints single parts and prototype parts, right? But in a matter of fact, we realized pretty quick that the technology gives us way more than just those single part prints. So yeah, we found a way to get actually into serial production. But going to that point, why we did choose Formlabs and why it is so important for us, right? We looked for a partner that is, first of all, US-based, right? Because we needed support quick. Again, I didn't want to build an R&D center. I needed somebody, in case the printer breaks, has an issue whatsoever, that I can have somebody on site quick, right? And especially when you talk serial production, and Formlabs acted to that point very often. We had turnaround times from 24 hours of them supporting us on site, et cetera. So this is something that was really crucial for us to make that happen. On the other hand, we looked at items that are low maintenance, right? We didn't really want to invest into the high labor amount, so that was a big point for us. And if you look at the fuse in particular, if you change over and if you have 2 build chambers, which is key, right, then you can change overs within minutes, right? Yeah. Yeah, that was another big point, and then of course a turnkey solution, right? You have with Preform software that kind of does it for you if you want to, right? You can now go into more details with the PSE and etc., right? That Formlabs offers, like I was just talking about with the powder cookie, right? But if you don't want to, you literally can drag a part in there and yeah, get a good result, right? Yeah, now talking about how we got into serial production, right? So when we talk prototype for automotive, and especially in our area for seats, right? Prototype is not just your 50 parts, right? Usually we talk somewhat between 100, 500, 800 parts for prototype builds, right? So for a lot of people, this is already like a small serial production. For us, this is like everyday business, right? Yeah, so on this side over here, you see a gear housing actually that we printed, right? In this case, several hundred were needed. We definitely, when we go into higher volumes, always choose SLS for a simple reason, because again, I mentioned labor, right? We try to do it lean and efficient as possible. I'm not a big fan of support structure, so that really like helps us over here to make the decision pretty simple, right? On the other side, you see where the 2 technologies actually meet, right? Where you can use SLA and SLS in conjunction. So this is actually a comfort mat, right? The comfort mat later gets installed into your seat adjuster. It's basically where you sit on to give this nice, comfy feeling, right? For the SLAs, we do use the Form 3s, Form 4s, right? We have several dozens of those actually throughout the Brose group. And I can tell this over here, and I discussed this earlier with Formlabs. I'm not getting paid for this, by the way, right? Yeah, but we had several hundreds of prints already on the Form 4, and we had literally one failed print. So this thing is so reliable, it's almost unbelievable. So yeah, no matter that they, or no wonder that they made it on the Times Magazine here within 6 months, right? Yeah. Now let's talk into the transition from prototype into serial production. I think the center picture that you can see over here says it all, right? This is really like the counter and mating equipment that you need to have, in my opinion, right, in order to make this transition. This is a blue light scan that you can see over here. So when we do prototypes, very often we do reverse engineering, right? So you have a physical part, you make a modification to the part, you scan that part in, and you use that blue light scan or structural light scan, right, to reintroduce the part into the 3D printer. You get a solid 3D object that you can directly upload into Preform, no issues. So this is also the key technology to transfer over into serial production, because now you come into capability studies. You need to hold different quality requirements, right? This is really key, right? So on the bottom picture, actually, you can see a pulley that we 3D printed, several tens of thousands of parts that we used for end-use customers in current vehicles on the street, right? When we talk serial production at the moment, right, we talk gap printing. What does gap printing mean? It's basically you have an existing tool and there's a design change on that existing tool, and there is a certain grace period until you get a new tool, right? This can, in serial production, vary between 12 and 24 weeks, no problem, right? So this time transition we refer to as gap, right? And that gap printing actually is what we use when we 3D print those parts that actually needed in between, right? So serial production for us at this point is not from SOP to EOP, right? It's really like some niche in between, right? But this niche is really what pushes the envelope further to get into serial production here. So yeah, this was a part that you have seen earlier. So this goes into the BMW X7. We print several hundreds of thousands of those parts actually. Yeah, that being said, now I wanted to get a little bit more into like the quick wins and also the difficulties that we had, right? I think we all share those. It doesn't really matter in which industry you are, right? Biggest one for me was supply chain management. When I created this presentation, I really thought about what can I find as a different acronym for supply chain management, because since COVID, it really ticks me off when I read it, right? So yeah, I think you all had similar struggles, right? Get material, etc., right? 3D printing, I really do not worry about it because I just hand that over to Formlabs. We never had an issue of getting material. How they made it, I have no idea, but it worked. So yeah, definitely something that you don't have to like consider when you work with Formlabs. It was a big win for me, right? Oddly enough, and that is one of the most questions that I'm getting asked for serial production, is the part setup. Like, Matthias, how do you and your team work to set up a part for serial production? To be honest, this exact same way like you do for a prototype part, for a single part. The same effort you put in there, you have to put into for that serial production part. And then, to be quite frank, it's a rinse and repeat. You just press that same button on the printer because you want to stay consistent anyways. So you're not fudging around with the program anymore after you're set up. So this is really like I said, one of the most asked questions, but I think it's a low-hanging fruit, to be honest. Yeah, sorry. I think I can answer those later. I'm sorry. Yeah. For maintenance, right? Yeah, I mentioned it earlier already. For us, the transition time in between printing a part and then going into the post-processing process has to be as short as possible, right? So having a second build chamber, taking that part out and then cleaning the printer is really like a 5-minute topic, right? So you vacuum the printer out and then you install your second build chamber and you press the button again and the printer goes while you can work your sifter, right? To not have downtime. Now let's get into the meat and potatoes here, right? Obstacles, right? Quality control, of course, a a big change, right? Now you have to, like I mentioned earlier, you have to make capability studies. You have to make in-process checks. Like we installed envelope gauges where we press through a certain amount of parts just to see if they still hold the dimensions, right? You have to make checks that your tumbler doesn't like break the parts when they like interlock with each other, etc., right? And here another good point, it was mentioned earlier, make sure you report problems back to Formlabs. I mentioned it earlier to Matt, I always feel like super important and like the highlight, because the other day I addressed to Formlabs is like, hey, I really need a cage where I can print those parts in. And then 2 weeks later, it was like, hey, Matthias, you got the cage. It was already in the makes. It wasn't for me, but right, made me really feel good. So yeah, address those issues. This is really like important, right? Then traceability is the next item. When we print prototypes, usually you print those several hundred parts or 50 parts of whatever you have, right? And then you set them aside, right? For serial production, now they actually go for us in a sellable vehicle, right? A seat structure is something that really saves lives out there, right? You put a child seat in there, you put a kid in there, right? This is really something you don't want to mess with, right? So when it comes to traceability, and it kind of falls into the quality control too, now we have to have traceability from the batch that we printed down to the printer log file. So therefore, we created labels that follow those parts around, right? Pretty neat too, right? You will see that in Preform too. You can add labels to the printers as well if you want to, or to the individual parts if you want to, right? But this is something crucial, that you don't mix up batches anymore, right? For prototype parts, very often we print like 4 or 5 sets of the same parts, and then we throw them all together in the tumbler and let the tumbler run just to save a little bit on blasting media, etc. You can't do this with serial production anymore. You have to have the traceability, right? So make sure you separate those parts. Then part handling is another good topic, right? I'm not sure how it was for you, but before we started with serial production, I called Formlabs, and there was this nice tiny FedEx box that showed up at our front door, and yeah, the FedEx driver was super happy to deliver that. And now we're getting pallets of material. So yeah, you better be prepared for that one too, right? Also, your post-processing probably looks a little bit different, right? Now there's like a media blaster that consumes a little bit more media than you planned before, so also that comes on pallets now, so yeah, make sure you have that. Then the last point, and for me personally also the most important point, is culture change, right? So in order to get into serial production printing, especially with like an OEM big name like BMW, right? It took a lot of convincing, right? We don't have to lie to each other, right? Everybody still looks into injection molding, right? It took also a lot of education, right? And very often it starts within your companies, right? We have to make sure that we educate within our companies. We have to make sure that we keep educating our customers if we have to. And furthermore, and this is what I wanted to have you, when you go out there today, ask yourself what you can do to support the education and the culture change. When you look at it right now and you find a university that gives you a legit bachelor's, master's, or even a PhD degree in additive technology, lucky you find a needle in a haystack, right? This is really not out there right now. We all need your help to make this work. This could be as simple as go out there and support a robotics class, right? If you have an old printer that you probably don't have a need for anymore, or you have an FDM printer and you can hand that to a high school, to a university, this makes a big difference, right? So try to push the envelope this way to help all of us, right? That really makes a difference. Yeah, as earlier asked, right? I'm very happy to give some answers and some questions later on, right? So catch me when I'm leaving here, right? Scan the QR code so we can connect if you guys want to, right? And yeah, thank you very much. Appreciate it.
Good to go. Hello, everyone. My name is Bridget, and I am going to be doing some post-processing today. So that's what we're going to be talking about. My name is Bridget Long. I am a strategic account specialist here at Formlabs, here to talk to you a little bit more about the post-processing journey, the things that you can do with that, and some tips and tricks about some of the things that I have definitely heard from all of you about like what is difficult about this. So I want to share some of those things. I will have a friend come join me a little bit later on, but I'm going to start you out for this session. So I'm going to start with how do we actually define post-processing? This is a little bit of a challenging one because everyone kind of defines it differently depending on what they actually want their end result to be. So some people define it as like just washing and curing your parts. Some people define it as all of the things that they do, like sanding, cleaning, all of those things. We actually loop all of those into one big kind of like holistic collection. So on the services team, for the most part, if you want to talk to us about post-processing, we will talk to you about anything that happens to your print after the print has actually completed. This is washing, curing, sanding, all of those things, depowdering, and also like blasting and polishing, all of those things. That's all kind of like under the post-processing umbrella. The topics that I'm going to cover today are kind of a smattering across both SLA and SLS. I kind of wanted to be able to cover both topics to some degree, so that's kind of what we're going to be doing today. So we're going to do support removal, dyeing, electroplating, and polishing. So we're going to do just like broad smattering from very easy entrance to much more complicated and a little bit more challenging, but also see what kind of like options are out there in the world as well. So we're going to start with support removal, everyone's least favorite thing to do. This is one of our biggest challenges and biggest complaints whenever we are talking to users about what can be done about support removal. How do I make my supports look smooth? How do I do this? So there's no like magical way to make it all better. However, there are some tips and tricks that I can offer you to kind of like help with that. Kind of like the beginning things that we always tell our users is that like you can use the flush cutters that we send with our SLA printers, with our finishing kits. This is a good like starting point and a good way to start your post-processing journey. You can use that flat edge to get really close to your parts and snip off very close so that you're not like removing additional material, but you're also like removing whatever supports that you need to. This becomes a little bit more challenging when you have a very dense like forest of supports though. So I am here to offer some additional tips and tricks. Starting with Dremels. Dremels with like a cutting disc on them are actually super popular and very handy in our dental and medical space. However, whenever I go and I talk to an engineer and they're like, how do I do this? What am I supposed to do? Usually I'm just like, have you ever considered using a Dremel with a cutting disc? And they're all like, you know, I never really thought about it. So it's not really as popular amongst like the masses, but it can really speed up your post-processing just like in general, especially if you have like a ton of like supports, like a really big part with a very dense forest of supports. This can be a way to kind of like speed up removing all of those. So you can take a giant cutting disc and actually just like cut through, get the base off, and be able to see what you're working with a little bit easier, as well as just like remove the bulk of that like extra material that like you're no longer going to need, and you could just get rid of it, get it out of your face. If you get really good at it, as most of our dental folks probably know, is that you can actually finish your parts this way as well, for very like fine detail things. A lot of like super small prints, you can actually get in there with your cutting disc and smooth out the surface. I say this with a little note of caution. When you start out, you may make some mistakes and you may cut into your model a couple of times, but with a light hand, you can usually get like a very, very smooth finish that is honestly preferred by a lot of people who are making like dentures and other medical appliances to make a nice smooth finish. So that's kind of like a if you're thinking about it, it does help speed things up, but also can be used as like a more detailed kind of like brush as well. On that note, you can also use a hobby knife. So getting a like really small blade to kind of get as close as you possibly can to your part without digging into your part is going to leave you a very easy to clean surface, and or just like a surface that is not going to be like pokey to the touch, even without any additional sanding. If you follow along the curves, it makes it really, really smooth, makes it really nice, and can really help. This is mostly used by people who are printing much smaller things. However, I have seen people use much larger parts and go in with like some of like the finer details and really like cut out like those little support pieces that they really want to make sure are actually like well defined and you're not like cutting those off by accident. Or sometimes with your flush cutters, you'll like snip a support and it will break off a piece. This can give you a little bit more control on that and help you out. And then there's our favorite secret third option at Formlabs, which is just ripping the supports off of your models. This is most popular for our Form 3s with the like light touch supports. It is a great way to do your post-processing very, very fast. For big chunky models, I'd say this is probably the most efficient way that you can do that for removing all your supports. And honestly, once you figure out like the motion of the twist and pull, it is one of the fastest things that you can do to get supports off of your parts. And it is like kind of messy, I'm not gonna lie. It can leave behind a lot of marks on your parts. Sometimes it can leave scratches and things like that. But if you're just doing this as like a very quick, like I need a quick model as like a visual, that is definitely something you could do. You can just like twist them off, pull them apart, and you're good. The reason that we kind of like recommend a lot of these things and some of these additional kind of like tips is that you actually want to leave behind like a lump on your parts is actually preferable. A lot of people don't really think about that. They want it to be as flush as possible. Or when you're ripping off supports, you can actually leave a divot in your part. So we like to recommend ways that you can actually leave a little bit of extra material that you can then sand off later. And that's actually how you get your smoothest finish, because if you're taking dimples out of your parts, those are actually probably going to be way harder to sand out, way harder to finish. And you have to sand off layers of your actual finished part in order to get there. So we usually recommend that you leave a little bit of a bump, which most of these are going to do the trick for. Pulling off your supports is a little tricky, but sometimes you can get it to work, sometimes you can't. Next, I'm going to talk a little bit about dyeing. This is a little bit more of a fun topic rather than like a this is how you should be doing your things. So dyeing parts is actually a relatively easy way to make improvements to your final production pieces. For the most part, we do this with fuse parts. These examples are mostly like nylon 12 parts, both in white and in the original. What we use, for the most part, is RIT dye, where basically you just take a little bit of RIT dye, put your parts in the RIT dye, you pressure cook it for a little while, and then you have a colored part. This is really great for like not wanting to add any additional like coatings or materials onto your part. You still want it to be your original material, you still want it to be your original parts, but you want it to have some color. This can be really nice for like examples of things that you're going to be showing at a meeting. Maybe you're showing your customer that what like the final part might look like if it actually had a little bit of color. And this can be like really good and representative, or you could be delivering a final part and you want it to actually have some color rather than just being gray or white. Some people do desire those things, and that's totally fine. But if you're looking for other options, this can be like a really easy way to kind of step into that world. So if you're looking for something that can give your parts a little bit more color, RIT dye is a good option. In terms of like SLA things, I don't have any like good examples up here, but like if you want to dye your SLA parts, usually you have to add things to the resin. And if you want to do that, I highly recommend you reach out to us and ask before you start adventuring off on your own. We do have recommendations for that, but dyeing nylon is actually pretty easy, and like it's after the part is already done, so there's very little risk to doing any like damage or anything to your actual part. Electroplating is another kind of just like additional thing that you can do to your parts, kind of like after your print has been completed. This is a little bit more of an advanced one. This is not for everyone. However, it can have like great benefits for your like final parts, especially if you're doing very complex geometries that you want to have kind of like metallic properties. So electroplating, you kind of have to have a good setup for. A lot of people who do this, they either have their own setup in their lab somewhere, or they are outsourcing to someone else to do this, because it is a little bit more of a challenging one, but it comes out with like really great results. So basically what you're doing is you're taking your material, you're electrocuting all of it, and you're moving your material over to the other one. So that's kind of how you're getting your electroplated part. You get a pretty clean and smooth finish off of this for both SLA and SLS parts. You can do this on both. And they actually come out pretty clean, pretty smooth. It can be slightly unpredictable in terms of like some of the finishes if you're not doing it quite right. But if you are kind of like getting it going, it comes out very smooth, and it kind of like gives you an increase in structural properties because it gives you a shell of metal around your plastic, so it gives you extra structural properties. It also makes your parts then conductive, so you can add conductive properties to your parts without having to add anything to your material overall. You just kind of add a coating to it instead. And it's still very lightweight, pretty low cost, instead of making like full metal pieces, which can be rather expensive to machine. You could just kind of like add a coating on the outside, and that kind of helps with the cost, or just give your parts a metallic finish if you just want them to look that way. Is also a good option, and can also be very beneficial if you are trying to show this off to a customer and you're like, hey, I want this part to eventually be a metal component. This is what it will look like. You can add like an electroplated coating of whatever metal that you are trying to show off, and that will give you kind of a good idea of what the results will be. The weight will be a little bit different, but the part will look the part. And then my last topic for today, I'm going to talk a little bit about polishing. This is one of our most sought after, most asked questions that we get on the services team and just at Formlabs in general. People want their parts to be shiny, particularly the clear resins. They want them to be as clear as they can possibly get them. So for SLA, there's a lot of options out there for how you can get a little bit of a shine and a little bit of polish on your parts. It doesn't have to be super duper intense. You can get super intense, but you don't have to. So we have a couple of like different examples kind of like on this slide of like things that we use in order to get a little bit of shine. If you're looking for something really, really easy, you can just go in and you can just like get a piece of sandpaper, sand off those little support nubs, and then just add a little bit of like mineral oil. For when I first got here, they handed me a bottle of Johnson's baby oil and said, put this on your part. And I was like, okay. And it adds like a really nice shine. If you are like sanding your parts, or if you scratched your parts when ripping off supports, it can help kind of get rid of that like dusty look, or kind of like disguise some of those scratches. So using like a little bit of mineral oil, you can rub it in with a paper towel, you can rub it in with your hands, and it actually comes out with like a pretty nice shine on it. And that's kind of like the easiest thing that you can do to add just like a little bit of shine to your parts. If you want to get a little bit more advanced than that, you can get a clear coat of paint of some kind. You can just kind of like spray that on. This one's a little bit trickier for much more complex like geometries, because you got to make sure that you're painting all the nooks and crannies to get a nice smooth finish. But if you have like relatively flat parts, actually like spray painting your parts with just like a clear coat. Most clear coats work. I don't know if we have like super specific recommendations, but I'm sure if you went to a hardware store and asked somebody like, hey, I want to put a clear coat on a piece of plastic, how do I do that? You'll probably get a couple of really good answers, and be able to just kind of like grab one, spray it on there, and get like a much nicer like clear finish. It kind of just like helps polish things off. Additionally, you can paint on either a clear coat, a clear paint of some kind, or you can paint on actually an extra layer of resin. So if you take like a paintbrush or something and you dip it in the resin, you can actually like paint that over, or you can dip your parts into a layer of resin. If dimensional accuracy is like super important to you, this is maybe not your best option. However, it does make your parts super duper clear, and if you can then go in and like maybe like polish up and change the shape a little bit, that is also probably going to look really nice and give you a very, very crystal clear kind of like infill on all of your parts. And then lastly, I kind of wanted to mention something that is also much more popular in our dental medical spaces, but using a polishing wheel with a little bit of just like polish on it, putting your parts up there and just running it through after you have sanded your parts can give you like a fantastic shine on a lot of your parts. Going through and making sure, and you just run it through a couple times. It's usually really, really quick as well. Like you don't have to spend a lot of time on it. Just take a pair, like this person is not wearing gloves, but if you wanted to, you could take a pair of gloves and just like run through it, and that way you don't get it on your hands. So these are kind of just like a few tips that I have for SLA. And then for SLS, I wanted to talk a little bit about polishing these parts. SLS is notorious for having a little bit more of a crunchy surface, as I like to say. So it is a little bit rougher, it's not quite as smooth as like our SLA parts. They come out, they have a pretty smooth side. So I want to talk a little bit more about like cleaning these and like making them a little bit more shiny and a little bit more smooth. So you can take your sifted potato that is covered in powder. It's very crunchy. You take that, you put it into, well, we use the blast, but you can put it into any media blaster with a little bit of glass media, and that at least gets you a nice clean surface and removes most of the dust that you're using. That's gonna give you like a pretty clean, pretty nice finish. Most people are done, they're good with that. However, some people want something a little bit more finished and also wants a smoother surface to do some of these other post-processing steps. So if you wanted to add like an additional coating on top or something like that, this is a good way to kind of like start that out. So you can kind of like compound the just like the outer surface of your parts. There's that porous like first layer on your fused printed parts that would basically with the polishing system you should go in and you pack them all together, make it much smoother, gives it a nice shiny look. And this can be done with the blast, or if you want to do it in some other way, you can, with another kind of like polisher, tumbler. We recommend the blast just because that's how we made it. So like this is super automated in our own system, but can be made to work through other systems if you are really looking to do so. So that's it for me. I am now going to hand it over to my good friend, Phil Sau, a renowned name on the services team for getting very innovative with finishing and getting lots of things done. So I'm going to hand it over to Phil.
Thanks, Bridget.
Let's go. That's back.
Okay, cool. Thanks, Bridget. I'm losing my voice a little bit because I've been like having too much fun talking to everybody, so probably should have paced myself, but I apologize if it cracks a little bit. I'm pretty thrilled to be here. I've known many people at Formlabs for many years, and yeah. So my name is Phil. I'm a mechatronics engineer. I have a background in mechanical, electrical, software, and firmware engineering. I've worked in various industries from medical imaging, particle accelerators, robotics, and consumer electronics. I'm also the founder of Ember Prototypes. We're a small, bootstrapped, rapid prototyping, consulting, and product design firm in Vancouver, Canada. I fell in love with 3D printing back in 2013 and started my SLA journey with Formlabs in 2018. And Formlabs has been a really big supporter of me ever since. So here's a picture of our small space at Ember. It's around 200 square feet, which is kind of crazy. And we use 3D printing in 3 main ways. The first way is we print as a service. So these are some example parts for a skeletal traction kit for a local medical company called Arbutus Medical. We also use 3D printing to, do the videos not work? Okay, I guess the videos don't work. It's kind of a problem. But anyways, we use 3D printing to design and iterate on complex products like these air quality devices for Haven IQ.
And we also use 3D printing to design and produce our own in-house products, like these optical calibration tools for multi-head FDM 3D printers. So I think we all can agree that post-processing kind of sucks. And throughout the years, I've learned some tips and tricks to make it suck a bit less. And I want to share those with you today. So I know this presentation is called post-processing, but I truly believe that the path to a perfect part starts at the beginning. So Preform is a pretty amazing piece of software. It achieves very high success rates and works out of the box for a lot of different materials. It also has some very powerful editing features that, if you understand how to use, can really help make your life easier when it comes to post-processing. Okay, so this was supposed to be a video. All right, well, it's not a video, but I'll kind of describe what it was supposed to be. This is a pretty complex heart model in elastic 58 resin. And it's a very difficult part to print. There's a lot of cavities, it's thin-walled, it like bounces around a lot when you print it. And what I wanted to show was that sometimes auto-generation doesn't put supports exactly where I would like them to be placed. And using some of these editing tools can really help when it comes to difficult parts like this, but also when it comes to post-processing. So I'll kind of describe in words what this was supposed to look like. Basically, for this part, if I hit auto-generate, it would create a whole bunch of supports. It would also put some supports in the center of the heart, which is not what I would prefer. So, and then if we flip to the back, it would also not support the back of the heart with much density, but it would support these mounting points with very high density. So it wouldn't support the back enough, but it supported the mounting points too much, which made support removal difficult. So what I was going to show is that using the manual editing tools can be really helpful. And my workflow was basically, I would disable internal supports, and then I would use the support paintbrush to manually put supports on the back of the heart at the density that I want. And then I would also support all the local minima on these parts and add additional supports where needed, and then step through layer by layer to like inspect that everything's okay. It's a bit hard to visualize without the video, but using these tools can really help with difficult parts like this, but it can also help with post-processing. So this is the heart model fully printed. If any of you guys print in elastic 50A, I think you'll appreciate how hard it is to get really clean parts like this. Another example of where using these editing tools and pre-processing can really help is shown here with these parts. So on the left side is a rigid 4K part that's been auto-generated. And on the right side is me aggressively removing supports from the inside and outside faces. Not only does this mean I don't have to sand the part as much, but it also leads to a pretty significant reduction in resin consumption. If you're a beginner, I don't recommend doing this because it can increase the chance of part failure. But with experience, knowing what you can get away with can be really helpful for minimizing sanding and post-processing, especially if you're making these parts in any production capacity. So the next topic I want to discuss is sanding and polishing. But from a perspective of I hate it and how can you not do it? So Formlabs' low force technology is already very impressive. There's many cases where you can take supports off and not have to sand your part. But there are ways that we can minimize the need for that even further. And that's by lowering touch point sizes. So I've shown a table here. And on the right side are the support sizes that I typically run on parts. You can see that they're routinely 0.1 to 0.2 millimeters smaller than the default print settings. That doesn't seem like a lot, but it's actually quite significant when it comes to sanding and post-processing. Again, if you're a beginner, I don't recommend doing this because it can increase part failure, but with experience, this can work really well and save you a lot of time. That was also supposed to be a video, but you can see here that if you lower touch point sizes and you are careful about where you locate your supports, you can get pretty flawless parts that just come off the supports with a perfect surface. So that top surface here was the supported side, and it's flawless and does not need sanding at all. Using some of these tricks also means that you can get pretty good optical transparency without the need to do any sanding or polishing. A lot of the things we see on YouTube and stuff is like people sanding for hours, people polishing on a wheel. But here are some examples of 3 parts that we printed in clear resin, took off the supports, and just sprayed with clear coat. And you can see that they have pretty acceptable optical clarity. I have 2 last tips for this section. The first tip is we use a mixture of 80% Novus and 20% mineral oil in a small spray bottle, and we mix it together. And we use that to polish parts without leaving an oily finish that just mineral oil would end up doing. And the second tip is that I will often remove supports from parts before curing because it tends to leave a much cleaner finish and result in less sanding. But there are some caveats around that. And so that leads me into my next topic, which is about curing itself. Formlabs has a very impressive material library, and in my opinion, is like the biggest reason to adopt into the Formlabs ecosystem. These photopolymer resins all require a heated UV post-cure to unlock their maximum mechanical properties. But this same heated cure can sometimes lead to warping with certain geometries. This depends on a bunch of factors like part geometry, print orientation, material property of the part. For example, flexible thin-walled parts are more likely to warp than thick, rigid parts. To combat these edge cases, we've come up with a flowchart that has worked for the majority of things we do, ranging from our service bureau to our product design work. And how this essentially works is, the first question is, we ask ourselves, do we need the exact mechanical properties that are specified in the data sheet? In other words, are these parts just for a fit test, for an investor demo, or do they need to be load-bearing and fully functional? If they don't need the exact mechanical properties, then we will almost always remove supports first before we cure to minimize post-processing, and we'll cure it without heat for 3 times the duration. And this has always prevented warping from happening. If we do need mechanical properties, then we'll ask ourselves, is the part large, long, thin-walled? If it is, then we have to leave supports on when they go through the standard heated cure. If they're not, then we can often get away with removing supports before they go into the standard heated cure. This is an example of a product that I designed, and we had printed 100 of these enclosures for a beta test. Because of the part geometry, print orientation, and material property of these parts, the gray parts specifically, they had a tendency to warp when they went through the standard heated cure. So following our flowchart, in order to minimize or eliminate warp entirely, we ran those through with no heat for 3 times the duration. And so my last topic is something that I think we seldom talk about in the additive manufacturing industry. So I'm pretty thrilled that Formlabs wanted me to share this. And it's about how we minimize our waste. So SLA 3D printing requires a solvent to wash off excess resin from your parts. And once the solvent is fully saturated, it needs to be replaced and disposed of. We used to pay a chemical treatment facility to take our waste, only to find out that they burn it. Like, they literally incinerate it. So we wanted a better way to deal with our waste, and we talked to our friends at Formlabs and ended up buying a solvent recycling system. So how this works is that basically you essentially pour your saturated resin into this bag, and this machine will boil it, condense down the vapor into a new bucket, and you have crystal clear fresh IPA in that bucket. And all the solid waste is left in this bag, which just gets disposed of. Again, this was a video, but that's okay. What this means is you don't have to store as much IPA in your space. It's more cost effective, it's more convenient, and it's also just better for the environment. So for our business, it's been a no-brainer, and I would highly encourage everybody else to at least look into solvent recycling. That's all the time I have for today. If you want to chat, I'm on social media, I'm on YouTube. I'm active on the Formlabs forums. You can come chat with me after this. Thanks for your time.
All right, thank you, Phil. One more round of applause for Phil and for all of our speakers in the first half. We have, for our online audience, we're going to show a video from BD Medical, and then after that, you'll get a bit of a break. For everyone in attendance here, this is lunchtime, so you can all take a break. We have, meet us back here in just under an hour at 1:30 Eastern Time. Thank you guys so much. Enjoy your break.
Good morning, Formlabs User Summit goers. My name is Clara Mandrasova, and I'll be talking about 3D printing medical devices at BD. Did you know that according to the latest BCC research study, the demand for 3D printed medical devices within the global market is expected to increase from just over $2 billion in 2024 to about $4.5 billion within 5 years. So with that, let's explore how BD and Formlabs fit in. So, Becton Dickinson, BD. You're asking yourself, what is that? What do they do? So BD is a global medical device company that was founded way back in 1897 in New Jersey. And now BD makes all different kinds of medical devices under the sun. A bit about my role. I am the lead engineer of the stereolithography R&D 3D printing lab, where I manage associates and run the R&D 3D printing lab. My background is in mechanical engineering, and I have over 8 years of experience within 3D printing using a variety of different 3D printing technologies. I love being an experimenter, looking into new 3D printing machines and materials and processes. At BD, I support key projects to further the development of medical devices and ensuring biocompatibility for clinical trials, where I love testing out new materials and machines. How does 3D printing support BD's mission? What is BD's why? BD's mission statement is advancing the world of health. How does 3D printing help BD, you might ask? 3D printing helps BD to support key projects, usability tests, voice of customer, human factors engineering studies to improve patient lives. 3D printing also helps BD to innovate next generation medical devices. We can have quick innovation and iteration of new designs and solutions for healthcare providers and patients. 3D printing can help BD to bring medical devices to market faster, and it can help engineers and scientists develop next generation diagnostic tools, medical devices, and treatments. So, what is the value of 3D printing? The main big values are the quick iteration of medical device designs, also biocompatibility. We're able to provide biocompatible parts that can be tested on thermal contact studies to our BD partners. And we can also provide some low volume production to support them. as well as creating designs that are difficult or impossible to machine using traditional subtractive methods. What has my experience been with 3D printing over the past 8 years? I remember the first time I saw a 3D printer in a shop called Micro Center many years ago, and I was fascinated when I was able to see the FDM printer just creating a really cool zigzaggy cube structure, and that really intrigued me and helped to lead me down the path of becoming an engineer and getting into the 3D printing space. So most of my experience has been with stereolithography machines. I've worked with a whole host of different kinds, from 3D Systems and also some larger ones from Stratasys and Union Tech. And I worked with a lot of different Formlabs machines over the years. I remember I worked with a Formlabs Form 2 back in college and was doing a senior research project, so the opportunity really helped me to get into 3D printing, and then was on to using the Form 3 and then beta testing the Form 4. I've also used different fused deposition modeling or fused filament fabrication machines, such as the Ultimaker, and I have also had the chance to use digital light projection from 3D Systems, and I've used a whole host of Somos materials, Formlabs materials, and know about 3D Systems materials as well. Now let's take a look at the Form 4 beta program. I had the opportunity to have the Form 4BL machine on site in my lab to test out for a couple months. But first, let's take a look at the speed of the Form 4BL versus my 3BL. After printing dozens of parts, I found that different builds could take anywhere from 96% to about 34% of the print time, with an average of about 60%. So printing on the Form 4BL versus the 3BL decreased the print time by about half. Really awesome. I also found that taller parts seem to have more benefit of printing in substantially less time. So for example, I had printed tall 10-inch parts, nearly the full Z height of the build volume, and they printed about 9.5 hours versus about 18 hours on the 3BL. Also, these bottles that you see on the left-hand side, those printed in just under 7 hours, which was about a third of the time it would have taken on the Form 3BL. So massive improvements there on speed of printing. Let's take a look at quality and accuracy next. For all three materials that I tried, the clear V5, white V5, and rigid 10K high heat deflection materials, they all had smooth walls and crisp feature details. For the clear V5, that one was clear when printing vertically or flat. There were some issues with it not being a true transparent clear and more of a misty color with the layer lines when printing at an angle. You can see that pretty well here with this bottle that was printed at a 45-degree angle. For the small holes and thin slits over here, I was wanting to see the limitations of all the different materials. So for the clear V5 and the rigid 10K, I found that it could print holes that were down to 0.02 inches in diameter. So really love that. Also, thin slits of about 0.01 inches were able to form with no problem and be cleared out. There were some issues with the white V5 being able to clear out small features. So for example, we could not clear out anything less than 0.04 inches in diameter for these small holes in the white material, and the thin slits of 10,000ths could not be cleared out for it. As far as accuracy goes, we had really great spot-on results when measuring in X and Y. So there was a bit of an issue with the Z height for some overhanging parts that were a little thicker than they should have been. Now going on to the reliability of the Form 4BL. I and my team are really happy with the changes made in this new printer. One of them is the recoder arm being attached with a clamp versus a magnet. So versus the Form 3BL that had a magnet, this recoder arm being clamped down was really helping to prevent print start failures, which we have had issues with before with the Form 3. So we're really liking that we have a clamp that is actually a recoder arm that is clamped down. I also really like the feature of preheating the resin, and then also the heating is a lot faster than it was on the Form 3BL, so we can keep the resin at the right temperature and not have to wait for 30 minutes for it to heat up before it starts a print. So we can get partners' parts started faster and get iterations to them a lot quicker. And for the whole duration of the beta trial, we did not have any crashes. So we love that. How does Formlabs Form 4's advances impact my workflow? Impacts my workflow quite a lot in terms of speed, quality, and reliability. In terms of speed, we have the opportunity to turn around parts the same day to our BD partners due to being able to print in about half the time it takes on the Form 3BL. This will lead to quicker testing and iterations of designs by our engineering teams, which will end up speeding up innovation and time to market for medical devices. For quality, the flat and smooth sidewalls of this mold that we printed, you can see on the left side, those enabled the machinist to not have to do a lot of prep work in order to have the mold fit inside the injection molding machine. And the reliability of the Form 3BL, the Form 4BL actually, to provide these molds in just under 6 hours and continuously provide flat and smooth sidewalls is really a big plus in not having to prep the mold too much with machining before getting parts injection molded out of it. In this molding example, these molds, which are of a example flip cap part, were placed into an Arberg injection molder, and then we had run polypropylene and polycarbonate through it in order to test a more flexible and then a stronger material. And versus a lot of other different high heat deflection materials, the rigid 10K material was able to provide us with quite a few dozen samples of the polypropylene flip caps. So that was really great to see that we're going in the right direction for having a solution for nearly doing next to no work in having the mold printed and then getting it ready for the injection molding machine and then getting physical injection molded parts from it. So to conclude, 3D printing provides an immense value in speeding up innovation of medical devices here at BD. The Form 4BL is a definite step up from the 3BL in terms of speed and reliability, and a bit of a challenge for achieving higher clarity. We would love a solution for getting that higher clarity without extra post-processing, especially for the Clear V5 parts that print at an angle that will require a lot of extra polishing and clear coating. Thank you all for your time. Once again, I'm Clara Madrasova with BD, and enjoy the rest of your summit.
Hi everyone, my name is Greg Holman. I'm one of the software product managers here at Formlabs. Today I'm going to kind of walk you a little bit through our software platform. We don't often talk about software, or we don't talk about it enough maybe is the thing. So I just kind of want to walk through our bigger platform, our different workflows for SLS, SLA, and then some key takeaways at the end. Hopefully you'll learn a little bit here, some things you might already know, and we'll keep going. So first of all, three main platforms when we think about our software. We have the Preform system, we have firmware, and then we have dashboard. Preform being everything to get you from a digital file all the way through to a part that can be printed on a printer. Then you have the firmware side, which is on the printer. It's everything to kind of move the motors, start the heaters, all that fun stuff, plus anything that's on the UI. So if it's priming and you're going through all those checks, that's all on the firmware. And then dashboard, that's all of our monitoring software. That includes everything from our fleet control systems all the way through to print monitoring, history, material usage, things like that that you would use on our dashboard. So we generally like to think about that as our software ecosystem, and we're trying always to get that closer together so you guys can have that kind of one experience throughout the entire thing. So today I'm going to mostly focus on the Preform side. As you probably noticed, we did put some new features out recently, so we'll talk through some of them. But we'll start with the SLA side. I'm going to go through some features that are kind of key to your workflow and might give you some ways to improve your workflow and overall improve your efficiency. And then we'll walk through the SLS side. So on the SLA side, on Preform, the first thing you always do, you import files. So we're really excited to announce that in the next few months we'll be adding native CAD import files. So yes, that's if you use CATIA, if you use Creo, SolidWorks, bring those in, but also step files. We get a ton of requests for step files. So now you'll be able to bring those right in from your CAD program, and you won't have to transition them over to an OBJ or a 3MF or an STL. So that's really exciting. That should be coming in one of the upcoming releases. It should make your workflows a little better. Next, you're going to do the orientation work and kind of get everything ready so that it's ready to print. But one of the big things that we added recently in October was model hollowing. So model hollowing will make it so that you can reduce resin consumption. Your material consumption will go down, which is great. It's great for you guys. But there's also other benefits, like reducing the number of touch tips you have. So you can keep those Class A surfaces as Class A surfaces. So you'll have fewer touch tips. It'll be easier to remove the touch tips at the end. That's better. You'll also be able to reduce your print time in some cases. So those big chunky parts, hollow them out, reduce the resin consumption. You'll have faster print times and fewer touch tips. All value add for you guys if you are printing on those larger, chunkier parts. Next thing we added was drain holes, because whenever you hollow your parts, you're going to see the whole thing light up in orange like that. You're going to have this big cup inside of it. And you have cups in many other situations, and that's we can set you up with a settings optimization engineer, and they can talk through cups with you for probably over an hour. But generally, it's just the concept that the liquid inside the resin has to be able to move in and out, and you don't want to build up pressure. So one way to reduce that is to add drain holes. So many times, our users were saying that they were going outside of Preform. So what we've been trying to do is make Preform a one-stop shop. So try to turn it in from this thing where every time a user wants to do something different outside of these normal orientation, support, and sizing things, they don't have to go outside of Preform, take their file out, bring it back in after they're done with it, and do it that way. So we've added drain holes as well, and drain holes make it so that you can relieve those cups and keep your printing going, and it will make it so you can print faster when you have cups. Just as a side note, if you don't want to add drain holes, there's also the cup mitigation mode, which can be found in the print settings editor, which is a new feature we added, I think, earlier this year, I would say, in probably Q1 or Q2. And the print settings editor allows you to edit some of those knobs. That's one of those options that you can turn on cup mitigation. It will slow your print down a little bit, but you'll be able to print with cups still. And in most cases, you'll have a pretty reliable outcome. So cool. The next thing we released is labeling. Labeling was a big one. A lot of people are asking for labeling across all the different segments. Everyone has the same kind of use case there, though, right? You're trying to improve traceability. You print something. You print a bunch of things. Let's say it's teeth, right? You print all these different teeth on a build platform. They all look like teeth on the other side. You have to take that, and you have to be able to sort them on the other side. So being able to add the text to the parts themselves within Preform rather than going back out to other software is super valuable. So we added this feature to be able to emboss or engrave your text onto your part. And one neat thing about that is that we decided that your initial condition for the label is actually your model name. So one little story there, actually 2 days ago, one of our engineers came up to me, she goes, hey, I really love this feature, and here's why. I printed a spine, so she printed a human spine for Halloween. It was part of her costume, and each one of the parts inside of it was labeled by the vertebrae number, and she needed to keep them together in an order. So she actually was able to, in one build, in one shot, just hit on each one of the parts because they all retained their model name, and she could do it all in one and then press apply, and it was quick and easy just by naming it up front the correct thing that she wanted to be labeled. You can, of course, go back and change the label names. We have that ability. It's super flexible. You can change the depth, change the size. It's really a really fundamental tool that will help you guys speed up your workflows and be able to sort those parts at the end. Cool. And then on the last one, so part texturing. Earlier this year, we put out this tool on our website that was called Meshy. I don't know, did anyone use Meshy? Meshy was on our web tool. It was great. I see a few hands. And it made it so you can add a texture to your parts, and then you can import them into Preform. We were seeing a lot of usage of this feature, so we decided to bring it into Preform to make it so that you guys can add that production-like finish to your parts, those production-like finishes that you often see on like injection molded parts. So you can add them within Preform. We gave you guys a library, so you'll see in the GIF on the side that there is a library in there that you can choose from, but you can always also add in your own PNG or your texture map that will be added to the model. And you can change the amplitude, kind of how far out it sticks, how frequently the texture kind of continues over your model. It's a neat feature that will help you get that final finish that you're looking for. And we're kind of excited, we're really excited for you to use it and see what kind of textures you're using for those different models. So that's a lot of the SLA workflow. We put a bunch of these features out to make your workflows better. Hopefully they're making everything a little bit faster. Those are the new ones. Then when you go back, it was probably like middle of last year, I think, that we added the brush support tips, right? So we added this concept where you can edit your supports using a brush tool. Back then we had been asked about like, hey, why don't you guys have a paintbrush? So we added this feature where you can add or remove your touch tips using the brush. This allows you to bulk edit your different support touch tips without having to go in and onesie-twosie them or use the box drag. So this should speed up your workflow when you're going from either direction of, many times the workflows we'll see are, they'll start by supporting all minima and then they'll add using the brush, or they'll start by supporting all and they'll remove using the brush. So those are the workflows that we're generally seeing, and the brush allows you to take a large area of those supports and add or remove them to speed up that print preparation process. So, cool. Now we're going to jump over to the SLS side. On the SLS side, there's a few new tools on that side as well that are very SLS oriented. I want to note that the tools that I just went over are both for SLS and SLA, except for the support touch tips side. SLS, beautiful, no support touch tips. I'm slightly biased, but that's a different problem. So on the SLS side, we are adding a few new features that are just SLS based. So first of all, yes, you still import those models, but we're going to be adding part grouping and folder imports. So when I say that, I mean that you can take a folder on your desktop, you can import all the files inside of it, whether they're STLs, OBJ, step files, import them all. They'll import, as you can see on the screen, right into a folder inside of it for organizational purposes. So it'll go in there, it'll keep the name of your directory, it'll be in your folder so you can manage your parts. Because on SLS, we're printing more than 5, 6, 7 parts a build. You're often seeing 100 parts, 200 parts, 50 parts. So it's a little bit harder to manage your model list. So we've really taken time to start helping you organize that model list so you can better understand what you're printing and how you want to manipulate it. So that'll work for all your different CAD file types. It will not work for form files right now, but it will work for everything else. The part grouping also extends beyond that, and you can use it in general by selecting your parts, right-clicking, and adding. This will be out in, I think, one of the upcoming next 2 releases. Next, orient and lock. Many times I talk to customers, they don't know about the locking feature, say, hey, I really want this surface to be up, but I still want to use packing. How do I do that? So when I look at it, I say, well, okay, you want to orient your part first, and then you want to lock it in that position. So here's what you're going to do. You're going to orient it. Use the little manipulator. You can, I don't know if you guys know this, but we added a snapping tool for the manipulator. So you can snap it to every 15 degrees by holding the shift button. This is a long-awaited feature as well. Small one, but it's a quality of life improvement. And you can take that orientation then, and you can lock it one of 4 different ways technically, but really 3. Lock the XY plane. So you lock it so it can only spin about the Z. Just as a reminder, the X plane goes across the front of the printer, the Y goes into the printer, and the Z goes up the printer. So you can lock it just in the XY plane, so it'll just rotate around. You can lock it in the X, Y, and Z. So you're going to be able to have 0 rotation, but you'll be able to translate about the build chamber. And the third one is complete locking, so no translation, no rotation. And the benefit here is that you're setting a number of constraints on the system itself, on that part. So when packing happens, the packing algorithm will take that and it will use that as part of its constraints for putting these parts together to get you the most efficient packing job possible. That packing algorithm is one of our great things. We'll talk about that in a minute, but these rotation and these snapping and model locking tools are ones that aren't used by some users because they're less discoverable, but it's a really important part of the workflow, especially on SLS. A few different use cases here. One, when you want the XY scaling, you're going to want that often, or I often use it when I have circular things like these gears. I want the gears facing up at all times, the circles facing up, and I want the gear edges also facing up. So if you use XY scaling, it can rotate, and it won't rotate around the XY. But on the other side, if you want XYZ, you might want that in a case where you're doing nylon 11 carbon fiber, and you have directional strength there. You want to make sure it's not rotating about the Z either. So you're going to use XYZ rotation locking to make sure that it's keeping the same rotation, the same orientation that you've chosen, but it will translate around the build chamber itself. Just a few little tricks there that we like to use when we're kind of looking at what we should be doing when we're setting up a job and how to make it easier and faster to set up jobs and use our packing algorithm. Cool. Next, part cages. So part cages are a feature that previously you could only get in Magix and NetFab, really. Part cages are actually right here. They look like this, and they're the idea of taking small and fragile parts and putting them into a cage so it's easier to post-process. So many of you guys, if you run SLS machines and you've printed small parts, you know it's a pain to be post-processing all those little parts. You lose them, you have to count them, and in that process, you're spending a ton of time. That's real active time of an employee or of yourself or someone to actually do all that post-processing. Putting them in a cage makes it so you can cut a lot of that time short by doing everything from sifting it. So I'll often just tap it against the bottom and shake it around. A lot of the powder will fall right out. And then throwing it right into the blast if you have a blast, or using a blasting cabinet to blast through it. These, actually, there's some of these back there, but you'll see these have been blasted once by glass beads, and they are really clean. At the end, what you'll do is you can break them open, just like that, and your parts come out, and the cage itself is a consumable. You can toss that away, but you've saved yourself significant time and effort that you can spend doing something else at that point. Next, packing. Packing is a great feature. Packing saves you guys a lot of time probably. Anyone that has used either Preform as of last year, like probably 3.15 or something like that, last November. I think it was last November, 3/31, we put out the new packing algorithm, which is lightning fast relative to the old one, and a much better pack job. So packing makes it so that you can take all of your parts, get them as tight as possible, and increase your packing density, which when you think about packing density, you always want to compare that with your refresh rate to understand how much excess powder you're dealing with. This can all be found in the print report, which is a tool. If you have questions about that, you can grab me after and we can talk about it. But the excess powder is the thing you're trying to avoid. So you always want to try to bring your packing density as high as possible to compare it to the refresh rate you're using. So using the packing algorithm, you'll be able to do just that without actually doing any extra work of manually packing yourself. We are continually improving this And it's, you can pack with cages, you can pack with groups. As I said before, the locking all works with the packing as well. So that's kind of, those two work really well together. And then finally, printing. So printing on the Fuse side, we're going to be adding an improvement. Some of you probably know that we added fleet control for Form 3 and 3L probably about a year ago, a little over a year ago. Fleet control is this concept of being able to manage your fleet or manage multiple printers using our dashboard interface. And you can, what you can do is you can send your prints right up to the cloud. The cloud will slice them, and it will add them to a queue. That queue can then distribute those jobs to any available printers. An available printer is a printer that's ready. If you print on Fuse or you print on the Form side, if your printer says ready, that means you've primed it. Priming, if you've used a Form 3, we used to have priming. We did away with priming on that side. Fuse still has priming. But once you get to that point, the job will be sliced. It'll be shipped to the next available compatible printer, which is great because it's going to save you time. So you can, when you're sending up the jobs are smaller, so they'll take less time to send to the cloud, freeing up your computer. So your computer, when you're slicing, is grabbing a ton of your resources. So it's grabbing your RAM, it's grabbing your CPU, and it's taking all those resources just to get the job done. You've probably all experienced it on larger jobs, especially if you print on like carbon fiber or you print on nylon 11. So imagine going from that kind of waiting period to being able to ship it right up to the cloud in a matter of seconds and letting the cloud deal with all that time. And then when it gets up there, it ships it right off to the printer, to the next available printer using the remote printing functionality. So that's going to be a big improvement. We're looking to put that out in the next, probably in Q1. And we would love to kind of get your feedback on how we can continue to improve and make this more usable for you guys as we try to grow that system and grow the usability for your use cases. So these are the big features that we've put out over the past few months. Most of them, just as a reminder, it's CAD native imports, step files. That's all coming out in the near future, not out yet. Then you have hollowing, drain holes. You have part labeling and texturing. Those are the big ones that went out this past October, just a month ago. And then we have the support touch tips that you can brush on and brush off. On the SLS side, you have the part grouping and model folder imports, which should be helpful for anyone that's managing orders or managing large volumes of different types of parts. And you'll have part cages. Part cages is really helpful for those people, like I said, printing small and fragile parts. You can also use it for big parts. We've seen use cases where people want to combine big parts for it as well. And then fleet control, packing, and that rounds it out. So those are the really exciting features. One thing I do want to note is keep giving us feedback. So last June, we put this little button in Preform. Some of you maybe have noticed it and clicked it. That button will bring you to a survey. We do read the results of that survey. Actually, it goes to a Slack channel. Many times engineers will read it, and we try to take that feedback and help that drive our roadmap. So we're taking that feedback and using that as part of our case for building features. So just think about the questions that were in that survey, which were, hey, what features do you want? And then think about the features that we put out last month. And there's a clear correlation to things that you guys wanted, things that we knew the market wanted, and how we can deliver the best experience for you guys. So the more feedback you guys give us, the better experience we can drive for you guys as we're trying to develop the right thing at the right time to make Preform a one-stop shop for everything you guys need. So cool. Thank you guys for the time. And hopefully this was helpful and informative. And feel free to poke me. I'll be around.
All right, let's get started. I'm Max, co-founder and CEO, and we've got a special session here to talk about our new developer platform. So some of you may have seen the announcement we made in October announcing these new features. We're going to go through just kind of a quick overview of what they are. But I also have on stage a few of the people building all of these tools, and they're going to show you some new demos and applications, and then we'll have a little Q&A. I think more than most things that Formlabs has shipped, the developer tools are going to be much more interactive and require a lot of feedback from all of you to help us build the right thing. So that's we're hoping to get out of this. Great. So we just launched the 4L, and that is a big milestone for Formlabs. It's with the 4 and 4L, it's the 4th generation of our stereolithography technology. We've been working hard at this for like 12 years now. And what we set out to do when we started with the Form 1 is to make 3D printing much more accessible for professionals, but easier to use and more reliable so that you can go from a 3D model to a part quickly and easily. And that's been always our core focus, and we put a lot of work into that over the years. Different features like one-click part setup, cartridges to reduce spills, quick-release build platforms, remote monitoring, and all these features are really focused on like a typical user who's got the 3D model. They want something out of a standard material, and they're happy with just print it and go. And that's still most of our users. But over the years, we've gotten a lot of requests for things that are outside of what our kind of standard platform can do. So people ask us, like, can I print this other specialty material you don't have in your platform? Or can I modify the settings and get even higher resolution out of the printer? Or I've got a lot of jobs to print. I want to automate job setup so that no one's clicking around in Preform. Or can I modify the settings to print a part faster? And many, many more requests. And typically, we've taken those things as input, as like, okay, maybe we can work on those features. But we've kind of stayed focused on what do most users want. And now with the 4th generation, we think we've gotten to such a great place on the standard, most common needs that it's time to do a better job supporting all of these other things that people want to do, and to help people really build on our platform where we become not a one-stop end-to-end solution, but a component that people can build something even more powerful on that's built for their needs. And we think of this as the same way in the software world. There are developers and there are developer platforms that people build on. Think about like iOS and the iPhone, and how a world of developers have built amazing applications that have made iPhone more powerful for everybody. And so part of Apple's job is to make a great developer platform. There's different types of developers in 3D printing. There's people who are trying to make new applications where, like, get 3D printing to do a thing it couldn't do before, like maybe direct print aligners in dental or things like that. There's people who are running a lot of printers, and they need to maximize performance and minimize costs and fine-tune the system. And there's people trying to bring new materials to the platform that increase capabilities. So there's a range of types of developers, and we're trying to help all of them with a few different pieces of the system. So the Formlabs developer platform, we've got 3 components. There's open material mode. So this is the ability to run any material on any of our systems. Then there's Preform print settings editor that lets you tune the print process for speed or accuracy or other things that you want. And then there's the Formlabs API that lets you automate using Preform and fleet control. So I'll go through quickly through each of them, and then I'll turn it over to the team to go into a little bit more detail. But here's a really quick demo of what you could do with the print settings editor. Do we not have the video anymore? Maybe not. There's supposed to be a video here showing you how you could make 25 micron print settings. So we come with out-of-the-box settings for some layer thicknesses. Nope, I'm still on this one. There it is. So yeah, so if you wanted to run a material at a layer thickness we don't provide, it's now pretty easy to go in, create a new setting yourself, and try a different layer thickness, and potentially dial in some other settings if you're trying to get the accuracy just right. And there you go, you've now added a 25 micron setting. So that's pretty straightforward to do. Then yeah, with open material mode, you get to use all of our all the capabilities we have in our printers, which I think make it one of the best platforms to develop on. So there are other open printers out there, but like for example, if you take Form 4, you won't find another desktop SLA system that has the temperature control for materials, that has the mixer that lets you run more viscous materials, resin dispensing and resin height control. All these things make it a really good platform to develop materials on. And then lastly is the API, which really can do a lot of things, but here's just one quick demo that I'm really excited about. This actually combines the print settings editing and the API in one system, and we call this speedrun.py. It's a little Python script that helps you optimize the print speed of a job. Usually you can get more print speed out of the printer than what we do out of the box with our settings. So this tool knows about a few different ways you can optimize print speed, and you can ask it to create some settings files with some of those speed ups, and then it will make jobs with each of those settings files, and then if you like, even upload them directly to a printer so you can try them out. Here it's showing a little report of the speed ups that I was able to achieve with the different adjustments, and as you can see, you can often find 20–30% speed ups on different settings. And this is really cool because this typically takes a lot of work and a lot of knowledge to get to this kind of process engineering. But if we can start to encapsulate it in little bits of code like this, we can make that more accessible to more users. And then the API is also going to make its way out to users in the form of off-the-shelf integrations with different CAD software that will be built using this API. So even if you're not a software engineer yourself or your company's not prepared to take on something like that, API is going to make the system more powerful for everyone. And that's true of all of everything that here in Developer Platform is. It should make its way into many users' hands, even the people who aren't developers themselves, either by bringing new materials to our platform or more optimized print settings or software integrations like this. So now we'll jump into print settings editor. Woody will share a bit more. And at the end, we're going to have time for some questions. So please think of some things to ask us or some feedback or feature requests you want for these systems.
Awesome. Thanks, Max. So I'm Woody. I am a materials program manager here at Formlabs, and I'm going to talk to you today about the print settings editor. To begin, what is the print settings editor? It is a tool that provides you the opportunity to modify the core printing parameters for our printers. So this allows you to fine-tune and control the machine as you see fit. During our tuning process here at Formlabs, we make lots of decisions on our print settings for reliability, for speed, for accuracy, that we believe is a great trade-off for the general user. However, for your specific application, there might be a better optimal set point for your print setting. So the print settings editor will allow you to tune and optimize for your workflow. I'm going to dive into 2 examples here today. The first one is going to having to do with alternative layer heights. So as Max showed previously, there was the 25 micron TUF 2000 setting, which allows you to improve the surface finish and fine detail with the trade-off of some slower print speeds. I'm going to talk about a fast model 120 micron print setting that we've actually seen large dental labs utilize so that they can get the right trade-offs for their business. So the question they're asking is, what if I had a setting with finer layers, but I preserve the print speed of the 160 micron fast arch setting? So if we look at our available settings, we have 100 micron, which are a default setting, and that takes 24 minutes for this scene of arches. The Fast Arch 160, which we here at Formlabs have optimized for dental applications, does take 8 minutes, which is substantially faster, but it has some surface stepping, some artifacts that a customer might like. And then we have our default 200 micron, which is the same speed, with even more stair stepping. So I'm going to show you how to make the 120 micron setting. This will allow you to have less surface stepping than the 160 micron Fast Arch, while preserving as much speed as possible for this print, so you can make sure your workflow is still going efficiently and quickly. So this is a quick video of how to make the setting using the print settings editor. So I start by finding the fast model setting in the print settings editor. So I'm searching by printer type and by material. I'm basing this off of the 160 micron Fast Arch setting. I am then able to change the layer height and rename it. For this setting, I was able to change just this one parameter to get a print that showed me the ability to speed it up and get these better surface finish. There is still way more room to optimize and tune as you are developing your print setting. I then applied the setting via the print settings editor and got the print time estimate, which came out to 11 minutes. So going to see this setting was real, we did print things with it. So if you look, we have our 100 micron print setting, which is our best surface finish of the 3. But it took 25 minutes, which is much slower than you would want for a fast turn aligner manufacturing process. As you can see, the 120 micron Fast Arch is slightly slower than that 160 micron setting, but it is substantially better in surface finish and quality. So this customer is able to choose exactly what trade-off they want for their application. We do our best to make sure our compiled in settings create the right balance, but every customer is different, and this allows you to choose what you want. My next example is going to be with a custom outer boundary offset. So with color kit resin, there is some complications here as the user can define what color it is. Adding different pigments to resin can change how it prints, and most notably, its fine feature performance can vary greatly depending on what mixture you choose. At Formlabs, we tuned so the general mix of color will come out, but it's hard to cover every single edge case of this material. So I went to print this really fine detail part, and as you can see, it failed. There are substantially under-resolved features that were just not robust enough to survive the printing process. With the print settings editor, this can be addressed using the outer boundary offset parameter, which changes the perimeter placement. So you can get slightly larger features that are actually closer to the design size. I also found that as this is a short part, I did not need to wipe during the print, and I turned that off in the print settings editor. So going in here, what does this look like? So this is the interface for the print settings editor, and I have highlighted the outer boundary offset parameter. I adjusted this from 0.2 to -0.3, which dilates the layer by 50 microns. So this is makes it a little bit more robust and larger, which is more accurate in this application. I then went and found the wipe behavior pattern. I changed the parameter from -1, which is a one-way wipe, to 0, and I applied it. With these changes, I was able to get a fantastic looking part and also save a few minutes while doing it. This is just another example of how you can use the print settings editor to optimize for your workflow. This is another application that we've seen our customers use to get the best performance from our machines. While we do believe we make the right trade-offs for the general user, every person is different, and you can get a more optimal result for your application with this system. With that said, I do want to hand it over to Alex Herring to talk about open material mode.
All right, thanks, Woody. My name is Alex Herring. I'm on the materials team here at Formlabs, and I'm going to be talking today about open material mode. I think this is a pretty cool thing for everyone to work on because it allows all of our users in a way to sort of work the way we do on the materials team here and lets us really open things up to try whatever you want to do. So what does it actually enable? There's a few different directions you can go here. One is printing specialty materials. Maybe you have a niche application already that there's an existing solution for that's not in our resin portfolio. You can bring that onto the printer and pour it right into the tank and print with it. Maybe you're trying to do materials research and development, create your own formulations. Form 4 is a really nice platform to do that on because we have all of the print settings that Woody was just talking about that we can really dive in and tune it. If you have a highly viscous material, maybe something that settles, maybe something that is slow reacting, you need to really control the exposure, you can do all of that on the Form 4. And then finally, it allows you to share your settings, maybe with a colleague internally or commercialize and bring a material to market and have it available with settings on the Form 4 ready to go. So Open Materials Mode has only been out for a couple of months, but we've already heard from our users over 25 different materials that have been printed on our printer, which is really cool to see. It's a wide range of things ranging from engineering applications to dental, medical applications, and it really shows all the different things people are doing. And a lot of this is existing solutions, but we're also starting to hear from our customers about new materials that they're developing, things that they're trying to work on for special applications, and it really shows what you can do with the Form 4 platform. So the first thing I want to talk about is materials research and development. The reason I like Form 4 for this platform, for this application, is that we can control things like heating. Like I said, maybe you have a viscous material, you can go up to 45 degrees C on the Form 4 and control that precisely. You can also tune the power. We have a really pretty powerful machine here, 16 milliwatts per square centimeter, and you can also precisely tune the exposure and how you want to deliver it. You can control the motor movement, both during the squish movement and the peel movement. And again, if you have a viscous material, that's going to really help you out in trying to get those nice parts out at the end. So one user we can talk about that's been doing this already is Polymed. They've been developing a bioresorbable material, which you may know is not in our 35 materials that we make. It's a really cool application, but not something that we've done ourselves. And we're able to see a customer who can go onto the Form 4 and create this sort of material and print successfully with it. And from talking to them, it sounds like the ability to heat the resin was really key here to get the viscosity in a range that they could control this and print it well. And so they're having good success with this and already starting to share it with the world. Another thing that I mentioned you could do is to print specialty materials. So something, maybe you have a material that already exists and you want to bring it on. Here on the Form 4, we have the wiper. So if you have something that settles out quickly, you can use the wiper to control that. Or if it's a viscous material that you need to move around, again, you can do that. You can pour the resin directly into the tank, so you can get it just in a bottle and use it. And then you can modify the exposure and really tune it in. So one thing that's nice is you can start with our material settings as a base. So if you look at the TDS for a material you find on the shelf and you say, okay, the mechanical properties are similar to one of Formlabs materials or the viscosity is similar to one of Formlabs materials, that's a reasonable starting place for you to go. And then you can tune the settings from there to get it to work with your material. A couple of our customers that are already doing this that I want to bring up, Restore 3D, they're developing really interesting cutting guides and surgical planning tools, but they have a proprietary material that settles really quickly, it's highly viscous. They're able to use the wiper, and you can actually tune the way the wiper moves, the speeds that it moves at, to prevent that from happening and allow them to print this material on the Form 4 with good success. Another customer that's been using this is Figure Engineering. They've created this resist resin, which is a really durable material. It's chemically resistant and designed specifically for masking applications in like electroplating. So this is something that they've developed, and they've been able to tune not just the basic settings, but really every aspect of the settings so that it gets a really nice, highly accurate part that you can use for masking. And they're starting to bring this to market as something that customers can buy and comes along with Form 4 settings, which is the last thing I want to talk about, which is how you can share and commercialize your settings. So you may not have something you want to bring to market, but you have a colleague that has another site with a Form 4. You want to be able to share a material you've been developing with them, allow them to work with it. You can export your settings, share it with them, and allow them to have sort of the same experience that you are on the same platform and make sure you know that you're looking at the exact same thing. Or like I said, you could use this as settings that are available with the material that you wanted to sell yourself. And then on the Form 4, you know that you're going to get a really repeatable experience, which is nice. So what does this actually look like in in Preform? Is just like Woody was showing you in that print settings editor, you have this button to export and share. It just shows up as a FPS file, which then you can import into Preform. You only need to do that once. Once you import it, it stays in Preform. And you can see that once you've loaded that up and applied it as your material, it displays in Preform as though it were just one of Formlabs materials itself, which is really, really nice and makes it easy to use and easy to share. And with that, I'm going to turn it over to Jacob.
Thank you. My name is Jacob. I'm on the software team here at Formlabs. I'm going to talk about the Formlabs API, which you can use to develop custom integrations and automations with Formlabs hardware and software. So really the main takeaway, what I want you to get for the API is if you have a repetitive or a manual workflow, you can consider automating that with the Formlabs API. The Formlabs API can fit in on all parts of the manufacturing flow, from design to coding and review, scheduling and printing, to monitoring your fleets. So example uses include integrations into design or CAD software, estimating material usage during quoting or print time, using speedrun.py to make the print faster, as we saw, getting the status of your printers and automating job preparation, batching jobs together, creating printable job travelers, and importing your print history and printer status into an MES or other software system. So I'd like to show you a couple of examples about what building an integration might look like. So the first one we'll look at is integrating your printer status into an MES, or a manufacturing execution system. This is a tool you can use to track the stages of a part going from different manufacturing stages to delivery. And we'll be looking at Tulip as the specific example. So within Tulip, you can make dashboards like this of your manufacturing floor. Here we're looking at, for a print farm, the distributions of the materials loaded in each of the printers. So as orders are coming in, you can rebalance and change the materials in printers to match that. Within Tulip, you can also use their no-code platform to build apps for operators on the floor. So here is an app giving operators visibility about what's in the queue, if anything has issues, so they can jump on it and look into that printer. Both of these things are looking at the live status of printers, and that's really easy to do within Tulip using their web connectors in the Formlabs web API. So here we're using one of our API endpoints and deciding what fields we want to pipe into the no-code platform to build those apps. In some cases,
I just want to add something on that example. What's really cool about that previous slide is this is building an integration between our system and this MES software without any code involved. So it's pretty much just kind of this interface you see there, and so there isn't a very high barrier to entry for this stuff. You can start putting together automation without a lot of software engineering expertise.
Yep. And another way, if your process is even more informal, we see a lot of people tracking things in spreadsheets, and you can use the API with that as well. For example, a common thing we see is making a printing log. So things you're printing across your printers, you're typing in the job name, which printer it was, when it started and stopped. You can also automate this process of filling in this information using the Formlabs web API. Using Google Sheets, that's really easy. You create an app script and this little snippet of code, and it'll automatically pipe that data into your spreadsheet, so you don't have to manually type that in. And next, we'll look at what automating a job preparation looks like. For example, if you're a high volume user printing a lot of the same parts, for example, a dental lab. I think they're going to play the video. So this is a script we call autobatch.py, which is a Python script monitoring orders coming in on a local folder. So when a new folder is detected, the script starts running and automatically goes through the steps of job preparation. And here, it's not only setting up the models, it's also figuring out how many fit on one build platform, and if needed, we'll create additional build platforms. So in this case, it needed 2 to fit the number of parts. And not only can it do that, it can also upload to Fleet Control or directly to printers to automate the entire job preparation workflow. Here we go. So looking at that example, If you're a high volume user, maybe you're having someone sit in Preform, manually importing parts, doing the same steps. You could automate those same steps in Preform and use our API to build a script to do that. Here we have the scripts built in Python, and we have an official Formlabs library for using our APIs in Python. But you can use any programming language, as we saw in the MES, build things without code as well using our APIs. So if you want to get started, we have our developer portal on support.formlabs.com. We have API documentation, example code, inputs and outputs, getting started guides. So it should be really easy to jump in from there. And if you're looking to get help, we have a section on the forum for developers. You can also email apiinquiry@formlabs.com for more help. And finally, what I've talked about is if you're a developer or if your company has the capacity to build custom integrations, but that's not always true. Sometimes you wish there was just a plugin you could install without having to do any work. So please let us know what those are. We're interested in partnering with other software companies to build these integrations so they can just be a one-click install. So, with that, I think we'll open it up to any questions we have right now. If not, we'll also stick around for any other questions.
This is, I think it's supposed to be a coffee break now, so feel free to get up and take a break, but we'll keep going here if there's questions.
Do you plan to keep any kind of like centralized repository of community-derived profiles for open materials?
So I think I'll repeat the question. I think the question is, are we going to support some kind of community system for sharing print settings? And yeah, that's absolutely part of the roadmap for print settings editing. Today, we don't have a special purpose system for that. We've got our forums on our website. It's a good place to share things with our community. But right now, we're getting a lot of feedback on what people want to do with print settings editing. And over the next couple of months, we're going to take that and try to turn that into some better ways to support people sharing settings. Because I think that's one of the most powerful parts of the system is there's so much great work being done optimizing, getting the most performance out of the system. If we can make it available to other people, it's going to make it more valuable. If you have specific ideas of what you'd like to see in a system like that, love to hear it.
Yeah, sorry, quick question. Is the idea later to implement those items as well from the API? Let's say we have a lessons learned over time into the dashboard as well, or is it up to the user?
Yeah, so the question is, will we take some of the things that we see people building with the API and build them into our software systems like Dashboard and Preform? I think that's one of the things we expect to happen. If there are particularly popular types of integrations or little add-on scripts like some of those demos we showed that are very popular, then that's something we would make a first-class part of our system and support really well. But this is also another area where I think we can support the community to share best practices with each other. We added a little section to our forums specifically for developers, and there'll probably be activity on GitHub and other places like that.
Is it possible currently, or is there a plan to implement adaptive profiles so I could, change print settings based on wall thickness or Z height?
So repeating the question, is are we planning on implementing adaptive print settings so that they can be adjusted on print parameters or model geometries? So we do have adaptive settings based on kind of layer heights and angles for the Form 3 and Form 3L. This is something that has been in talks about for next-gen printers as well, but they are not scheduled for any release dates or anything like that.
I can't build my own either?
We do not have a workflow for you to be able to build your own in the current print settings editor.
You could build something like that by, if it can work within our existing print settings, then you could do your own geometry analysis and tweak settings specific for a job. That would be a way to sort of hack something like that. the print settings we have exposed today is a subset of all of the print settings in the system, and we do have geometry adaptive features in our system. We are planning on exposing more over time. Some of the geometry adaptive ones are more difficult to use and more difficult to document well, which is why we didn't throw them out there immediately. What's the specific thing? Is there something you have in mind where?
We're printing a lot of physiological stuff, and so you end up with some really, really small features and some really, really large features, and it'd be nice to be able to like change power on the laser whenever you're printing those really small features, so you don't end up clogging them up like, say, an inner ear. Whereas, when you're printing the rest of the skull plate, you probably, don't need to be quite that fine. Maybe you want to go for the higher power for the better speed. Just kind of thoughts as I've been talking to a few of your engineers on things that might help us with getting some of these really fine features tuned in. So I was curious if they were in the pipeline anywhere, especially with the open material and the advanced settings and all these fun things coming out. So thank you.
Thanks.
This is kind of two questions, I guess. Is the print settings editor and open material model, is that like the same license that you buy for both? Or is PSC already like available for use without the
Print
license?
settings editor is free and included in Preform, available for everybody, and open materials mode is an extra charge per printer.
Gotcha. And then does the print settings editor, is that for SLS as well or just SLA?
Yep, it's for SLS as well. Yeah.
Okay.
Regarding your dashboard and fleet control, is there any plan to make that more of a local control rather than using a cloud service? Because, for example, in Aerospace, we have security concerns and we simply can't use the cloud service to do those kinds of things.
No offering for that today, but using the API, you could definitely build something like that, either yourself or if there's enough interest, we could use the same tools to develop that. So that's the idea of making this local API.
Yeah, one of the things, I'm not sure if it was clear in the talk, is that API has some functionality that connects over the internet and connects to dashboard, and some that just works with Preform. So if you're just using the local part of the API, you can build some features like that.
Just, I guess, a quick clarification. For the open materials that you guys are running, you said you can generate a file that can then be used to use that material on other printers? Did I understand that correctly?
That's correct, yeah. So you can export the settings that you've developed and share them with other people. If they want to run the material, if it's not a Formlabs material, that other printer would also need to have open materials mode. But yes, you can
That's
share
what I was going
settings.
to ask, is if you'd need open materials mode on any other printers that you'd be deploying this new setting for. All right, thank you.
The settings system is available with all printers. Open material mode lets you run a non-Formlabs material on a given printer. So any printer that you want to run a non-Formlabs material on needs open material mode.
Three short-ended questions, so they're not all long. One, would there ever be implicit format? 2, 3MF. 3, would there be a communication protocol where robots can interact with the printer?
The first question was an implicit format, or that's like exporting a scene or a setup into an implicit format, or?
Yeah, directly. Whether right now I do a lot of latticing, and when I do my intricate thing, it turns out to be gigabyte plus scale, and there's no way to reduce it without compromising its detail.
Yep.
So printer can definitely handle it. So don't want to mention other people's needs, but they adapted like implicit file format directly. And is there any roadmap for that? Because the only way to do latticing is 3D printing, and it kind of asks for it, but I don't see the option. So the second part was a 3MF, the same thread. It has more information than just
right.
coordinates. So it is necessary. is the foundation for that. Will it understand that, hey, I'm here, can you explore? Like say,
Great. So to kind of summarize, I guess, some of your questions, the first is about being able to export scenes into common formats like 3MF or other formats. Currently, API is designed for the common printing workflow of importing the models and then going to our printers. In terms of exporting the models again and using them on other software is not something that we see a lot of people using.
He's asking about, can we import implicit CAD like from Entopology or something like that, and not go through an STL mesh?
I see. Okay.
Yeah, not something we currently support. Actually, don't know of any 3D printer that supports importing in. There's some that EOS and others support slice files as an interface.
There's another one. I want to not do STL.
I see.
So far, every time we've encountered this, my response is, give us your nasty STL file and let us try to import it. And I think haven't found too many cases where we can't.
Yeah, I agree. I did that. It's just that my computer almost burned down.
It is slow to load for sure.
Yeah.
But I think that's.
I have like triple 6000 series NVIDIA card. They almost burned down. So I'm just exaggerating a little bit. Yeah. How about the communication protocol?
Yeah, so the communication, I think you asked like being able to detect the status of the printer and like do other robotics around it. I think that's definitely a use case the API can support. It can already expose features of the information, its current status. The printer does have other checks in terms of its safe operating condition, which you'd have to work around. But I think some sort of robotics would be possible. We'd have to chat more.
An API endpoint for a fuse that unlocks the door is probably something.
Oh no, that would be.
I don't know.
I
think we can do that.
Yeah, we can do that. Yeah. If it's safe, yeah.
Did it already, but I don't want to do it again. ESP32. Thank you.
Yep, thanks.
So kind of following up with him, and so you mentioned that you can support step files now, and so dealing with implicit files, I have to mesh them, so tessellate them, and then bring them in. Now they're kind of faceted. Is your step import function also like tessellating them, or do you think we're going to have like smoother features because you kind of get faceting around stuff?
Internally, Preform still has a mesh representation that it's using. So yeah, when you import those CAD files, it will tessellate them into a triangular mesh. Typically with things that are in step files, that's not a problem because you can mesh them at a very fine resolution. For those lattice type structures, those can be a little more challenging.
So I print big things that have large, long ventilation holes. They're only like 1 millimeter long, so long, thin cylinders, and they kind of get filled in sometimes. So I have to over-design them in anticipation of them shrinking. But this, boundary expansion, that would fix that, or no?
So just repeating the question is, you print long channels that you often find are filling up due to dimensional inaccuracy from this hard-to-print geometry. So the outer boundary offset will work very well for vertical channels, things in XY. If your channels are horizontal, that's much more difficult to compensate. When you expose resin to cure it, the light goes into the resin. There's nothing to stop it curing other than just how much the resin blocks it. So outer boundary offset will only really affect XY geometries, much less so than Z geometries. Does that answer your question?
Yeah.
Cool.
But yes, you can, I'm pretty sure with any of our default settings, you can improve the fine channel performance if that's all you're trying to get out of the setting, if you're willing to maybe compromise with accuracy in some other places. That's something I'd suggest email Woody and ask him for some some tips.
Yeah.
Outer boundary offset would be one.
Outer boundary offset, reducing exposure, particularly for horizontal channels, because that's kind of
Yeah.
how your finger drew it. The less exposure you can give and still get a reliable part will be very beneficial. We call this phenomena Z-bleed because you're curing more than what you ideally want. So we try and tune with that in mind, but 1 millimeter channels are a very hard to print geometry.
Wiping two ways is probably another
More
good
wiping
thing.
can be helpful. There's lots of ways to really squeak out that extra performance at the cost of other things that a lot of other users would not like to make that trade-off with.
I did work with a medical device manufacturer who had this need for some microfluidics channels, and something we did for them actually is gave them an additive for the resin that actually basically makes the resin print better at finer layers. It reduces that Z bleed. So that's something that we haven't commercialized, but it's we could if you got a specific application, we can try sending you some additive like that, and yeah.
Yes, sorry.
In that sense, for that application, how do we know to go to you for that additive?
Can you repeat the question?
I said in that instance where you just gave him an example that you used an additive in order to provide a solution, how do the general user population know to go to you for such an additive?
It's not a widely available feature right now, but come and talk to us after, and we can see. I think we can do a little bit of experimenting with it.
For SLS printing and being able to adjust all the print settings, are you able to see an increase in the properties of the material? Like if you were to increase layer height, are you seeing more strength, or is it just pretty much staying the same?
You can get better mechanical properties in SLS by fine tuning. So there's often some kind of, especially in SLS, there's a lot of trade-offs, but generally putting more laser power in and higher temperatures of the bed will improve mechanical properties, and then you may start to see other surface finish or other problems. But that is, there's definitely a lot of room for tuning for mechanical properties.
And we can go, there's places that we can go online to learn more about all that fine tuning and understanding how those different settings work, or is it just trial and error?
Right now, the documentation we have, we sort of explain directly what each knob does. We don't have all of the guides on if I wanted to increase mechanical properties, which knobs would I use? Again, I'd encourage you to come up after and can connect you with the right people who can give you some of that input. But this is part of the we're steadily releasing more documentation of these features every week or two. Great. Well, thank you all, and I guess we're on to the next section.
Go. All right, perfect. So I'm going to go ahead and get started. I am Claire Bartel. I'm a sales engineer here. Been with the company for about 8 years, so lots of talking to customers, lots of hearing about their applications and the exciting stuff that they're working on. So the topic of today's talk will be maximizing your printer ROI applications from every stage, from prototype to production. So we'll hit on a number of applications and ways that you could use your printer. Maybe you're already doing some of these. Maybe you could pick up some ideas from today. That's kind of our goal. So in terms of agenda here, we'll talk about rapid prototyping and boosting your return there. Talk about expanding your projects using the hardware that you already have. Maybe that means getting new hardware, and then rapid tooling applications, as well as some key takeaways. So to start off, what do you do when you have kind of a large product that you're making and you want to make sure that you're cutting the right tooling? I'll start out with a customer story from Ford that we just released, and I think this is a great example because they're using 3D printing to prototype all of their kind of exterior, internal components, and they're able to kind of use 3D printing to get shorter time on parts, design flexibility, kind of streamline that product development, and make sure that they are not making tooling and then realizing they'd like to make a change later. So this is a project that they did at the Ford Rapid Technology Center in Cologne, and they used Formlabs machines on the new EV Explorer. And another cool thing that they did is use the 3D printed mold to make parts out of end-use plastic. So sometimes the 3D printed material is enough, and sometimes you really need to see what would it be like if it were injection molded. So they used that here. If you'd like to check out that customer story, you can actually scan that QR code and take a look at that. But basically, we're going to look at a couple other applications here, and hopefully some of them are exciting to you, and you'd like to expand and do fun things with your printer. So the first one is silicone molding. So this one I've seen people talk about it today. The customer story in this image is a crayon company called Tinta Crayons, and they use silicone molds with 3D printed kind of positive molds to make custom beeswax crayons, and they like it because they can make whimsical designs. The printers allow design flexibility, quick turnaround times, and smooth parts. So this is something that you maybe could do with an FDM filament printer, but it's not going to give you that kind of nice surface finish of an SLA type of application. And not only can you use silicone to kind of mold on top of parts, you can also mold parts within silicone. So this is an overmolding application here. Dame Products uses these kind of molds on the outside to silicone mold hardware on the inside of their products. And I think this is a telling quote here. They say they couldn't do their job without 3D printing, and they're not sure that Dame would exist without being able to print their prototypes. That goes for products like these, and also things like this. So this is actually an air tag within a tag for a dog collar. So you could track your dog that way. And silicone overmolds are good for different durometers of silicone, more color options, and also medical grade materials. So we have a resin that is a silicone kind of resin, but if you want different options, you can get that by using molding. You can also use compressive molding. So this is an application from OXO. They actually do kind of a two-part putty and then put it into a clear mold. This is good for kind of low heat applications, and they use that to prototype gaskets on some of their shakers. That's a cocktail shaker right there. And it's nice because they can do multiple iterations, kind of change things really quickly, get those parts really quickly, and you can kind of print things, test them, go back and print, and it's a good way to get kind of different mechanical properties than you would from just necessarily, printing a part. And one last kind of story here in this section is from TU Berlin. So they are a Formula student racing team. They have about 80 to 90 people that will build cars in kind of a Formula style and race them. So the part that you see in this picture is a carbon fiber layup on a 3D printed part. And the alternative to kind of making this out of 3D printing is actually to CNC mill this out of aluminum. And that would take kind of a long time, requires specialized tools. They would have actually had to send this out. But this is a good way to get different mechanical properties on your parts. So if we look at this steering wheel right here, this is the part where they actually saved kind of $600 and 4 to 6 weeks by doing this kind of layup composite molding technique. And in terms of all these applications, it's kind of not necessarily that you will it's kind of material costs you're saving. Often you are saving material costs, but it's also kind of the time and the business impact of what having this new technology is. So if you get things faster, you can produce different products, you can kind of iterate faster, and then in the kind of end of this presentation, we'll talk about some end-use 3D printing parts as well. So one other way that you can get kind of awesome, maybe non-3D printing resin material properties is by kind of using hybrid technologies. So we'll talk a little bit about electroplating. Here is a graph of kind of the strength and tensile modulus of some materials. So you'll see we have 3D printing over on our left-hand side. We have kind of metal alloys on the top right. And I always get this question when I go to trade shows. They come up to the booth and they say, can you print metal? And right now, still no. But you'll see that gap there, and what we are able to do is fill that with coating our resins with metal materials. So we send these out to a plater and kind of tested them again, and we saw that it's a good way to bridge the gap between just 3D printing parts and then having kind of the metal part. So that opens up new options for those parts. You're not necessarily going to have to machine something out of metal until maybe the final iteration or something like that. So that opens up kind of 3 different main categories of how electroplating is going to change your parts. One is mechanical, so you'll see this kind of almost latticed cube here. That's actually about a 2-inch by 2-inch square. And what we do at trade shows is we put that out, and stand on it. So you'll see the 3D printed version there. That'll break if you stand on it. And that electroplated version will not break. So we've put kind of hundreds of pounds on that. We've handed people heavy things so they stood on it, and it still survived, which is really cool. You can also do kind of electrical and shielding applications. So we've been plating some of these. That's a copper plate. We have some white papers online for you to check out if you're interested in that. And then kind of not on the mechanical or electrical side, you can just plate things so that they look cool. So if you're making props or you're designing products, electroplating is a good way to get kind of a really unique surface finish on the parts that you have. And it's a kind of good segue into generally how we're prototyping and kind of where we are in mass production. So 3D printing, I think, is very common in the prototyping space, is accepted by the industry as a good tool. When you're not making many parts, maybe you're doing kind of concept prototypes, first prototypes, it's a really good fit there. I think it's kind of matured there. And then if we look at the mass production side of things, I think it's not as mature there. It's not as accepted by industries as a good solution for making mass production parts. Some of that is materials based, I've heard some talk about that in other talks and in workshops that we've done today, and they're definitely right. So what we are good at today is this middle section here. So similarly to the electroplating, plating parts is a good way to bridge the gap. We are able to bridge this gap with 3D printed tooling. And that means that you can do functional prototypes, maybe of end-use materials. You can do kind of pilot prototypes. We'll take a look at a story where they use 3D printed molds to do pilot studies. And then you can also do kind of limited run production or maybe customized production that way as well. So rapid tooling, as we define it, is combining 3D printed tools with traditional manufacturing processes. It enhances production by improving its flexibility, agility, scalability, and cost efficiency. And as a result, you can use 3D printing to meet business needs quickly, make affordable, low-volume production feasible for your in-house applications. And a couple of good use cases for this. I'll read out the bottom too. So functional prototypes using the final material. This is exactly what Ford was doing. So if you just need a couple parts that are maybe a thermoplastic, but you have resin printing, you can make molds and injection mold it. You can also use it to make kind of pilot production, so multiple parts, kind of try them out in your production line, see if they fit, see if they can be assembled, and then also make end-use parts. So that last one is a max strap. Maybe you have parts that aren't manufactured anymore. You can make molds to manufacture those. So the next customer story that I'll talk about is a Unilever and Serioplast Global Services story. And they are kind of a manufacturer in the fast-moving consumer goods category. So that's kind of soap, shampoo, your essentials that you'd buy in kind of a drugstore. And in that industry, it's important to be competitive because if you kind of aren't and you're not innovative and you're not adapting your product strategy, you can lose out on a lot of business. So they use some 3D printed molds to prototype this bottle for dish soap. And it's important to innovate the packaging because the design of the bottle can have an effect on the customer perception of the product inside. So it's nice to be able to put them out for pilot prototypes, get feedback, have people use them in their sink, use the soap, and make sure that it doesn't fall out of their hands and the bottle looks good. So here's some pictures of that mold being assembled and used in their blow molder. So the process they're using here, they're using this mold to kind of inflate plastic preforms and make bottles that way. So kind of cool, we had some injection molding and now we're able to have a blow molding story as well. There's some more pictures of it being assembled. So it's really being kind of put into that traditional manufacturing space and to that traditional manufacturing process. And you'll see it's nice for the 3D printed molds to have kind of a metal outside just to make sure they're pretty strong by themselves, but good to shore them up. And this process is important because they can test the material usage, the aesthetics, kind of safety and sustainability features. So they're doing some testing here, making sure everything's kind of the right weight, that it looks good, and that those products, once they cut the mold, are going to meet all the properties that they're looking for. There's another picture of that mold there. So that's actually the final mold. And if they're just making this mold from kind of computer to CNCing this, it can take months just because their design process, they have to kind of check everything and be really diligent. And what that means for ROI is that by 3D printing molds and doing pilot tests that way, you can save a ton of time and a ton of money. So if we look here, comparing the kind of machined metal mold to the 3D printed version, they did that in 2 weeks, whereas they were machining a mold in kind of 6 to 8 weeks. In terms of costs here, it is a significant cost reduction. So when they did this analysis, it was about 80 to 90% less cost. And these numbers are run on a Form 3L, so Form 4L is a little bit faster. Maybe it's a little less than 2 weeks, but cost may be about the same. And we see the same thing not only for blow molding, but also for injection molding. So if we look at this graph here, we have the same situation where maybe the 3D printed prototype is fairly cheap, maybe $5, $10 in material cost. But then if we were to go cut kind of a traditional manufacturing injection mold, that's up to $100,000 just to get that kind of made on a CNC machine out of metal. And we can fill in this gap in the middle with 3D printing. So the molds are fairly accessible. They work well for low run production. And they let you test your products and your mold itself before you kind of cut a final mold. So looking at kind of what changes when you're doing a 3D printed mold versus a metal mold, the answer is not very much. So you still have to include draft angles, kind of pay attention to how your gate is letting resin in, avoiding kind of small features and making sure that things won't break as you're injecting plastic inside. This is kind of an example of a mold here. If you want more details on that mold and kind of designing molds in general, you can scan that QR code. And this was made for mass straps that we saw earlier. And in terms of kind of how these are printed, generally we want flat on the platform. We do most of these in about 50 microns in a rigid 10K, so that is a glass-filled resin. And that is a great material because its heat deflection is 218C, so that's enough to stand up to most plastics. And you'll see that most of these are in a mold frame. That's just a good, easy way to get them into the injection molding machines, but also kind of make sure that they are getting enough kind of mechanical support on the back end if you're really pressing them together and injecting plastic inside. So in terms of kind of resins or kind of regular traditional resins, thermoplastics, we can do a number of those, pretty much all the common injection materials you can put into a 3D printed mold. In terms of injection temperature, we cut it at about 250 C, so everything that injects lower than 250 C, you get more kind of shots out of that mold, so that's maybe hundreds of parts. Anything that is an injection temperature higher than 250 C, you may get fewer, and that's just because the resin does kind of start to combust in the presence of oxygen around that temperature, so that's the one to keep in mind. Haven't tested kind of really high temperatures, but your kind of TPE, polypropylene, polyethylene, those all do really well in 3D printed molds. So if you're looking for kind of specific numbers, we have this white paper you can check out. It's basically all the process conditions that we've tested so far. So how long that cycle time was, what injection temperature it was, what we printed the mold out of, and some other good details there. So that's a good working place if you have maybe an injection molding machine, you have a printer, and you want to try this out. Now to show you a couple instances where this was used. Multiplus is a company in Shenzhen, and they have kind of serve 250 clients per year. They're a micro injection molding workshop house. This is a mold that they made. I think it's a cool example because it actually has the ejector pins that push your part out after it's molded. And they were able to get hundreds of these electronic housings out of these molds. And it's a good thing to point out too that even if you need multiple molds because maybe the mold fails after 100 parts, you can just print another one. So this part was less than $500 in material. This is the kind of build platform of Form 3. So you could, for size. And they were injecting this part out of polypropylene, ABS, polycarbonate, some other materials as well. They were getting pretty good cycle times out of this. So this is a cool kind of example. I've gotten the question whether you can do mold cores actually fairly recently. So this is a nice example for both kind of the AB side of the mold and a core in the center. So this is a threaded bottle cap that they wanted to test in its final plastic form. So they got kind of hundreds of cycles off of this one as well. This is from Novus Applications, which is an engineering and design consulting firm. And here's kind of a good schematic of those threads in there. And where it looks printed. So this is also less than $500 in material. Compare that to maybe that much or multiples of that if they were to send out a mold. And kind of one note about molds too is that you may need to sand down those surfaces, so you can kind of add a little bit of extra, sand them down, make sure they're flat, and they work really well. And the kind of last molding we'll talk about today is thermoforming and vacuum molding. So this is a pretty cool opportunity to do kind of end-use parts and use them to form sheets of plastic. So if you have a dental liner, a lot of them are formed this way. And another kind of use case that we've had in terms of user stories is actually for bath bombs. So Lush bath bombs used 3D printers to print the positive molds and then mold on top. And they noted kind of a cool benefit, which is that they don't have to send their parts out to third parties, and they like to keep all of their kind of internal IP private. So it's kind of a qualitative benefit of 3D printing, but I think it's still cool that that is something that they really appreciate, so that they don't have to share any of their designs with anybody else. And this also is a good benefit for kind of short runs of parts, custom parts, and prototyping designs. And then we can go into kind of end-use applications. So if you have a Formlabs product, there's a good chance that there is a 3D printed part on it. You'll see a number of examples here. We have the kind of turntable coupler in the Form Cure is actually a fused printed part. The resin pumping system has a number of fused printed parts. And both the 4 and 4L have tool caddies that are fused printed parts. So we definitely practice what we preach here. And we both prototype with these 3D printed materials and put them into production contexts. And the customers are doing the same thing. So this is Expector. They make kind of game cameras that attach to the outside of cars because their sensors couldn't get through a car window. And they actually use both resin and SLS printed parts for their products, which means that they're able to kind of flexibly incorporate customer feedback, able to put in a lot of design complexity that they would have to kind of tool difficult molds to get. And they can do things like lattices, intricate shapes, organic features. They kind of have full control over their product. So I think this quote is cool because they kind of think about their product like a living product. They can incorporate feedback, whether it's kind of features people want or they get a bug request, they can fix that and change their design, print out new products. And one other note about kind of printing kind of full scale, maybe production parts, is that we do have bulk discounts. So if this is something that you're interested in doing, you want to print tons and tons and tons of SLS parts or tons and tons of resin parts, often there are price breaks available. So chat with any of the sales reps here, kind of talk to us on the website. We're happy to discuss both the applications in your project and pricing that would make it feasible. So wrapping things up, some key takeaways. I hear all the time, I get on kind of calls with customers and they have tons of ideas about what they want to focus on. And I think what's the best way maybe to get, if you're looking to get someone to approve a printer, is just to focus on one project and then treat the others as bonuses for a little bit, just because it's sometimes easier to run numbers with one thing. Even if you're excited about a lot of things, just kind of focus on one. And that you should be kind of thinking of creative ideas to use your printer, and you can get better outcomes from prototyping to production by using 3D printing, whether that's kind of prototyping parts or using them for molds. And yeah, again, if you have interest in producing a lot of parts, talk to us about discounts. We can definitely give you those. Awesome. So I think the resources in the room today, if you're here, talk to each other about your ideas. If you're online, there is a forum as well as the chat in the YouTube or the video there. So put your ideas there, put them in the forum, and any formling here is happy to talk too. Thank you.
Good afternoon, everyone. Thank you for being here today and also joining our sessions on how materials are being developed at Formlabs. Oops. My name is Fiale. I am a technical program manager here at Formlabs. My primary focus is on new R&D materials for our SLA printers. I am very excited today to have a chance to give you some insights on how Formlabs bring innovative 3D printing materials to the market. And also for today, I'm also joined by Bradley High, who is the head of our compliance and regulatory team. So in the next few minutes, I will give an overview of our team and also give more insight in how Formlabs has successfully launched over 60 materials in the past 13 years. And then Bradley will dive deeper into how compliances influence the development of materials. So let's start. So right now in our portfolio, there are about 60 materials for both SLA and SLS. We are specialized in engineering materials for a variety of industrial applications. This also includes specialty materials like flame retardant, silicone, and nylon 11 carbon fiber. We also have expanded into specialty industries like medical, dental, and jewelry. And as our portfolio has grown, so has our team. The materials team at Formlabs consists of over 50 technicians, material scientists, and engineers with diverse backgrounds in chemistry, material science, mechanical engineering, and industrial engineering. Together, we work to ensure that every materials that we made are functional and compatible with our hardwares, but also are easy to use for users. So every new materials at Formlabs project begins with listening closely to our users. We gather feedbacks from users through interviews, user surveys, and an opt-in program where our users can share their printing experiences. This direct inputs help us understanding the challenges of printing and also what are the important factors that our users face in their workflow. But listening to customers is only a part of the process. We also proactively stay on top of all the advancement in the material science field and also the market trends to make sure that we are always on the forefront of the innovation. By knowing where the market is heading, we can proactively design new materials to be the next standard in the market. And with all that effort, the recent launch of us include, we have recently launched successfully a few really cool materials, the silicone 40A, alumina 4N, and our white nylon powder. During the research phase is where we form our formulation. In a particular project, we go through about 100 combinations of raw materials before we settle down on a base formulation. Early collaboration with the engineering, product, software, and compliance team help us optimize formulations for a functional and usability product. We also lean onto our loyal user base, the people who have been with us through mutable product iterations. Their real-world insights really help us redefining the product specs. In the development phase, we mainly focus on designing a seamless user experience with our software Preform, the printers, and the post-processing units. But we also understand that having an easy workflow is very important, but it's not everything. it's very important to have a quality and consistent printed part. And because of that, we spend a lot of time, effort, and resources in developing the settings and validating them for performance, print accuracy, and reliability. So for an example, for every new layer height of a new SLA material, we conduct about 100 prints over 40 printers, and we use 20 unique geometry models to evaluate them and validate the performance. And as a result, with the recent launch of Form 4, users can expect a 94% print success rate outside of the box. Similarly, we also conduct extensive testings for all of our SLS powders. And if you guys already use Formlabs users, I'm sure you are familiar with our TDS. There are a lot of information on it. I do think that is one of the more informative one out there in the market. So in the TDS, we cover most common mechanical properties using the ASTM standards, but we also provide relevant information such as swap data in different solutions or creep test, and also biocompatibility for skin contact application. All of these materials and supporting documents are continually to be tested and validated while the product remains in the market, because we want to make sure that our users have the most accurate information and have the most up-to-date workflow when they are making their decisions. And lastly, once a project passes the development phase, we will go into a scale-up manufacturing stage. We have a lot of experience in manufacturing resin and powder. Therefore, we follow all the good manufacturing practice and have rigorous quality control process to make sure that the final products meet our standard. Our users can be confident that they will receive a good performance and consistent between our production batches. We also provide comprehensive user guides, certifications, and dedicated customer support to help users bring the new materials into their current workflows. And by following all these steps, we hope that we can empower users across different industries to adopt our materials in their 3D printing journey. And for that, I will pass to Bradley to talk more about regulatory and compliances.
Thanks, Via. My name is Bradley Heil. I run our global regulatory and compliance team here at Formlabs. My team has 4 areas that we support. The first, which we won't talk about today, is our hardware compliance. So bringing all of our hardware to market through product registrations globally for safety, EMC, Wi-Fi, environmental purposes. My other 3 teams all focus on materials, and we'll dig into each of them in a bit more as we go through the slides. And that will be chemical compliance, our medical regulatory, and our materials quality. FIA did a really good job of showing the development cycle of all these materials, from ideation all the way through go to market. And my team is involved in every step along the way. What we try to do is gain early alignment so that the materials team knows what requirements we have for compliance and for regulatory, and then deliver on those through every step in the process. FIA talked about how we get some of these ideas to make new materials. Some of those actually come from us. We're scouring the global landscape. We are in regulated industries, and the regulations change a lot. So we're always looking at, is this material still allowed to be sold in that market? What's coming down the pike of new regulations that might impact what we want to do? And we feed that information back to the materials team. Through the research phase, we're looking at similar global regulations. Are all of our raw materials registered in the markets that we want to sell to? are there any specific medical requirements that we need to make sure that our materials will meet? So maybe specific properties or specific tests that we know we're going to have to pass. Once we get to the development is when we actually do all of that testing. So we're doing all of our verification, our validation. That includes both on the product side and the manufacturing side to scale up production. And then we're ready to go to market. We make sure that all of our customer-facing materials are ready, such as our safety data sheets, all of the labeling, and then doing all of those global registrations, both at the raw material level as well as our medical resins. For chemical compliance, the most important thing that we're looking at is chemical safety. We want to make sure that we are giving you good products that are safe to use and safe for our employees to use. We do a lot of printing ourselves, and I want to make sure that all of our employees are safe throughout the whole process. So part of this is making sure that we choose the right raw materials. You heard Fia say that we might go through 100 different formulations before we choose one. That's a lot of different raw materials, different combinations of those raw materials, and we want to make sure that we're choosing the right ones. So for instance, we have a policy that we're not using ACMO in any of our materials. We know that that could cause safety hazards, and it's just our bottom line, we're not using it. We will communicate all of our safety issues if there are any, and that comes through the SDS and through the labels. Like I talked about, those are go-to-market deliverables that we provide that will tell you all the specific precautions that you need to know about for using our materials. We also handle all of those geographic registrations and following up on all the regulations in all the different markets that we want to sell to. Fia talked about some of the information that you might find on our technical data sheet, some of the basic mechanical testing. There are also times where we may choose to go above and beyond that and choose some specific material properties that we want to test. Maybe some of the elastomeric materials might have some additional testing that we do, or we might have something special that we want to do. So think of premium teeth. Color is very important to premium teeth. So we're doing specific validations to make sure that we can always hit the same color out of our manufacturing line. But we're also thinking about it from the user standpoint. So we've also done additional testing like putting it in coffee and seeing if it would stain coffee, or red wine. So yes, if you are printing with premium teeth, you can definitely enjoy a cab later at the happy hour. It won't stain your teeth because we've done that testing to make sure. In the medical side, we do a lot for the next two, so biocompatibility and sterilization. Our portfolio has a wide range of biocompatible endpoints with different materials, whether that's long-term skin contact, short-term mucosal membrane contact, and it's not just our biomed materials. We also go and do some testing on additional materials that also have some of those properties. Same for sterilization. We want to make sure for medical customers that might sterilize their products that we have modalities that they can use, so we test to make sure that specific sterilization modalities won't impact biocomp, won't impact the mechanical properties of those materials. And we also do some special certifications. The one that jumps to mind is our flame retardant resin. If you've been here, you've probably heard a couple people talk about it already. So it has a UL Blue card. That's the special certification. So it is tested to make sure that it actually meets the standards of the test. But every quarter, they also come and test the quality of the material to make sure that it'll still hit those same properties time after time after time. And speaking of quality, I want to jump into our material quality team. So we make all of our Formlabs resins in the US at our plant in Ohio, and that's where we have our quality team dedicated to that plant and to making sure that we're always producing good resin. And they're involved in quality throughout the entire manufacturing process. So making sure that we have approved raw material suppliers, from checking the raw materials as they come in, and then even in production, in line quality. So making sure that the right resin's going into the right cartridge, or that we have the right label on the right cartridge, and then we're filling it to the right level. And the one that's most important, I think, for me, is making sure that the materials actually meet spec. So we have a really robust quality control system to test every single lot of resin that we produce, and we wouldn't ship any lot if it doesn't meet our spec. On our biomed side and our medical device side, we also have an ISO 13485 quality management system. We produce all of those materials in an ISO Class 8 clean room. Just also want to call out that this certificate doesn't cover just the manufacturing. It actually covers the entire life cycle that we've already talked about for these biomed and medical device resins. So documenting every step along the development process, having specific procedures on how we handle it, how we manufacture, how we test, and documenting that we've done everything that we say that we're going to do. From the regulatory side, it's broken up into two things. So first, how many people knew that Formlabs makes medical devices? Raise your hand. All right, so this is a medical session, so maybe some of you, my part of this is medical, so maybe some of you knew that. For those online, a couple hands went up, maybe some of the dentists in the room too. But we do make medical devices in the dental space, and those are very highly regulated around the world. So we have to make sure that we register those materials in every market that we want to sell them. From the biomed side, what we do is we work with FDA, and we have master files. So what a master file is we provide all of our data, confidential, proprietary data, to FDA. And this process allows it to share it confidentially, where you can then reference it in your submissions to FDA, whether that's a 510K, PMA. If you're using Biomed Clear, Biomed Durable, Biomed White, or Biomed Black to submit a medical device to FDA, we can write you an authorization letter that allows FDA to look at our confidential data in your submission. And what we found for several customers that have utilized this approach is that we can save them some time and money on biocompatibility testing, where they've actually been able to leverage our testing in their submission. So we have those 4 today, and before the end of the year, we'll have 2 more for Biomed Elastic and for Biomed Flex. So Fia, I'd like to call you back up on stage. Got a couple questions for you. We've talked about this entire development process, and we've talked about how we've done 60+ materials over the last 13 years. What has been your favorite material to bring to market?
Thanks, Bradley, for very difficult questions. It's really hard to choose one particular project, like a favorite project from all the projects that we have developed, because each project has their own challenges and new learning opportunities. Also, because most of our team, we work on the project from start to finish, so obviously we will have some attachment to our materials. But there are a few that stand out to me, so I would like to list them. The first one would be silicone 40A resin. So if you guys, some of you may already know, it's really difficult to make a silicone 3D printing materials. This is actually the very first accessible 100% silicone 3D printing material out there. When I mean accessible by have a good printability, actually have a good, can be used for functional parts. The silicone team faced a lot of challenges when they developed the materials, from chemical availabilities and chemistry limitations. But obviously, we passed that. So after almost 2 years of development, we were able to develop a silicone 3D printing material that still maintained the usability and printability that Formlabs is known for. And it was a very rewarding process, because it's opened up a lot of opportunities in soft touch like materials for industry like medical device or consumer. The second one would be the general purpose 5th generation, or also known as GPV5. It was a very interesting project to do, because it's very rare that we have an experience. We have an opportunity to develop a material along with hardware development. The goal of it was that we can leverage the technology on both the material side and the hardware side, and to make something better. But as we all know, the more team get involved, the more people get involved, things got more complicated. So there was a lot of challenges, but we learned. We learned how to work better with our team. We learned how to make better product, and I think we had a great result after the launch. And I think the third one I would like to mention is Formlabs washing solution. So this is not a typical materials development project, but it is still a Formlabs proprietary formulations. So we're still going through the very typical materials R&D steps, as mentioned earlier. And it was very rewarding to get such a quick positive feedback from both our internal and external users. And most importantly, after all these years, we're finally able to provide a solution that is non-flammable solvent, but still maintaining the washing efficacy that people are familiar with IPA. So what about you, Bradley? What are the challenges that you think of materials development?
Yeah, if I think about it from my team's standpoint, a lot of what we do is in a regulated industry. So we have the chemical regulation piece of it. We have, again, some of the medical stuff that we're dealing with in the medical regulations, but also our customers are in a lot of the same types of industries, whether that's medical, dental, aerospace, government, like lots of restrictions, and keeping on top of all those changes and being able to meet those globally is kind of the challenge. And making sure that, you know, the regulation over here is different than this country, and we got to make sure that we're specific over here for that country. So I think that's the biggest challenge. One is that it is a global scope in regulated industries, and those regulations are always changing. We talked about this development cycle. I know we recently launched some resins that are not used on our printers. Can you say what that development cycle looked like? Was it the same as what we would do for developing material on our own printers?
Yeah, sure. So I believe you are talking about the Formlabs Creator Series. For those who don't know about it, it is Formlabs research and developed formulations, but being developed for other printers, other resin printers, and it's currently being sold through Amazon. So honestly, the whole process of the project is not really different from how we have always been doing it. We identify a need for a well-balanced properties materials, but also still safe for our users, especially for users who already acquired other resins printing setup. So because of that, we decided to make two formulations, the super clear and tough, because we believe this would cover most of the applications within this market segments. And in case that you don't know, we also recently we recently made the settings and validated the setting for TUF 2000 and GBV5, also for other resin printers. Again, we follow the same step of making the setting, validating, using different kind of models, a lot of printers. Actually, we made a print farm here in TC for this project. And because we want to make sure that no matter what setup you have, if you are using Formlabs resin, you should experience the same ease of use and the quality that you usually get from Formlabs materials. Last questions. Just our curiosity, I know a lot of people here are familiar with medical devices, but what do our users usually want to know about compliances?
All right, so I think I get two questions the most. The first is, can I get an SDS? So yes, we will always give you an SDS, but they're also on our website under the materials catalog, and you can get them yourself. They come in all the jurisdictions and all the languages, so you actually don't have to ask me for those. So next year when FIA asks me this question, I hope I don't have to give that answer. But we're always happy to provide them. They're just there for you if you already need them. And the second one would be about biocompatibility. We get asked a lot about, like, can we see your data? What do you have available? So what we do is we write what we call biocomp cert. So each of our materials that have biocomp testing, we will write a certificate that says, here's the material, here's the endpoints that we tested, showing that everything passed, sign off. And that's what we would give to kind of show the confidence that we've done all of the due diligence from our side. We have all the testing. And again, if you're going to submit something with FDA, we could also give you the authorization letter to reference that in your master file. So I think that's all we had today. Thanks for sitting in on our session. Feel free to stick around for the next session to see how you can kind of push additive manufacturing within your own company. Thank you.
Hey, look at that. We pulled it off.
Well
Nice.
done, well
Look at that.
done.
We're in the right order.
Yeah, all right. Victory in the very beginning. I like it. So if you're in the sound of my voice, come on over to the main stage. We're gonna have a great fun conversation here. So welcome everybody who's here in Massachusetts, everybody who's logging in from online. Thank you very much. It's been a great session. We've had lots of conversations on tips, tricks, behind the scenes, talking about materials, software, best practices. We want to kind of change up the tempo a tiny bit and have a conversation about your careers and talking a little bit about how do we utilize all the stuff that we've been discussing and learning to bring it back home, bring it back to our companies, and try to help increase the overall adoption of 3D printing. And I'm joined by some really, really great people here. So I've got Kat from Peloton. Thank you very much. I've got Ago. You guys saw him earlier today for Radio Flyer. And Patrick from Hasbro. So let me just start this off real quickly. And I'm going to start with you, Kat, just because you're kind of closer here. So you've done a whole lot with women in 3D printing. And we had some earlier conversations before we even sat down to have this. One of the things I really liked about your approach is you kind of take a devil's advocate approach to bringing additive manufacturing into your business sectors. Can I introduce a little bit about kind of what you do and kind of how you got into additive inside Peloton?
Absolutely. So my background is in fine arts, specifically sculpture. And I find that the most powerful thing about learning, working with your hands, working in 3D, is understanding how materials crumble, how they build, and all that. And so how I got into additive was realizing that it's a form of sculpture, it's a form of craft, and Peloton is really supportive in a diverse skill set. And so being able to bring that skill to the prototype team there, I can help with product development and innovation in ways that maybe somebody with a more traditional background can't.
Okay. So what sort of traditional methodologies do you think you've run into the most often that you've been able to kind of replace with additive?
Well, there's the classic blue foam. Everyone loves the mess that it makes, and everyone loves carving it and melting it. But I think that that's a really valuable skill to still preserve, especially when you're trying to compare what additive can do in terms of just the difference in time spent crafting, time spent iterating, and being able to take things from idea to the next iteration. Blue foam is still really valuable because it teaches people to think in 3D, whereas CAD might trick people into feeling a little more comfortable.
Okay. Ago, you had mentioned, and one of the things I want to highlight here is coming from Radio Flyer, you're coming from a real incumbent company, right? A company that was founded back in 1917. Mm-hmm. It's a lot of status quo as far as a manufacturing process, and there's a lot of really big innovations you guys have done over the past couple of decades. But when we're talking about adopting additive as a new method of manufacturing, have you run into any sort of hurdles or stopgaps or kind of the ain't broke, don't fix it mentality?
Yeah, absolutely. I think our prototype shop is super capable. We have CNC, PolyJet, FDM in-house, and there was kind of an incumbent of, this is how we've done it, this is how we do it. And when I joined Radio Flyer, I was like, hey, there's some pain points here. This takes a little while if we're outsourcing SLS parts or SLA parts, and the cost is pretty high. These are really valuable technologies. So in that case, I put together a pitch to kind of sell those concepts in, both from a cost and a time standpoint, and that has really helped me overcome some of those maybe more traditional incumbent challenges, and that was really effective in my case.
What were some of the things that you felt you had to kind of bring to light with some of the executive teams or kind of like the champions in order to get them to kind of say, hey, this is worth us spending some time, some energy, some resources in?
It was really data-driven, so comparing the parts that we were getting out of the SLS or the SLA machines respectively against our production parts and the capabilities that they had. So it was Gardner impact, it was printing parts and doing treadmill testing. It was all of our internal design requirements that we would put our injection molding parts through, putting the 3D printed parts through and saying like, hey, look at the stuff that we could be doing and saving us, tooling modifications later down the line or things like that.
That's awesome. Okay. And then Patrick, just kind of picking on you for a little bit here. So if anybody doesn't know Patrick and what he's done over Hasbro, you had actually gotten our Impact Award a couple of years ago for your work on the Selfie series, which was kind of a mass customization project.
Yeah.
And I think coming from another side of this, right, you're coming from a company that is very heavily injection molded focused, wide range of components and parts and things along those lines. Can you kind of walk us through some of the journey of how did that Selfie series that you had worked on come to fruition? Was there an executive champion, or was it something that you guys came to them and said, hey, here's something we could possibly do? What was that journey kind of like?
Got it. Great question. So, much the same as Cat and Otto, people are always interested in what we do, 3D printing, and how we bring a product to life, right? And so one of the things I would always say is never shy away from tours. We always tour people, because if you can demystify what you do, then when you start explaining it in numbers, people start getting it. So a few years back, we used to make one-off figures for any executive that would come, so from Disney or another one of our partners. And so we do it the traditional way. It would take us a couple weeks maybe to make that figure. And so my manager at the time was like, oh, wouldn't it be great if we could do that and do it in real time so we could give it to them before they leave? And so we sort of set our sights on that. And so from that moment, then it became all of a sudden this, hey, how do we create this into a product or, for the masses? And sort of that's what kicked it off. And of course there, again, to kind of loop it back to the ROI, we had to sort of compete against what injection molding and sort of what our normal sort of mindset was for how we cost things out. And so comparing it to, instead of the initial huge investment that you have in a steel, sort of the time and the materials, right? And so we tried to automate as much as we could, work with certainly Formlabs to kind of get the cost of materials to a place, the automation to a point that it actually could compete against injection molding. It was actually cheaper in the end.
So it was actually cheaper to print it than to mold it?
Yep, exactly. So our parts were actually cheaper than the injection molded bodies that we were placing our sort of custom pieces on, and we were making one of ones. So.
And so just so I'm aware, so you're talking like taking the cost of the molds and the tooling and the machinery and the raw material and amortizing that down to the individual figure was less expensive, or was less expensive from just a raw material standpoint?
No, it was less expensive overall, yeah. So especially when you start looking at the numbers, right? Obviously if you're making $1 million, $2 million, $3 million, hard to compete against. When you start talking about 50,000 to 100,000, it's much more competitive, and the numbers worked in our favor.
Okay. And so in that scenario, it sounds like there was some executive kind of sponsorship of the initiative.
Yeah, exactly.
Have you guys run into situations where you feel like you've got to carry some of the front load, where you kind of have to go to a decision maker or an internal champion of some sort and kind of say, hey, here's a place that we could potentially consider using additive?
Yeah, I mean, in my case, it was that set of slide decks with the ROI of, these are our current material costs. This is the current lease payment on our existing printers. Going to Formlabs is this cost saving. This is the dollar value associated. So that's what that setting was with kind of the executives at Radio Flyer.
So for you, it was really much an ROI kind of conversation. It was
Absolutely.
The dollars and cents?
Yes.
Okay. How easy is that for you guys to get and to kind of put together? Is it something that you find you have to do on a regular basis, or is it something that you had to get a little creative, get some assistance from the organization?
I like to document as I go. So for example, rather than looking forward and hypothetically putting together an ROI, I like to document what we've done. And I like to document, okay, this is how long it took to get this project done, and then you have some data to compare against when you do want to make that pitch. You do want to come with a story that not only makes sense for the narrative that you're trying to pitch to an executive or just even your own manager. You want to also come with data, hard facts, and scenarios that you've all witnessed and be able to say, this could have been improved because I'm pitching this idea.
Okay. So, and we talked a tiny bit about this earlier, that I really believe that this is a new age in additive manufacturing. Over the last 3 years, we've kind of seen a reemergence of interest in it. There's been some new products in the FDM space and the commodities spaces, but it's become much more exciting for executives now and for just everybody in general. Materials are getting better. I mean, Formlabs, we just reduced cost on materials, releasing faster machines. If you guys had the ability to go to today and you had to start your kind of additive teams and additive departments over again, what would you do? Is there anything that you would change? Is there any initial, like for those who are joining us, especially from home and want to expand the additive environment in their organization, where's a good place to start?
Yeah, so I would look at it a little bit differently. So previously, years ago, the cost of entry into 3D printing was so expensive, right? Large format printers, you were in, and typically you were stuck with one resin that you loaded the machine with. And that was great for larger companies. If you were a smaller company, though, you just can't be that flexible, right? And so I think Formlabs has obviously taken down that barrier, and then the materials alone have kind of freed that up so that there is a right material for whatever project you're looking for, ease of swapping the materials, and then obviously the speed with the 4, right? And so for me, I think it would be much easier to justify these days starting small with a Formlabs printer. You can, you don't need a lot of infrastructure to support that build. And then the usability, right? You don't need a ton of training. So you can, the ramp up and the startup is so, you have success right out of the bat.
I'd say that the only thing that I would really recommend, especially teams that are outfitting a shop for the first time, is to consult your experts first, because not every, even if it's the best tool in the market, not every tool is great for that team's projects or that team's intentions and goals. So asking your experts what they like to use to achieve the business goals will actually have better ROI and also just a stronger business impact.
Yeah, in addition to asking the experts, I think really leaning on your core users to understand what they need from the machine. So in my case, it was printing identical parts and saying, here's A, here's B, here's your kind of confidence building tool to kind of sell this machine or sell the value that this machine would bring to our space and to our workflow.
What's kind of your opinion if you're starting up an additive environment into what types of equipment to look into, right? There's a huge landscape, and you kind of mentioned there's some of those multi-$100,000 pieces of equipment. There's some consumer-grade pieces of equipment. There's a whole gambit of different technologies. How do you decide where to invest the time and money, the resources, the energy?
I mean, there's experts like you on sales teams for equipment manufacturers.
That wasn't a lab question, trust me.
That was good, though.
But there are people that aren't always just trying to sell you a product. They're also trying to match you to the best product, right? And so I say ask questions. I mean, I ask too many questions sometimes, and I just feel like you're never gonna find the answer you're looking for just by sitting around and like scratching your head. So ask questions, check out user groups, check out forums, and see how people are using something, and see what the support system is. Because sometimes if you get something that is really expensive and is very closed loop, you actually run out of support when you're looking for something specific.
I think that's really smart. And everyone's willing to help you out, right? If you ask the right questions, most companies are willing to make you a test part. They're willing to work with you. There's a lot of tech that I really like that we don't have in our department. Just because it's cool doesn't mean we need to implement it. So it has to make sense. So I think you're right. Doing your homework, asking questions is huge.
So let's, now that we've got a time period where there's a lot more of excitement adding into the additive space, we talked a little bit about some of the incumbent issues. There's another type of person that I run into, and I hear customers talk about this as a challenge all the time, so I'd like to get your opinion on it. And I kind of call it like the science fiction addict. It's the executive or the leadership person or a champion or whoever who comes in and says, oh, I saw this thing on the news, this person's 3D printing and insert some really high-end, very hyper-specific thing that would take forever to kind of get to. How would you guys approach those sorts of situations so you don't crush the dream, but still bring them back to reality?
So for us at Radio Flyer, one of the things we like to say a lot is we have a very yes I can mindset. So that's very likely something that we would use in this scenario where we'd say, sure, here's how we could do it. Here are the obstacles we might encounter or the costs associated, and really try and get buy-in from there on, is this something we should keep doing before kind of going full bore in, but basically do the homework, collect the data, say, yep, we can do it. This is how we would go about doing that. Go. If the answer is yes, then fantastic, we'll go for it. If not, maybe find alternative solutions to get there or get close to there creatively.
I think the alternative solutions is the key phrase there, because there are a lot of ways to do pretty much everything. And so if somebody's really excited about one way to do it, something that they saw, being able to demonstrate like, oh, we can achieve that with other tools or with other techniques, or even just showing that like you might not even need that thing, you just are looking for a certain goal or result out of that thing. So finding out what the core request is sometimes is enough.
Well, you had mentioned something to me earlier, and this is where I kind of appreciated your devil's advocate approach to these sort of situations, where there's times where you'll come back and honestly say, well, you could probably make it without it being additive. And you've found some success in kind of saying, oh, but there are actually other methods to manufacture this same thing. It doesn't have to be additive, and not trying to square peg round hole yourself.
Yeah, for sure. I mean, I love 3D printing. I love additive. It is, I'm known to all my friends as, that is what I do. That is what I think about.
You're the 3D printing girl?
I'm the 3D printing girl. And I love that. But I also love to manage expectations and say 3D printing is not magic. It will never be magic. It is a science. It is a very logical science. And if you want magic, say the words.
Talk to a wizard.
Yeah, say the word and we'll give you a part. But that doesn't mean it's going to be 3D printed. I'm going to give you what you asked for in the best way possible. It doesn't mean it's going to be 3D printed.
Do you guys find that sometimes that's also helpful, setting realistic expectations early on?
Yeah, absolutely. Yeah. I think you have to be realistic because, like I said before, one tool, one technology doesn't do everything, right? So you got to have the right technology, whether it's blue foam early on or whether it's additive manufacturing in a production setting, right? And so the one thing that I do like that has disrupted the space is if you think about it from early concept to production, now additive manufacturing fills that entire space. There is a technology, there is a way to get there. It's about choosing the right program and technology that fits your need, though, and not just jumping in because it's the latest thing someone saw on CNN,
Yeah, it's the entire industry has been a really interesting one. We've had a lot of new impact, a lot of new people jumping in and trying to expand where they are. Have you guys found any specific ways to gain a champion inside your organization?
I like to demonstrate that 3D printing is both an educational tool, a team building tool, skill building, as well as morale boosting. I love it when people come and visit the 3D printing lab because they're always so fueled with passion, and then they take that passion back to their work. So for example, at Peloton, someone from the studios or someone flying in from one of our remote offices could come into the lab for a tour and be really excited about 3D printing all of a sudden when they didn't even know that we had it. And being able to say, yeah, what does your team need? We would love to support you guys. It builds that fire and it builds that team structure and helps them do their work even if it's totally tangential to hardware at all.
Are you guys doing any sort of activities or promotions to get people to come to your setups and your labs?
Absolutely. It's part of every tour through the office. Anybody in any department, if they come through the office, we give them a tour of the prototype shop, talk about the printers. Even for events like Take Our Kids to Work Day, we're exploring opportunities to print little trinkets or kind of teach the kids about the printers, how they work, why we use them, how we use them, put on little educational mini sessions. So we've done things like that in the past, and that's been really engaging for the kids because you see that spark in their eye. When they get excited, but yes, we use it.
Kids alone, I enjoy getting to tour printing facilities. I get a little spark in my eye.
Yeah, we do the same things. We have everything from sort of elementary on up through college, through the department, and STEM. It's so important and it encourages people, and you can help point them in the right direction for a career path as well.
Do you do some of those events also with not just students, but also coworkers?
Mm-hmm. Yep.
Yeah,
absolutely.
Peloton hosts an internal hackathon, which is
okay, that's cool.
Yeah, which is a great, and I know a lot of companies do this, but what's really exciting for me to see is somebody who doesn't have a hardware background or doesn't work on any of the hardware. They have a hardware idea and they want to see it come to life. So they have that childlike spark when they're actually in marketing, and it it just brings everyone together and like really champions what we do as a company.
Yeah, at Formlabs, we have a hackathon that we do every year as well, and it's a really good occasion to have people intermix, and it's an opportunity to kind of stretch your understanding and your boundaries and what you think is possible, and it's a lot of fun, so I'm glad to hear you guys do that. Now, here's a question that we discuss a lot internally, and I'm kind of curious for your opinions on this. What do you think about using printers to do kind of knick-knack, trinket, toys, little giveaways, promo things, give them to the execs or something like that? What's your opinion on that versus using them only for dedicated production processes?
I think all three of us would say we do them, right? They're fun to make, right? And you can have fun, and you want to showcase what the department it can do, right? And so, they always seem to come at the wrong time sometimes, right? You're busy, you're flat out, and you're like, okay, yeah. But overall, it represents the department. When you walk somewhere and you see that on an executive's desk or somebody that did something and was recognized, and you're like, oh, yeah, we made that. So it's kind of cool.
Yeah, I think similarly, we do the same thing. It's a vessel for the culture of the company. If it's a show of gratitude, we have our golden wagons or things that one flyer gives to another flyer. It's like, hey, thanks for doing this for me. I really appreciate it. So we have little internal mechanisms like that I think 3D printing serves an effective and reasonable use case for to really kind of lift everyone up and kind of act as a benefit to the culture.
It also supports our ERGs at Peloton too. The employee resource groups are a valuable part of our culture and our diverse support network. And so we have, advocates for 3D printing within those ERGs who, utilize the 3D printing that we use for work also to support that and celebrate the diversity of the company.
And you guys have found that you think that these sort of things, have they generated more interest into what you do? Do you give them to somebody and they kind of go, oh, wait, we did this here? I didn't even know we could.
Yeah, absolutely.
Okay. I think that's kind of fun, right? A lot of people have said, oh, well, we've got to keep this a little more limited, but opening it up does generally create more interest, excitement. So it's definitely an interesting conversation piece about how do you utilize production equipment effectively. So one of the other questions that I really kind of want to know, if you had to start with one Formlabs material, that would be a good place to start in bringing a material or bringing additive to a company. And I didn't ask them this one ahead of time. They have no preparation at all on this guy. Where would you start?
My answer is easy. It's the SLS PA12. It's what we use. It works for our designers. It works for our engineers. Everyone loves it. Everyone's happy with it.
Not what I was expecting to hear. That's awesome.
Yeah, that's what we did. That's the first machine we brought on board. So.
Well, my follow-up question is, who's asking?
Ooh.
Is it a designer? Because then I'm going to say gray. Love gray. Specifically the Gray Pro, because it's got a little bit of both. But the engineers, I would say tough 2000.
Okay. Yeah, we're tough 1500, everyday resin.
Okay. We've got the tough 1500, the 2000, and my personal favorite, durable. I've actually even got it on my lanyard here. Are all back in the torture testing room, right? From the engineering standpoint. So I agree with all that. Though I like the nylon 12 answer. That's definitely an interesting take on it. So I guess as we're wrapping up here, I've got enough time for just one more question. If you had to start with one project at your organization that would be a good springboard, what would you kind of go back to your organizations or something you could recommend to everybody who's watching as start here? Here's a place to kind of use this buzzword or this location in the facility to try to start the additive journey. And I'll answer it for myself to start off here. So I come from a background of metrology, And one of the biggest hurdles has always been generating fixtures for things like CMM machines and measurement systems and stuff like that. There's an infinite array of geometries on parts and a limited way to hold them. And so I've always thought that's a great place to get started.
Well, for me, I used to teach STEM to kids, and one of my favorite things to get them involved was printing something that didn't need supports, because then it really teaches you about the physicality of whatever material you're using. So designing something and then designing your own supports for them was a great project to learn from scratch.
Okay, yeah, it's a good one.
Yeah, I think within our organization, it's really just, again, tying it back to that A/B testing, picking an existing product, saying, hey, here's an improvement we want to make, here's a proposed design solution, here's the original in the injection molded material, here's the printed identical part, and then here's the improvement, and then really showing like, hey, we can do this work without the traditional approach we may have taken in the past.
So if I can concentrate that one down a little bit, it's kind of keep your eyes open for an opportunity to reinvent an older method of doing something.
Exactly.
Okay.
Yeah. I would say breadboards, right? For us, we do a lot of iterative design. So, a nice thing about doing, if you do a breadboard, is you do that iterative design. People can see how quickly you can kind of go from, ooh, that didn't quite work. If I make this change and this change, I can print another one overnight or in a couple hours, and then put that back together. And then everybody starts connecting the dots on, wow, all right, I see the advantage of that tech.
I'm going to have a longer conversation with you on that one. That's actually really interesting. All right, unfortunately, we are out of time. So it goes that quickly, but I did want to say thank you so much, Pat, Ago, Kat. Really appreciate it. You guys are just leading the way in additive. So thank you very much for joining us. Stick around. We got more to come.
Thank you.
All right, just like that, it comes to an end. This is such a sad part, but we must move on. I hope that we fulfilled our promise for both information and inspiration. There were so many great sessions. Let's give one more round of applause for all the speakers, the panelists, the presenters. Everyone did an amazing job. For our online audience, this is a reminder that coming up in just like 2 minutes, you will get prompted to watch that Form 4 teardown with Shane Whiten. It is going to be awesome. Please watch that. For everyone here in the crowd, you can find it on our YouTube channel as soon as you wrap up your day here. But to wrap up your day here, there is go to the expo area, there's cocktails and there's snacks, and I thank you all for coming. It's brave to come to Boston in November, and I really appreciate it. Thank you, everybody.